Welcome everyone to Emergent Futures V1.0. In this webinar, we're looking at a unique blend of AI and 3D and parametric computational modeling. So should be a very interesting kind of workflow there from Alec. Um, Looking at things like Rhino and Blender and Comfy and Midjourney and ChatGPT and Gemini. Um, and your tutor here today is Albert Sumin or Alec, who is a member at Morphine and a senior architect at Cloud Corporation. Alec Sumin is a senior architect at Cloud Corporation, Vienna, Austria, computational designer, university lecturer, BIM specialist, and Autodesk expert elite alumni. So welcome, Albert. We're so happy to have you again returning, and we'll pass it to you.
Okay, yeah, let's start. I will share my screen and I suppose we can check some stuff. Yeah, there is a question about the certificate. I don't really know, but
Yeah, it'll be
yeah,
fine. Yeah.
okay. So let's start with the webinar.
Yeah. I just approved WoW. So you might have to click share again.
Okay. Yeah, it's working. Yeah, wait a second.
Perfect. You see it.
So first of all, I already shared this link to the Google Drive. I'm gonna use it to share some steps and files which we will need during these two sessions. So we will start today and finish tomorrow evening. So basically, there are some files which we will use during these days, and I already put some there. So first of all, it's Rhino settings and also some files for Rhino and ComfyUI. These two folders you don't need exactly right now. I will show you later when we gonna use it, but you can already download them. And the Rhino settings, it's what we need like immediately. And there are several settings here. It's a template for Grasshopper, display modes, and window layouts. I would say if you advanced user of Rhino, you probably have your own settings. In this case, you don't need mine. You will figure out how to set up some things by yourself. It's not a big deal. But if you're a newcomer, so I would recommend to download all these settings and use them, because in this case, you will have totally the same user interface as I have, and it will be just easier for you to follow all these workflows and different stuff I will show. So, and I also, when you download them, I also show how to implement these things to Rhino. So let me reorganize a little bit Zoom interface. Mm. Yeah. Okay. So this is about files, and also in addition, we would need a few Grasshopper plugins. It's first of all Weaverbird. I probably copy the link just in case to our Zoom chat. And using this link, you can download Weaverbird. We need this version, so for Rhino 6, 7, or 8. And this is too old for us because this version, you can, of course, download it if you have Rhino 5, for example, but Rhino 5 is not good enough for this workshop because there is no subd tool there, and we will use it. And so this is the first plugin. It's quite simple. You just download the file and drag and drop it to your Grasshopper canvas, and you will have this plugin. This one way. Another way, just use Package Manager in Rhino. I quickly show you how to do it in command line. If you already launched Rhino, you can just type Package Manager like that, and here you can search Weaverbird and just install it. maybe it will be easier. But this way is not perfect in case you have several versions of Rhino on your computer, because it's only installed for open Rhino. And for example, I have Rhino 7, Rhino 8, and Rhino 5 simultaneously. So better to just download the file in this case, because you will install Weaverbird for all your versions in the same time. Then we will need Dendro. Also, I will copy a link for you. This is Food for Rhino, and Food for Rhino is like a common place for most of the plugins for Grasshopper. And you can search a lot of plugins here and just download them. Basically, if you never use it, you scroll down and here are some versions. If you use Mac, for example, you can download this file. If you on Windows, probably better to use the last version, so Dendro version 1.0. Download it, and here is should be somewhere installation process. Yeah, here is the instruction, and basically the files probably has this PDF file with the instructions, but it's the same as for every Grasshopper plugins. You just either drag and drop it to Canvas or put the files to the components folder. And this is also the way I will show you later where is the folder. And the last plugin we need is Nuclei. Also, I will copy the link for you. Probably last, maybe I use something else, but these are main things we will need for sure. If I will understand we will need something else, I will provide for you another link. But basically these three, Nuclei, Dendro, and Weaverbird, it's good for us for starting, let's say. So just download them, and we can start afterwards. Second. Okay. My dog use a moment to steal something while I'm providing webinar. Okay, so we have these files. You already download things, and also I can show you how to use other stuff we will have here. So it's display modes, window layout, and templates. And basically, if you're in Rhino, you can go to the settings right here. It's options button, or you can just type options in command line. And you can go to the view and display modes. So then you can import these files I have there. So I, for example, have it somewhere on my computer. So you can download it to any folder, basically. In my case, I, for example, have Rhino settings, display modes, right here. Yeah. And these parts I need. So basically, I put it here. And it's working one by one. So if you need just one display mode, you can pick it and open it. But if you need a few of them, it's not possible, unfortunately, to just select all of them simultaneously and load. So you need to go one by one. For example, I need shaded mode. I open it. In case this mode already exists, and shaded is the standard mode, that's why you already have it. It will suggest you to replace it. And of course, you need to put yes, and you will have this new shaded mode. It's not a big difference from the standard one. The main difference here, what I have in the shaded mode, so to switch to the shaded, you go to this small arrow and go and pick the shaded. The difference here is visible the side of the surfaces, or mesh, or sub-D, doesn't matter. And this is important because we will use Grasshopper, and Grasshopper mostly use the face side of the surface. and not the backside, let's say, of it. And when it's visible in Rhino, it's quite handful, I would say. So you always can understand where is the side of the surface which Grasshopper gonna use to, for example, populate a pattern, or um, when we export it to Blender or to 3ds Max or to other softwares for rendering, where is the face for placing materials, etc. So for us, it will be important in both cases because we going to use Grasshopper, and also we will export our final geometry to Blender to make renders. So for both these cases, it's important for us to understand where is the main side of the one or another surface. And this is the main difference of this shaded mode, which I have. Probably I also have some settings for curves there to make it thicker, but I'm not quite sure. So other modes are also about some small changes and tweaks for graphical stuff. And basically, of course, you can just change all these settings manually. If you go to this view display mode and go to shaded, you will see a lot of settings inside. And you can change all of them or some of them, depends on your wishes. But it will, to cover all of them, we will need a couple of hours, I suppose, maybe even more. That's why I just prepare ready-made display modes for you. It will be easier for us. So, and then you can easily switch between one and another mode. If you have an object in the scene and you go, for example, to wireframe, you will see it in one way, to shade it another way. And for example, if you go to the pen mode, you will see it like that. So basically, all of them just represent your objects differently. And this will be important for us in some cases for making screenshots to provide AI renders, for example, or just to represent our diagrams, or just for working. Sometimes it's easier to have some features like size of the surface or thickness of the curve in the specific mode. So this is one thing. Once again, you go to options, you go to the view, it's like that, and you go to display mode, and then you use import button and import modes you need one by one. I'm gonna use during this session basically shaded mode, wireframe mode, also thick curves probably I would need, and I think technical mode also I would need, and ghosted. So ghosted mode also will be useful for us in this one. So, or you can just load all of them. So it's up to you. This one thing. Another one thing is interface itself. You probably have another layout where your window is located, how these panels divided, and which panels you have right here. So to load the interface I have, you can go to New in version 8, and there is a button here, Manage Your Window Layout. And then you can open layout I provided. It's located in the window layouts folder, this one. Just open it. You will see, I think this is the name, but maybe it's another name. I just didn't check actually. Can I check again? Yeah, here's this name. And just double click on it and your layout will be almost the same as mine. And you will see all these panels and some properties. I'm not 100% sure it's totally the same because I've saved it a few months ago, and maybe since that I already changed something, but basically it should be almost the same. So maybe some small things it could be different. And on top of it, we will need also Grasshopper template. If you launch Grasshopper, is this button right here, or you can just type Grasshopper in your command line. You will see this interface, and you can go to the file, then preferences, and here you can go to files as well. And this is the path to your Grasshopper template, you can just use this button. And then in your Rhino settings templates, I have this standard template. Just open it right here and close this window. And then if you create a new Grasshopper file, like for example, file new, or use Ctrl+N short key command, you will see this. So it's basically quite simple template. I already have predefined parameters. Actually, this also a plugin. This probably you don't have. It's called Telepathy. I suppose on the workshop webpage, you already had all these links, but just in case, I also provide for you them right here. So once again, if you need a plugin for Grasshopper, you most likely go to Rhino Insight. Oh, Food for Rhino, sorry. Not Rhino Insight. You go to Food for Rhino, and then you just need to search it. So Telepathy, in this case, and this is the plugin which we would need. I also copy it. Yeah, this quite a simple plugin. It's just for organize your workflow in a better way. But I also want to use it, so better you have it as well. And that's it. Basically, when you install all these plugins, depends how you install them. Just drag and drop them to the canvas, or you can put them to the special folders component folder right here, except Weaverbird. Weaverbird you need to drag and drop because it's not GHA file, but the specific file for installation with the normal Grasshopper script, which has inside it some information to install it automatically. But for example, Telepathy, I just put it right here, or Dendro, the whole folder, I put it right here. And basically that's it, because other plugins I installed through Package Manager. So it's another way, Package Manager, and you can, for example, find here Nuclei and install it. And the same for Telepathy. You can do it. Not Telepathy, but what else? Dendro, probably. So you can just try to find them there. Yeah. And just install them. And afterwards, you will need to close your Rhino and open it again. So basically, this is how it's working. And then while you're doing it, I tried to explain the whole idea of this workshop with the small presentation. And this was a technical part for us, but also what we're going to do here in general. So the idea is to try recreate in 3D any AI image. So if we generate something and using AI like Midjourney, or for example, Nana Banana, or anything else, we usually have images which are quite interesting, but how to work with them afterwards. So if we're gonna create such a project, or just use some parts of these ideas, we need to know techniques to transfer all this geometry to 3D. And of course, there are some AI services to create 3D models for us. And tomorrow I will show you some. But all these 3D models already quite nice, but still they have not a perfect mesh organization and how these files working for the real projects, especially if we speak about architecture, when we need kind of precision of the distances, sizes of the objects, etc. And also for architectural projects, we need most likely complex relationship between different elements. So there are some things which you cannot create automatically, and you need to know techniques in 3D software how to recreate them in case part of your concept that was done with AI. Of course, and I heard it many times. A lot of people can say, "So I don't need AI to create ideas for me. I mostly need it to provide, for example, technical stuff like renders or something else." And it's true, of course, but also AI a nice tool to help you with ideas sometimes, not to make entire idea of your project, but maybe some small elements or maybe some side tasks for which you don't have a time. And even for that, you can use modern models because they are quite nice. And this workshop not showing the exact approach for um, such a design project. It's like extreme way where we create the entire concept with AI and then try to recreate this concept in 3D using advanced modeling methods. Why we used it in this workshop like that? Because it's a nice exercise, I would say. When we use this extreme case, we always can use part of it in the real life. So basically, this is the idea. And of course, for real work, you will not do it in the all this stuff same way, but you will use same techniques for modeling and for creating scripts, for creating renders, etc. And to be fast with all these techniques to show, it's also for us easy way to just skip the part where we create the concept, because it's the huge part of each project, how we discuss the concept, how we um, come with ideas and all this collaboration work, some exercises, variants, etc., etc. Let's say we skip it for this workshop and start already working with the geometry. And to help us skip this part, we will use AI to just create the concept. So, and even for that, I already created this. Mm, uh, yeah, it's a question about Google Drive. It's just above your message, I would say. So it's a check. Yeah, it's this one. You should see. Hope. Okay. Yeah, and I already create one concept. Is this one, and I actually did it a few years ago already, and I used for that Midjourney 5.2. And basically, it wasn't just one structure right here. It was the entire concept of a world with characters, different vehicles, different buildings, landscapes, etc. I'm not gonna go into it right now, which concept that was. So we just will use this exact structure. And the interesting part of it in this Midjourney version, back in the days, it was 5.2 version, I believe, or maybe even version 5, because in this prompt is spelling like just version 5. I don't really remember. It was really a few years ago. But the interesting thing about any branch of this version 5 doesn't matter. It's 5.1, 5.2, or just pure 5.0 version. It was an approach for Midjourney where you can mix the concept. For example, you provide the prompt like that. It's like you describe the concept of something and then another concept. Like in this case, it's, for example, the lappy on the tentacles of the octopus. So basically, it's the thing which is not related to architecture or design at all. It's just something from nature or from animals or from weather effect, whatever you want. Something interesting, let's say, which can affect your shape. And then you describe the exact building you want to create or design concept, like, for example, car or I don't know, dress, or in these cases, futuristic weather station, or it could be skyscraper or something else. And then Midjourney used to mix these two things into one concept, which is kind of abstract, but this version mixed them in an interesting way, I would say. And I kind of liked it. The only thing, of course, this version of the Midjourney not quite realistic, or if you go into structure logic of it, is not make sense, and some elements just randomly merge. So basically, in this point of view, this version not the best. But how it works with mixing the concept, it was quite good. New version of the Midjourney and even version 6 didn't work this way anymore. So that's why I've shown this concept in this Midjourney version, but I also try to recreate it in new models, not Midjourney, but in this case, Nano Banana, and I will show you the result later. So basically, we will stick with this concept, and we will try to recreate this object and then the whole scene in the 3D model. And this is quite a tricky task, I would say, because it's first of all organic shape. Then we have here a lot of small elements, and we for sure will not do it exactly this way as we've seen it on the image, because the image in some parts just not realistic, and in some parts is not quite interesting. For example, these horizontal elements, it's not belong, I would say, to this concept. It's quite random horizontal beam or something like that. So we probably get rid of it. But this, of course, is to recreate if you want. Other parts, not that simple. So it's up to us in which part of this concept we will follow and which not. And so how we can start with it. First of all, we need to somehow analyze this image. And in my case, good tool for analyzing is just a sketch to try to recreate the structure manually to understand how some surfaces or curves can interact with each other, how they intersect each other. And this just shitty drawing. I'm not a good drafter or the guy who have worked with the pencil a lot. So it's just for me to understand how it's working. And if somebody else will see this image, it's probably not understandable as well for them. But for me, I already realized, okay, these curves, for example, go behind this surface. This curve start here and going this way, and then I move it right here. So it's one, and it's going on all way like that. So basically, I can afterwards recreate in the same logic when I will model it in 3D. And in this way, I can better understand how I can approach the modeling. Because if I have just this image, it's a lot of places which are not really understandable how to handle them. And first I need a little bit go deep into this structure and try to make it sense, let's say. So yeah, numbers is just for me. You don't need to really think about that, but I just enumerate surfaces and curves, which I will gonna use afterwards, which I will model in. So basically, this is the result with just curves and surfaces without some details for now, but it's already good enough to have the framework for further development. And for that, we will use Rhino, and inside Rhino, we will use sub-D tools. So basically, it will be our approach. Then for small details, we will use Grasshopper. And in this exact case, nuclei, it's a good thing to create this network in between mainframe elements. And basically, if I play this, nuclei, it's a plugin for Grasshopper, which kind of agent-based plugin. And using this, we can create a tricky geometry like a network. And then using Dendro, we can recreate this network to something like that. And it's already kind of close to the result which we need. And basically, it's enough details, enough complexity of it to go farther with renders and different stuff. So then I also have a character which was created on the separate image like that. And basically this character I want to implement to the scene, to the final scene afterwards. And there are several ways how to do it. You can just directly cut it from the image and implement it to the scene. You can also try to create a 3D model from it. And probably tomorrow we will try it using AI softwares for creating 3D from image. And for characters, it's I would say nice approach because here we don't need precision. Also, it's not the main thing in our scene, so we don't need really detailed models. So basically, it should work. And another approach, you can draw it in 2D. So this, for example, my drawing, which I used to create in Grease Pencil tool in Blender. I will not go to this approach during this workshop because, first of all, on this computer, I don't have planchette for drawing, and with mouse, it will be not possible to recreate. But the idea of it, when you draw it by yourself, not just cut it from the image and put it to the scene, drawing you can animate afterwards, and you can create a live scene, not like just a freezing frames or renders or something like that. If you draw it by yourself in Grease Pencil, for example, you can afterwards make an animation from this 2D model, and it could be interesting as well. So then we will need a couple of textures also for materials, and these exact textures I created with AI as well. In this case, in Midjourney, but we will probably try to use something else because it also was an old approach. But for textures, I would say even right now, Midjourney is good enough, and we can use it as well. So basically, the main things about texture is they should be tiled. So it's most important stuff. And then this final scene, which we probably will create by the tomorrow night. And here we use Blender already. There is our weather station. There is these characters and landscape. So all in real 3D except characters, which are 2D draw it. And basically, this is our goal to do something like that. And to create afterwards, we will create also a couple of renders from Blender. So basically, yeah, for that we will need some cameras and some also light objects and atmospheric effect. So there are some things which we will cover tomorrow. So the idea is today we will mostly work with Rhino and Grasshopper, and tomorrow Blender will be our main tool. And also we will try to, just for comparison, render some objects with AI using ComfyUI. And we also will use AI for creating textures and maybe a 3D model of the character. This is the idea. So, and this, the final renders I did in Blender. So basically, this is the result. This is more or less the same view I had from the beginning with AI, but just real 3D. And yeah, that's it. So basically, I suppose this is the whole stuff. It's not already at the workshop. And just in case you have Instagram, you can follow me and maybe see some future workshops and different stuff which I will provide. And I also have a Telegram channel. If you use Telegram, I sometimes share files there because it's much easier than do the same in Instagram, like different 3D Grasshopper workflows, ComfyUI workflows, some other stuff. So basically, this is the Telegram channel. Okay. By rendering in Blender, I basically not always render in Blender. I use either AI tools for renders or Blender. So I used to use 3ds Max like maybe 10 years ago or even more. I already forget. And I would say I was good enough in 3ds Max as well. But the thing is, Blender is free software and 3ds Max not. So and when I don't have, for example, subscription related to the my office, like Autodesk subscription, I'm not gonna buy 3ds Max. It's too expensive. And other than that, you have also tools like Cinema 4D or Maya, but they're also expensive. Or you can use something like Unreal Engine. And but Unreal Engine, I would say Blender I'm not using only for rendering. It's also a good tool for modeling, for 2D drawings, for animation, for different stuff. And Unreal Engine, it's not really for modeling. If you use Unreal Engine, you still need to use something like Blender. And in this case, you need to know both tools, and both of them are quite complex. So I, for now, decide for myself to just go deep into Blender and not going to Unreal Engine, for example. And this way, I just for myself. So it's up to you, basically. It's a lot of possibilities here. There are also simple tools for renderings like D5 or um, Twinmotion, for example. But these things I just don't like results which they provided. So Blender quite a nice tool for like realistic renders and different stuff. That's why it's just above all this like D5 or other things according to result. You will never achieve something like that. What you can do in Blender and, for example, D5, it's just different categories, I would say. And but for quick approaches, Twinmotion D5 also fine, I would say. So in our office, a lot of people use D5. So actually in workshop description, it's a little bit old information. I'm currently working in ComfyUI, not in the cloud cooperation, and it's a long story. Basically, I worked in ComfyUI before, then with divided offices, and one part of it called cloud cooperation, and now again it's ComfyUI. So basically, in ComfyUI, a lot of people using D5, and render department they mostly use Unreal Engine, but some other people also use Blender. So I quite like it, I would say. Okay. Yeah, we will use cycles in Blender. It's correct. Yeah, Grease Pencil is quite a good tool. And the name of the character, probably I had one, but I already forget. As I mentioned, the whole this concept I did a few years ago. I don't even remember 3 or 4 years ago when it was Midjourney 5. So probably 3 years ago. And basically, it's quite old. I don't remember details already. I just use it to right now to recreate this stuff in 3D, and so I think it will be interesting. Okay, yeah, and I mentioned I tried to recreate this approach, which I did in Midjourney using Nano Banana. I can show you how it works. So basically, this is the prompt right here. It's much complex than I have in Midjourney, and yeah, I can show you, or maybe just copy the whole prompt to our chat. It's not that simple, it looks like. No, probably it's too much text, it's not copying. Check. Okay, what if I just copy the part of it? Yeah, this way it's working, and then I try to do it by portions, let's say. Probably Zoom has some limits for the text. So what the idea here? We have basically primary intent, create a single photorealistic design by fusing two unrelated concepts into one coherent object or scene. And then you describe your concept A and concept B and provide which is the dominant concept and which is the secondary one using the percentage like that, for example. And I would say Nana Banana pay attention on it and understand the thing, because I started with like 40-60 relationship between this percentage, and it was like more tentacles and octopus thing on the result, and now it's less, I would say. So, and but you can check afterwards. And then you describe your concepts, then fusion rules, uh, and some other stuff like scene composition, materials, negative part of the prompt, and target for the quality. So this is the idea. And for that, I use Nano Banana mostly in ComfyUI, but it's up to you which interface to use for that. So it's basically not really important which exact interface you are using. You can go to the Google AI Studio or to Gemini WebPage or to any other services which um, have Nano Banana right now. I suppose any AI platform basically has it, and just use this prompt and you will have the result. And of course, you can use your own concepts. It's the main idea of it. It's you can always using this prompt provide your own concept and some other parameters, and it should work. So basically, Nano Banana support resolution from 1K to 4K, and I usually use 1K from the beginning to create the initial concept. And basically, if we speak about prices, for example, I use it through the API here. It means, for example, if you go to Google AI Studio, you probably will have some free options to generate images. And the thing is, when you do it this way, you will have a watermark on your image. This is one disadvantage. And another one, you probably will not have 4K resolution there, for example. If you just go to Gemini page, Google AI Studio, you probably will have all of the settings, but it's also paid. So you also will need to provide API keys there and something else. So basically, I use ComfyUI because sometimes my workflow is much more complex, and I also afterwards change some details of the image, like making color correction, brightness, contrast, deleting backgrounds, and different stuff. And this is the tool where you can do all of this. It's like advanced Photoshop for using AI models. And also you can use Nano Banana in Photoshop as well. So it's also, if you have a subscription, it will be a way how you use it, because standard subscription already has some AI points, and you can use Nano Banana there as well. So basically, there are a lot of interfaces for using this exact model, Nano Banana or Gemini Free Pro Image Preview. It's how it's called officially. And basically, the most important settings for us, it's aspect ratio. You can pick one of them, and resolution. So I usually start with resolution like 1K. It's easy afterwards to upscale this exact image to 4K. I will show you how exactly I will do it. But for this initial concept, I even don't need it. If I need it in the presentation on somewhere, I, of course, can afterwards upscale. And I not recommend to use 4K by default. First of all, it's more expensive. 1K and 2K price is the same. Basically, you can switch between them. But I would say for me, in most cases, 1K just work better in details. It's like more makes sense from architectural point of view. That's why I usually start with 1K. If it's not working, I switch to 2K, because sometimes it's probably different models behind it, and or different like system prompt. I don't know exactly how they divide an approach between these two resolutions, but sometimes 2K also quite nice, and it depends on your prompt, depends on your inputs and different stuff. So I either use this or this. They are with the same price, but details are different, and the results also different, not only by resolution, but also by approach and details and different stuff. So I prefer 1K from the beginning. And 4K I gonna use for upscale afterwards. So this is the idea. And mm, so if you use ComfyUI, you also need to provide some credits. For that, you go to the settings. And here you have your user. You need to sign in. I just use my Google account. And then you go to the credits, and you need to purchase some. So basically, for $10 will be more than enough for you. So basically, it's quite a good price to create. I don't know how many images. It's costs usually 12 cents, if I'm not wrong. Yeah, but let's say one image is cost 12 per 12 to 15 cents, something like that. I don't remember exact price. It's actually here is the credits. It's not dollars. Yeah, but something like that, and or 28 credits. So it's highlighted here, and you can just calculate it using these things. So 50, let's say $10 is 2,100 credits. So basically, it's quite cheap, and for $10, you can create a lot of images. ComfyUI itself is free. So the thing is, ComfyUI is the free software. You can just download it from the website, and for that, you need to go like just Google and ComfyUI download. So something like that. And this is the first link you need. I can copy it as well. And ComfyUI, it's like an interface where you can just use a lot of model for free. But the thing is, Nano Banana is not for free. It's not Nano Banana itself. It's the model. The thing, probably I need to explain it because not everybody understand it. And you can always see in the internet posts in Facebook or LinkedIn, like, I don't know, 10 best AI services for architects or something like that. And when you see that, it's a bit of confusion, because sometimes such posts are mixed things inside it. And in the AI world, there are a lot of different things. But for us right now, it's important to understand what are the models and what are the interfaces. So basically, there are just a few models for creating AI images or videos or something like that. It's not hundreds of them or thousands of them. And there is even platform. I can try to find it quickly. Let me check. Um, Probably I have the link here. Yeah, this is the website. So this is the website. It's arena for comparison different models. And if we go, for example, to image edit or text to image, it's what is important for us right now. So image edit, it's when you create, for example, AI renders. You have, let's say, initial screenshot, and you can create an image from this screenshot like a render. And text to image is what we are doing right now. We just have a text prompt. And usually a model can do both. And for example, if you go to image edit, this is the rating on this platform. And here is ChatGPT image latest right now on the first place, and Gemini, Nano Banana Pro, either 2K or 1K model, they are on the second and third place. So basically, this is the rating, and there are only how many positions actually? 34. It's not a lot of them, and some of them models are quite old already. And basically, there are some other models. For example, Midjourney not represented here because they are not um provided the credentials or open version of the model for such ratings. But most of the models are here, which you can find on the market. And basically, it's just for 34 of them, not much. And it's all we have. And you use exact these models in all the services all over the internet. So when you find a website where you can create an image or either like a render or from just a pure text, you can use one of these models. Most likely you use Nano Banana. But as you can see, it's not hundreds or even uh, thousands of them. So it's just 34. It's all we have. And basically, this is important to understand. And when you see the articles like 10 best services for architects according to AI generating, these articles more about interfaces. And basically, it doesn't matter which exact interface you are using. All the interfaces just for your comfort, let's say, how you connect your inputs, how you provide your results, etc. But the models behind them are the same, and it doesn't matter where you can use this prompt in ComfyUI or in I don't know, Korea website or somewhere else where you can use the same model. And basically, this is the thing. Uh, and this is important to understand. This model for me is the best one right now if we speak about architecture, because this rating, they put ChatGPT on the first place, but this rating not about design or architecture, it's about everything. And how this rating they made it, you can go to start voting, for example, provide your prompt. We can do the same. Basically, for example, I can just copy this, try this. So it's just a small side story, but it's probably interesting. And you can also provide your, if you, for example, make an AI render, you can provide your screenshot. And but in this case, we will not gonna do that. I think we just go with the simple prompt. And here you have no possibility to pick the model or our settings. You just agree with this and wait. And you will have two variants. You will not know which exact model will produce one variant or another variant of your image. And basically, you can use also this service like for free to generate something. And you can see these two variants, for example. And I would say maybe I like this variant more. So, and I will go to B is better. And let's see what models was behind. So this is the C Dream, and this is Imagine 4.0. So Imagine it's a really old version of the Nano Banana. It was before. So now we have Nano Banana Pro. It's Gemini 3.0. Before that, we had Simple Nano Banana. It's a Gemini 2.5. And Imagine, it's a model was done by Google more than a year ago. It was before even Nano Banana first version. So this is quite an old version of the Google model. And C-Dream, it's quite a not new, but from this autumn model, it's also quite nice, I would say. So basically, they take into account all this voting, and based on them, they created these ratings and how it's working. And you can also use this to create a free generating images, but it's not, of course, that professional. Just for fun, you can do that, but you have no settings here, or you can't pick the exact model you want. So basically, it's just for fun. You can use this website as well. Okay, this is the thing, but yeah, the ComfyUI itself is free software. It's just an interface. And inside this interface, you can use both free models, which you can download and use on your own computer, and models which are not free. Nano Banana is not free model. It's not possible to use it professionally for free. You can just, on some websites, can create a few generations, few images for free. But afterwards, you also will have some limits. Either it will be limits by time, because, for example, Google website, they provided the possibility to generate images for free, but without settings. You can't pick, for example, 4K resolution there, or and then if you generate a lot of images, and usually you need a lot for real projects, you will not do it there, because they only provide for you a few generations per hour, let's say, and then they will show you a message, you generate too much, wait for tomorrow, for example, and for professional work is not good enough. So basically, Gemini is not a free model, and I would say it's not possible to use it for free professionally, except you just need a few generations. That's why I use ComfyUI. ComfyUI directly connected to Google API, so it's prices from Google. It's not something above it here, so it's good for me. And also inside of ComfyUI, you can use a lot of free models. If your computer is good enough to handle them, you can download Flux 2 or Flux 1 model, which are quite good, and use them in combination with Gemini or without it. And also, it's not just about AI generating. So in ComfyUI, you can create some stuff just to post-process in your image, like colors, contrast, backgrounds, different stuff. So basically, as I mentioned, it's kind of Photoshop with advanced AI features, and it's not based Photoshop. So and software itself is for free. The Google model is not for free, so that's why you need these credits to pay for generation if you're using exactly this model. So this is like an introduction to AI world. Probably for most of you, it already was understandable, but maybe it was useful for some people. Okay, and yeah, if I run this workflow, I can just see the new result every time. If you have, for example, a randomized seed control after generation, or any options except fixed. If you have the fixed here, you will have the same result every time. So basically, you don't need to use it. And yeah, this is another result, for example. It's also quite interesting, I would say. I can right click and save this in my renders folder and try again. Let's see what we will have. So this approach quite an interesting to recreate the approach I had before in old version of Midjourney, but of course level of details right now is much more interesting, and these modern models much better than Midjourney 5, of course, and even than Midjourney 7 or something like that. So basically, this is the idea. And yeah, I can put one of these renders. Maybe I already did it. Let me check on our Google Drive. We have here files, ComfyUI. No, I only have inputs. So let me make another folder, which I will call renders right here. And I will put one of these renders. This I don't need. Maybe both of them, but you only need one of them actually. And the thing is, if you install ComfyUI, to not put all these, it's just two nodes, it's easier. But in case you will have a complex workflow, so what you can do, you can just, for example, close this and close this as well. Okay, just create an empty. And then you can drag and drop an image and right on the canvas, and you will see the whole workflow with the prompts and different settings. If this workflow, if this image was created in ComfyUI. So this image keep the workflow inside it. And when you download it from Google Drive, you can do it this way. And let's say afterwards, I like this image, how to make it in a better resolution, because here I have just 1K right now. And what my approach will be. So I need another node right here, which is called load image. I can double click on the canvas like that and search it, load image. You will see this node. I usually for inputs use the brown color, and then I can provide my image like that. In this case, I will drag and drop it not into the canvas, but into the node. This is important. And use this image as an input right here. So then I need to switch the resolution to 4K and change the prompt. So I would say something simple like upscale this image to 4K without any changes. So this will be my prompt. Can squeeze it a bit. Like that. So quite simple. Scale this image to 4K without any changes. And the most important setting is this one. And then run. And this is cost more credits, twice more, almost twice. And that's why I don't use 4K from the beginning. And also 4K, even if it's the same price, maybe in future they will make it the same. 4K model is not that interesting if we speak about creativity. And that's why I always use 1K or 2K on the first place, and then use 4K model only for this approach. How to start the prompt node. So prompt node is called like that, Nano Banana Pro. You can just double click it, Nano Banana Pro. And so it's two of them. You see this one is used the previous model, Gemini 2.5. You need this one, I think. Yeah, you just use Gemini 3. And basically, you can do it this way. Another way to do it is, as I already mentioned, just download my image and drag and drop it. You will have this node already here. My image on Google Drive right now, this one. You will have this node here and the preview image node as well. And the last way to do it is go to menu, go to the browse templates. ComfyUI has a lot of templates. And you can find some templates for create different stuff right here. Some of them, for example, Flux to Client, it's a local model. It means you need to download the model itself, and this is for free. You will use your own computer to generate images, because when I use Nano Banana, I don't use my own computer. It sends information on the Google service, and this model working through API, and it's not on my computer all this work happening. I just wait the result, and when the result is here, I see the perfect image in 4K resolution. This is the resolution of the final image. I can save it and use it whenever I want. So basically, this is the thing. And when you use other models, which are for free and you need to download them, you will not spend credits or money, but you will spend your own computer powers, let's say, because, and for that, you need a good graphic card. So basically, can I check the image because it's a question about Google Drive? This. So yeah, it should be in files, then ComfyUI, then renders, and right here. So this is the image. But yeah, it's not about this node. It's not this node. It's easy to just put it on the canvas. It's more about maybe a prompt because to recreate the prompt, it will be just easy to use my workflow. But yeah, for templates, if you go to browse templates, you can see a lot of them. Some of them, for example, to create animation also with AI models. But for that, you will need even better computer. And the most important thing in your computer for AI models is graphic card. And I have NVIDIA 4080 on this computer. It's good enough for most of the models, especially if we speak about just images, not about video. But for some advanced video workflow, even this graphic card is not good enough. And that's why sometimes you need to use either API models, or there is also the cloud version of ComfyUI. So you can just go to the browser and cloud ComfyUI, let's say, something like that. So it's official cloud version. It's look like that. You can launch it. You will need an account for ComfyUI. And for cloud version, you also will need a subscription. I forget how much it cost, but not really expensive, like $20 per month or something like that. I don't really remember. And so here you can use models which are for free, but not using your computer. And for example, this workflow is for upscaling, I believe. Oh, not translucent. No, it's not for upscaling. It's workflow I used for creating some concepts with Flux Crea model. So Flux Crea model is collaboration between Black Forest Lab, who are a developer of Flux, and Crea, who are a developer of web interface for AI models. Crea, it's probably familiar for you. And they altogether create version of the Flux model. And you can download it for free and use it for free on your computer if your computer is good enough. But if it's not good enough, you can also use it in ComfyUI Cloud. So basically, this is the thing. And these are all the possibilities you have. You can use a desktop version, but using your computer. You can use API models, API-related models like Gemini. It doesn't matter in which version, cloud or desktop version of ComfyUI you're using it, you need to pay for them because it's not belong to ComfyUI, they belong to someone else. For example, in my case, this is the Google model. And in the cloud version, if your computer is not powerful enough, you can use any workflow, but you need a subscription for the cloud version just to use in the server outside of your computer. Yeah, Nano Banana will be fast because it's not depends on your computer. Doesn't matter. You can launch it on, I don't know, on your phone if you want. It's launching actually on the Google server, and it just send the result to you. So it doesn't matter which computer you have if you use Nano Banana based workflow, because this node, it's not creating something on your machine. It's just sending information from you to Google, and then you receive the result. So basically, for this exact workflow, computer doesn't matter. If you see this small tab here with credits, it means it's working somewhere else, but you need to pay for it. So basically, this workflow, for example, which I opened here, if I run it, it's for free for me. And I can also run it on my own computer if it's powerful enough. But in this case, because I launched it in the cloud version of ComfyUI, not on the desktop version. So desktop version is like a software. You need to install it, and you have this interface on your computer. This cloud version you open in the browser. It's not working from your computer, but you need to have a subscription for it. So basically, it's also quite fast because they have a nice configuration. Yeah, I forget one thing. This exact workflow has a problem, but probably is not important for us. It's just about you can launch something in on the server. But basically, you can always browse templates and check one of the ready-made workflow for you, even one which are creating the video. So basically, this is the idea, and this all about ComfyUI. We will go back into it. It's quite interesting software, but today we gonna mostly work with Rhino. I suppose today we will spend about 4 hours for this session. We already spent almost 1.5, and it means 2.5 we still have. And by the end, we should create a 3D model of our weather station. And before we start with it, let's make a small break for 10 minutes. So in my case, it's 5:20 right now. We will back in 5:30, let's say. And we will have some breaks later as well. And one of them we will make not that short, maybe for 15, 20 minutes in the middle of our session. We will do it later. But for now, just 10 minutes, and we will go back. Okay, let's continue. Actually, while everybody join again, I suppose some people it's need more time to do it. I will check your questions, and some of them are quite interesting, and we will spend maybe 2 or 3 minutes for them. And during this time, I suppose everybody will return. So the first question is it more economical to use Nano Banana Pro with credits on ComfyUI, or is it better to purchase a Google Flow subscription? So basically, Google Flow I have as well, but I use it mostly for video. And can I show for everybody who not familiar to it? So Google Flow, basically, when you have it, you need to pay for one of the Google tier subscription. So let me show you. Like that. And Google Flow itself, it's a service for generating video, but inside it, you can create images as well as frames for the video. So this is an option for you as well to do that. And when you go inside, you will see your projects, basically. So this I made for one kid who is a kid of my friends. It's like a New Year thing, but basically if I go to the like real project, so you have a subscription right here, and you have some credits basically. And if you generate images, images are for free for you here. And when you, for example, go to frames to video, and then if you gonna generate your own images, not upload one. So I even forget where is the option for that actually. Yeah, you need to switch right here, images. So, and here basically, when you have the images, you can just put your prompt and create your own images. But as you can see, I never did it right here. So basically here is for free. If you have a Google Flow subscription and you generate a lot of images, it will be probably easier for you to use this service, and because all the images will be for free for you here. The thing is, here is not all the options are available. I believe because for the video you can only use landscape or portrait frames. Is the same for images right here, but also if you have this type of subscription, instead of Google Flow, you can use Google Whisk. If I'm not wrong, it's called like that. And this is for images specifically. And here you will have options as you have in ComfyUI for different resolutions and different stuff. But the thing is, in my experience, it's working a little bit in a weird way. And when I created images right here, results are not that interesting architectural wise. I don't know why. Maybe it's just my own thing and it's not true. But you can try this if you have Google subscription. Its cost depends on the tier. The cheapest one cost, if I'm not wrong, about 30 euro per month. And the ultra subscription which I have, it's cost with discount 150 euro per month. So, but this ultra you only need if you work with video professionally. For images, I believe you don't need it. So basically, for video, this must have subscription, either this one or from OpenAI, because either you use video model from Google or Sora from from Google it's called VL model, and from OpenAI it's called Sora, and they both quite good, and both Pro subscription cost about no more than 100 euro for sure. I don't remember the full price because for first 3 months in Google you have a discount, and it's cost 150 euro, and then it's probably 100 euro more. and for OpenAI is similar. So it's something like that. And basically, this Ultra subscription you need in case you work with video a lot, and in case you just work with images, Pro subscription is good enough, I believe, and it's cost about 30 euro per month. So basically, Whisk is a tool for working with images through the Google subscription. And here is Nano Banana, of course. And then when you will see some tutorials, how it's working, basically, and you will have this interface, and you can provide your own images like subject, scene, style. They mix all of them to one workflow. It's one approach. If you just provide the text, this text to image approach. We can even try it actually right now just for fun. Where I had it, a second, my original prompt. Let's try, because last time I tried, I didn't like the result actually, how it works, but let's check it out. So basically we have this also actually limits here for resolutions, also free options. So still in ComfyUI, it's there are more options through the app than even here. I don't know why they develop it this way. So let's check. Yeah, it's I would say something wrong with these images. It's like looks more like toys. I don't know. No like real detailed architectural object. So I don't like this service. But the thing is, if you have the subscription, all these generation images for you is for free. So you only need to pay for subscription once, and so maybe you can try this as well. So if we speak only about economical, the Google services will be easy for you. But Flow I use a lot, but for videos, not for images. It's another topic, basically. And for videos, it's quite good. It can create a really nice video for you. It's quite interesting, yeah. But this is another topic, basically. And okay. Yeah, let's go back to your questions and then go back to Rhino. So what are we doing currently? We will start working with Rhino, but yeah, it was a break for 10 minutes. At the early stage of its emergence, was an option about ComfyUI that it was better to install the portable version. Can we now say that the standard installation option fully meets the functional requirements? I would say yes. I only use right now ComfyUI desktop, and I even deleted portable version. It still makes sense to use portable version in case you are working with, for example, approach when your computer is not good enough and you launch the ComfyUI through services like, or I even forget the name. Oh, silly me. There is a service from Google as well, which allow you to launch different workflows, and you can put your portable ComfyUI version to Google Drive, and then through it you can launch your ComfyUI configuration, but through the Google server. It's quite tricky to tune it, but it makes sense to use in this case ComfyUI portable. Also, for some rare workflows, it's really only working with the portable version, but I believe it's only related to the old workflows, like it was for Hainan 3D model, which is AI model to create a 3D from images. And there was a workflow which not only create a 3D, but also assign textures and materials to the model. And this exact version of the workflow only worked for portable version. And but it's only case I remember actually. In all other workflow I used, desktop version worked good enough, and I think it's kind of okay. I see a comment. Maybe this why I don't like the result. You said that in Whisk there is no Nano Banana Pro. Maybe this is the situation. Yeah. So, but I would say Flow also has some limits if we speak about resolutions and different stuff. So, yeah, Collab. Thank you. Yeah, it's the service for launching your workflows. It's not only related to ComfyUI, basically Google Collab to just launch different Python-related workflows and different stuff, but you can also launch ComfyUI there. Subscription for Flow, it's like Google AI subscription. It's called Google AI subscription. You can just type it in the internet, and it's include a lot of stuff, not just Flow or Whisk. It also includes some additional limits for Google anti-gravity. It's even can include some stuff like Pro YouTube subscription and advanced Google Drive subscription. So it's like this Google AI subscription includes a lot of things. You better read it because I can confuse you with all the options there. But Flow is part of it. So it's called Google AI. Okay. Yeah, I think all the questions we cover. If I missed something, just text it again. And we finally start with Rhino. I think, so first of all, let's change our units here, because when I open my file, by default, I had millimeters here. You can either, when you create a new file, use the template, like I gonna use meters in the end. And there is a template in a standard Rhino installation, which is called large object meters. It's one options to have it. And here I have meters right now. And another option is right click on it, unit settings, and switch to meters right here. If you, for example, don't have templates, but you for sure will have them. So basically, this is the thing. Then I will go to the front view, double click on it. So you see the front view name right here on the corner. And also I will not need all these layers. I probably leave only default layer and layer one, and the rest I will delete for now. And layer one, I will rename to image. So it will be my background image from which I will start modeling. It will be helpful, I think. So yeah, back in the question, it's better to get Google AI. It's depends on your tasks, I would say. For me, why I have Google AI subscription, I use a lot Google Flow for video generating. And if you do that, you need the subscription. And the second reason, it's I use Google Anti-Gravity for code. So with this subscription, you just have no limits there. And in case you don't have, you still can use Google Anti-Gravity, but about 1 hour per day, and then you will go to your limits, and the software will ask you to go again next day or next week even. So basically, these reasons for me to use Google subscription. And if you just with image generating, I would say no, because even if I have the subscription, I not use it for images. So basically, it's up to you. Okay. Yeah, I create this layer image, and default I leave it right here, and I make this layer active to double click on this line, and I will have it right here. So this is my preparation. But basically, before we start, maybe with actual modeling, I will a little bit go with some mm, abstract techniques with the sub-D. Probably some of you never used it or even never used Rhino. So in this case, maybe it will be interesting. And yeah, let's go to probably perspective view right now. I go right here. So it will be easy for me. And just to explain some things, maybe I will create some primitive objects. So first of all, I will create a sphere. From this tab, you see this small arrow. It's a cube icon and this small arrow under it. And you see a lot of different primitives. And I will create a sphere right here, like that. So I, right now in the shaded mode, and the color of the layer is red. Maybe I change it to just gray or white. So color is right here. But it's not important, by the way. I just want to show you some basic stuff. If you not follow it, you don't need to model these spheres. I will, when we start with the actual object modeling, I will tell you. So right now, I just want to show you the basic geometrical things about what is the sub-D, what is the NORBS, mesh, etc., and some basic tools which we're gonna use there. So this is the NORBS sphere, and if I select it and go to the properties, it's called closed surface in Rhino. So this is the type of the object. I also want to create a mesh sphere. I go to the mesh tools, and here is also a tool to create a primitive object, but somehow, yeah, it's right here. We have some tabs right now. And so mesh sphere, like that. And also I will create a sub-D sphere. So sub-D sphere is right here. So it's three different type of objects which we have in Rhino for 3D geometry. We also, of course, have points or polylines or curves. So it's other types of geometry. But if we speak about 3D, it's three of them. It's a NORBS, mesh, and sub-D. And sub-D, it's basically also mesh geometry. For example, in Blender, you don't have such a separation between mesh and sub-D. It's the same thing there. You just have a modifier which you can apply to the mesh for subdivision. And basically, sub-D is an algorithm on top of the mesh geometry to create mesh geometry, let's say, more smooth and to create a relationship between different mesh sub-objects like faces or edges. Mm, uh, it's working this relationship between them in different way. For example, if I select on the mesh one face and move it, so neighbor faces, not neighbor, but because, for example, this face and this, they have common edge. Of course, this also modified. But for example, already this one not, because it's not related to this at all. They don't have common edges or vertices. So this stay as it is, even if I move this guy somewhere. So basically for sub-D, it's a little bit different. If I move this guy, it's also affect not just the neighbor, but also this one. You can see that. So, and the result is much more smoother in the end. You have this relationship between sub-objects inside the element. So this is basically the difference. Also, representation is different. So this represented in a smooth way, and this is like angled. You can see that. But basically, for sub-D, you can represent in this way as well. For that, you need to press Tab button on your keyboard. And you can see this angled representation for the sub-D. And there are less faces here than here. That's why we have not totally the same representation, because it's just structure of these objects are different, amount of sub-objects, let's say, are different. But basically, the representation itself almost the same. And yeah, this is the thing. If you press Tab button on your keyboard, you can switch between smooth mode and flat mode for the sub-D. So this is the flat mode and this is the smooth mode. We can use this a lot in future, and basically you can see that. So and this thing is totally different. This kind of the based on the same approach. It's polygonal modeling. And if you work before in Blender, 3ds Max, Cinema 4D, Maya, all these softwares are based on polygon or mesh modeling, and they all use this kind of type of geometry. There is also in Maya or 3ds Max or even in Blender NURBS geometry, but they are not really developed well, and not a lot of users work with them there. And for Rhino, it's vice versa. Basically, NURBS geometry here is the basic, because Rhino, it's more engineering software. Software like Blender or 3ds Max mostly used for spheres like cinema or computer graphics in the games, or for video production, etc. So basically, these spheres are not require precision for modeling like engineering bureaus who creating cars, boats, buildings, etc. And Rhino for that, actually, it's for engineers, for architects, for engineers, for design, basically. And here you need a specific precision to create object with exact sizes, and NURBS geometry much better for that. So it's not abstract geometry like mesh, which you cannot control for real. You can just work as an artist with it. And with the NURBS geometry, you work as an engineer, let's say. And this is the main difference. And if we speak about geometry itself, the main difference between this sphere, in this sphere, there is no sub-objects here. We still has these lines which visibly divide our sphere, but they are just for representation. I even can switch them on, switch them off like that. And here I only have one thing. It's a seam. And seam is important. It's the place where the closed surface basically closing. So this is important for us, because if, for example, we assign texture on it, this will be the seam for the texture. And also, if we assign a panelization or pattern on this sphere, this will be a place where all our panels will join together, and we always need to pay attention how they do that. So basically, this is like a whole object without any sub-objects inside. And this is the main difference if we speak about this in this type of geometry. And also, this object on behind the scene described as a math object by formulas. And there is no representation with the small sub-objects on the background as well. This object described by points. If I switch on these exact points, so on the background, if we like save this file as a text, let's say, this object will be described with coordinates of these points and how these points connected to the neighbor points. So they have just relationship. For example, this point connected to this. They have, for example, names. It's basically numbers. And let's say this point 1 is related to point 2 and to point 3 and to point 4 and to point 5. And this relationship and coordinates of this point is enough to describe the whole sphere. And this is quite a primitive. Here is the math formula behind to describe this. And yeah, these are three types of object, and you can convert one to another by using different commands. So basically, to convert any object, either this on this to sub-D, you need to use command which is called to sub d, and it's quite simple. So you can just type it in the command line to sub d. Then it's asks you to select mesh or surface. And for example, I want to convert this guy to sub d. I select this, press enter or right click on your mouse, and then you will have some options. Let's say I will keep them as it is. The only option is important for me. It's what to do with the input object, and delete it or not. I will say no, because I will need them in future. And right click to finish the command. And right here, I have two objects. So it's a new sub D, and this is my initial sphere. So it's basically like that. Amount of faces, it depends on complexity of your initial object right here. And when you create the primitive sphere like that, for example, sub-D sphere, you have an options to define how many subdivisions it will have. So by default, it's one, and we have this density. If I press two, let's say here, I will have twice more dense sphere. So basically, it's like that. If I use the mesh to convert it to sub-D, I again use to sub-D command, same options, and this is my new sub-D. You can see the result. So basically, the structure of the faces is the same. It's just much more smooth right now. So basically, it's what happened when I convert this mesh to this sub-D. So this is the thing. Then to convert this object to NURBS, there is an object command which is called to NURBS. It's also quite obvious. And then I need to select the object. Let's say I want to select sub D, right click again. And this is my NURBS. But the thing is, this is actually, if I switch off is a curves, it's not the sphere exactly. It's actually divided by two objects, as you can see. I can even separate them this way. So basically, it's not the real sphere. That's why it's not really possible to create from this or from this exact this object. So this is quite different. And it's try to create it as simple as it's possible when I convert sub-D to NURBS, but still it's not created the sphere for me. So it's created polysurface. It's created two different surfaces and join them together. And with mesh, it will be the same. There will be no like real surface in the end. So this will be the poly surface with exact same structure as I have here, but each element right here, it's a separate surface. They just join together. So the thing is, for NURBS, you can create a lot of separate surfaces and then join them, and this object will called poly surface. So it's not like a one whole object. Let's say it's a lot of objects joined together. So this is the thing. And then to create mesh from this and from this, there is actually no command which is called to mesh. I don't know why they didn't follow the same logic, but the command called just mesh. So this one. And for example, I select this, convert it. I will have this thing, how many polygons I better to create, and then press OK, let's say. And I will have this really dense mesh because it's tried to follow my surface precisely. And this will be a mesh. So the same for sub-D. I can create mesh from sub-D, and the result will be more or less the same. And this is one approach. Another actually exists to create more, let's say, simple mesh in the end. And for example, if I have this flat mode, I can create exact this mesh from this sub-D. For that, I need to use command which is called extract control polygon. So extract control polygon, this one. And as you can see, we have this mesh, which is totally the same as my flat representation of the sub-D. The thing is, mesh also have a little bit smooth representation. That's why we have these red things right here. So yeah, it's how you can convert one object to another. There are some methods also in Grasshopper. We will go into it later when we finish our own object. But for now, I delete all these spheres and show you some other small things. For that, I probably will create a sub-D plane. So sub-D plane. And X count and Y count, there are some options. When you create one on or another object, I right now go to sub-D tool and pick this create sub-D plane. When you launch one or another command, either through the command line directly or through the icon, you will have a few options how to create this command, this object, let's say, or how to edit the object, depends on your command. And you can always click on one or another options. For example, X count, I gonna use 4, and Y count, so 4 as well. And then it's asked me first corner to rectangle and the second corner for rectangle. And I will have 4 faces here and 4 faces this direction, X and Y. So these are my options. There are some other options there. If you newcomer in Rhino and you want to learn more commands and you want to do it using the Rhino itself, so you can just use this small button right here, options, and show panels. And find here panels which is called help. Where it is? I don't see it. It should be alphabetical. Yeah, this one, help. And use this checkbox, dynamic help. And when you launch one or another command, for example, this one, it will show information for this command for you, how it works, how all these options works. And you can learn Rhino this way, basically. So you just try to find the command and you will see the whole information in this help. You can make it bigger, of course, and how it's working. It's a lot of stuff with animations, with nice images, described everything here basically, and you can learn Rhino just this way. You don't even need tutorials for that. So basically, this is the thing, and yeah. So this is my initial sub-D object. And what I want to show you, it's some commands which we have right here, and also these arrows commands. So if you don't see them, you need to switch on this button, gumball. So this part of the interface showing you these arrows. And through it, you can manipulate your objects in a really interesting way sometimes. So this is the first thing I need. The second thing I need is selection filter. If you don't have this menu right here, selection filter, you can just type it in your command line, selection filter, launch it, and you will see the small window. If I launch it right now, it will disappear. I don't want it. So you will see the small window with the same checkboxes. Just put it somewhere on your interface, and we're going to use it. So yeah, the question about recordings, yes, you will receive them on your email. Okay, this is the thing which we will need. So it's selection filter and nothing else basically. So and gumball, yeah, gumball switch on. When you select object, you will see these arrows. If it's switched on, if it's not, you will not see them. So basically, what I gonna do now, I'm wanna select one of the face. To do that, if I just try to select the object, it's selecting like a whole object. To select one of the subcomponent of the sub-D, you need to press either Control-Shift and click on the object, and you can select it. You can select this way also edge, or you can select one of the vertices. For example, these or these. So basically, it's a one way how to select some object. Control Shift plus click on it. And another way, it's use selection filter. It's more convenient. And for that, you need to press sub object checkbox. And in this case, when you're just clicking on the element, it will select not the whole object, but sub objects in it. So it will be more easier in our case. And for example, I'm gonna select only faces right now, and I don't need all these checkboxes right here. And to select only faces, I right click on this line, surface faces, and all the other will be automatically switched off. Right click on it, and you can do that. So now if I try to use the frame, for example, I will only select faces, nothing else, not vertices, not edges, only faces. So basically, it's what I need right now. Then if I select one of the face and just drag it some here on top, so I also press Tab to use the smooth regime, not the flat representation. So flat and smooth, so you can see the difference. And also, I probably go to OSNAP right now and disable OSNAPs because I don't need them. I just need abstract modeling. So, you can just drag and drop some faces, and you can see how you can manipulate to initial surface and easily sculpt it somehow to create interesting shape. So this is the way how you work with the sub-D, and you can start with the very primitive object and easily create something interesting. It already looks like a roof of the pavilion or something like that. So this is the one thing. Another one, it's if you select and not use the arrow itself, but use this small dot on the arrow. In this case, you will extrude the face, not just drag it somewhere. And this is also interesting. You can extrude several of them. Let's say this, and maybe, I don't know, this one. Then if you select again, you can extrude it again, and you will see these intermediate edges right here. So basically, you can do it many times to have more polygons this way. So, and yeah, this already somehow structure. And for example, later you can select one of these ways and also extrude it this way or this way or something like that. Basically, it could be a really tricky shape in the end. This just about Gumball and how you can work with it. And it's quite interesting. We will use some other techniques with these arrows and different stuff later. For example, if I double click on this edge, right now I can't select edges because I use this option surfaces. So I check it off and use curves edges instead and double click on this edge. So if you double click on one edge, it's trying to select the whole loop. But in this case, this is not really understandable. This edge, it should be selected, or this, because we have this division in this place. That's why if I need, for example, this one, I press Shift and select it as well. So I have the whole loop for me right now. And then if I use this dot right here, I can scale it this way. So this is basically the scale in different direction. That's how it's working. Also, I can try to select these guys, for example, by frame and scale them this way. So scale we also will use a lot. And just check how it's working. Yeah, this is another thing. And the last thing on the gumball, it's rotation. So you can rotate elements. Because when you rotate just one edge, you kind of squeeze it in a tricky way or try to twist it. So you can select the whole loop and try to rotate it. So it's also could be interesting. Something like that, for example. Yeah, and sometimes you can see this a little bit confused geometry. And when you're in the smooth regime, everything looks fine. But when you switch to the flat regime, you can see some problems here. It's not really a problem, but sometimes they're more problematic right here. And if I go to the points and vertices, I can try to a little bit make it more relaxed in this place, not that narrow, let's say. And in the smooth regime, it's almost the same, but here I have a better representation of the geometry. And for exporting and for other stuff, it should work better this way. So basically, this about Gumball. Let's check some other commands right here. Some of them are quite interesting. If you go to the subd tool, you have this panel for editing subd, mostly for editing. Some other tools just for example, these tools are just for selection. It's the same as you can use through selection filter. You can just, for example, select only vertices. But I prefer selection filter than these commands, so it's up to you. You can also use these buttons. But the rest of the buttons here are either for editing or starting from here, it's for selection, specific elements. And these mostly for create primitive subd shapes from here to I would say here, even from this button to this button, it's creating the primitive shapes, and it's like a plane, cube, or sphere. It's probably understandable. And this is more tricky. It's loft, revolve, sweep, and they are the same as for NURBS commands. We will use some of them later. The only thing we will not use during the session is multi-pipe. I will probably show you because it's quite interesting, and for some other projects you can use them. And multi-pipe is based on the curves. So you first need to create, for example, polylines. I will go to the standard tab and use polyline command and just create an abstract polyline like that. And here I need already all snaps. I will switch them on because I need to, for example, use the end of snap or mid or something like that. So I will go back and enable it and create some stuff maybe like that. And the thing is, here is the sub-objects. I don't need it also. So here is the whole polyline, and here is the separate lines. When I create them, I create like polyline like that, and end the command using Enter or right-click mouse to end your command. And then I use the same command, but just with 2 points and end it, and this is just one line. So basically, for multi-pipe, you need to have just simple, not necessarily just simple lines, but in the place where they connected to each other, it should be division. So here it is, we have 3 branches, let's say, and it's not possible for multi-pipe to use this as a same object. We need to explode it. And to be sure we explode everything, I just select all the lines and use the explode command like that. And this is good enough for me. Then I go to subd again, select all these curves and use multi-pipe. So basically, radius 1 is fine for me. And cap, no, it's cap is how it will behave on the end. It will close it or not. So I will keep all the options as it is and just finish it. So I have this object right now. And yeah, it's not possible to select it because I only can select according to selection filter point and cars. I right click again on cars and it's going back. Okay, probably switch all this stuff again. Or another option, just disable selection filter. It will, in this case, it will be doesn't matter what exactly you select. Maybe it will be easy for us to disable it right now. So, and yeah, this is my new sub D. And of course, you can manipulate it the same way as you did with other objects. If I, for example, use only sub-objects and edges, I can select these edges, and maybe I just to close, scale them this way. If I press Shift, it will be scaling in all directions, like that. So you can do something interesting as well. Is this multi-pipe, and yeah, it's basically up to you what to do with this thing. You can also scale these somehow, or maybe this direction a little bit. So it's quite weird, but in the end, the idea is like that. You can use your cars to create a sub-D. And also, of course, you can create these not from just polylines, but also using more complex curve like that. Say, but the thing is, here we also need to have a division in these places. And here is whole object, not a polyline. If I explode it, nothing will happen. Still will be the whole object because there are no segments from the beginning here. So I need to split it using these other lines as cutting object. And I select it, use the split command, and select these, and these as cutting object because it's asked me to select cutting objects. And now it's split in the proper way. And I can select all these and go to sub-D tools and use again the multi-pipe. Maybe radius will be 3, I don't know, to have it bigger. 3 is not, maybe 10. Yeah, 10 may be more interesting. So, and I have something like that in this case. And also the thing is actually, it's quite fine. Yeah, basically this is your multi-pipe object. So, but this is the side story for us as well. I will delete them and select these, and I can use zoom selection command, ZS, it's short K, to focus on it. Now rotation around this object. So no, lines not being grouped. It's just a polyline. It was a polyline. That's why it's like a whole object, which is from different things. So group, you can use also group command in Rhino, but group you mostly use when you have like objects like that, and you can group them using this command. So it's ungroup basically, and this is the group. And now it's like a whole group. When you select one, you select everything, and you can ungroup them. But when you use explode, it's explode your initial object to subject objects. For example, this is poly surface, basically. It's called close extrusion, but close extrusion is also the poly surface. And you have these sub-objects inside it. And they are a separated NURBS element. And when you explode such things, you will have these elements separated. The same for polyline. By default, it's like a object itself, but it's created from different segments, and you can explode it. The same for sub-D, actually. I know for sub-D is not working this way yet. Yeah. In subd, you need to use another command. It's called extract surface, I believe. Yeah, extract surface. So, basically, yeah, sometimes it's a little bit different approaches for different type of objects, but exploding, it's working for polylines, for poly surfaces. So if you have this poly word in the name of the element, it probably will work. Okay, then let's go for some commands which we have here because we're gonna use them. And first of all, it's remove subd or mesh crease command, and the same command they have to create crease. So basically, I don't know why there is the gap between these two commands. I better to put them together, one to one, but I will start to this. And there are two options: add soft crease and add hard crease for subd. So basically, I first to show you a hard crease, and it's a right-click mouse on this icon, and left-click it's to create a soft crease. So basically, okay, filter I disabled, it's fine. So I right-click on it, and then I will select maybe this point, Control Shift, because I don't use selection filter right now, and to select just this vertex and right click again. So this create a crease for me on this subd. It's like a representation. If you switch to the flat mode, all the objects are creased right now in this mode, let's say. And here we can manually crease just one sub-object or a few of them. And for creasing, you can either pick the vertex or vertices, of course, or you can pick edges to make creases. So for example, if I pick all these, let's say I enable this again, sub-objects and curve and edges right here, and I select these edges, and again, I will use add hard crease to subd or mesh command. So basically, you can either use this option or this. So actually, this menu probably not available for you. How to have the same as I have. I go to the option and go to the mouse options. Where is the mouse? Here. And for middle mouse button, I use most recently used commands pop-up menu instead of the standard pop-up toolbar. So it's up to you. Actually, this one is also a lot of people use it, but I'm personally not really like it. I prefer this one. It's up to you what exactly to use. And this one allow you to create your own menu with frequently used command. And when you middle mouse click, you will see this menu. You can add some commands there and use them whatever you want. In my case, when I press middle mouse button, I see recent use commands. So for example, last command I used it was options, and I see it right here. And before I used add hard crease to subd or mesh, I also see it right here on the third place. Before I used explode, ungroup, etc. So basically, this is really flexible approach for me because I usually use one command multiple times in a row, but in between this command could be another command. So I can just repeat it using right-click mouse. I can use this menu to go back to a couple of commands and use it again. So I selected these edges and then add hard crease subd or mesh, and I will see this result, for example. And this is quite different from this mode and this because the neighbor elements are not creased. And I see this kind of difference right here. So it's also quite interesting. Then if we speak about soft edge, so the same command, but left click on it, it's working similar way. You can select this stuff, then right click, and then I have this percentage on different edges. And I can say, so, okay, make a crease, but not 100% heaviest crease, but let's say 20%. and it will be something in the middle. And on the other side, I actually even can create, in this case, it's not really possible, but sometimes you can, for example, this edge with 1%, this with another, you can repeat this command. And you see here is 0 and here is 10. And you can try to make it like it's measured on the vertices, of course. And you can try to make it more like 50. So we will see something in the middle of this smoother thing and this thing. Sometimes it's also quite useful. Yeah, and if you want to delete this crease, you use this command. You can just, for example, use this and select and right click, and it's going back to the initial situation. The same here. Here is nothing actually. Okay, probably it's fine already. So this is the thing. And we will use this later as well. So next command, it's expand edges. It's also quite useful command. When you go here, you need to select the edge like that, for example, and press enter. And it will make two edges on both sides of it. So basically, it's create like offset from your edge. But the thing is, I not recommend to use it this way. If you gonna use expand edges command, you need a situation where it's actually create the expand, but for the whole loop. Let's say if I select loop like that and then use expand edges, it will keep my structure as it is. If I just use one edge like that, I will broke my sub-D network. Let's say my all these wires will be divided by 2, 3, so it's not a good situation. I will explain you later why, and we will see some things as well. So, but the command itself is quite useful. Bevel, it's a similar thing, but it's easier to show you maybe on a cube. And I will go to the flat regime. And then, for example, I select this and this edge and use the bevel command, and it will be create for me such thing. It's also kind of offset, but it's also angled the initial faces like that. So, and you can see how it works in a smooth regime as well. But also in this case, it's a bad approach because here I have the weird situation with the polygons. And if I want this, it's better to use the whole loop like that. And then use the bevel command. So now I have a nice shape. Of course, sometimes you need to block your shape in the way I shown first, but do it only if it's really necessary. So then what we have here is a crease. We already know it. Insert. It's allow you to insert additional edges. For example, I have, say, this kind of loop, and I want to insert another loop right here. So it's allow me to do that. And then I, for example, double click again on it to select the whole loop and insert edges again, can create another one. So basically it's like that. And you can see the difference between this and this. So if I try in the smooth regime, the same. Also select the half of the loop. This one is not possible to select by double click because we have a division to here and here, two directions, and we need to select additionally using shift button. And then I again go insert and put it right here, for example. And here is already the proper loop. I can double click on it and, for example, create another one. So sometimes you need to make it more dense for your structure. How are you able to right click to go back to the process you're doing on sub-D? No, for go back, I use Control Z. not right click. Right click, it's repeating your last command in Rhino. So basically, Control Z, as on any other software, it's undo your actions. Okay, I will not show you all the commands here. You again can use the help, and it will show you how one or another command working. I only show you some stuff we will gonna use in this workshop. For example, breach command we will need. So it's this button. And for breach, you can select, for example, one polygon. So I go to highlight surface and faces to select one polygon, then shift and press another one polygon right here. And then I use the breach command and it will connect it for me. So basically I can add segments in between. You can see this. And you can also use creases like that, but better in this case, probably not. So, and the strengthen. You can also check how it's working. It's like a tension between initial faces. So you can also connect polygons from other element. Like for example, I can connect this and this. Also shift and then breach. So in this case, I don't need both of them. That's okay. And now if I disable sub-objects and the whole selection filter, this is the only one sub-D, like a object which is connected like that. The thing is, you cannot use breach in the situation when you have, again, switch on sub-object and enable the selection filter. When you have different amount of corners on the polygons. For example, if I gonna use breach and select, let's say, this polygon and try to find the situation like that. Don't really see it where we have. See, it should be somewhere, but all of them with 4 corners look like. Okay, I will try maybe first make this. Yeah. So now we have this, for example, polygon has 1, 2, 3, 4, and here is the 5th vertex. And if I try to, for example, breach this guy to this guy, it will not be possible. Nothing happened when I finish this command because amount of vertices between connected polygons should be the same. And for example, if I try to select this and this, again, it's not working. Why? It's for here. Let me check this and this, for example. Select first. Okay, let's see. Yeah, it's working. I just selected them in the wrong way. So again, here and here, it will not be possible. And if I select here and here, it will be easy connected because both of them have 4 vertices. So it's something like that. And maybe last command I will show you before we start modeling for real. It's symmetry. This one is quite a fun command. I will go probably on the top view. Also, we'll switch to the shaded mode. And then I use this symmetry command. Then it's asked me to select sub D. And then I need to create reflection plane. If I go to the perspective view, you will see this is the plane, not just a line. On top view, of course, it looks like a line. And I can put it however I want, for example, like that. And then right click, this is my initial plane, was here, and this is my symmetry plane, let's say. And now if I will change one of the element on the one side, it will be changed exactly in the same way on the other side. It's like that. When I'm done with this approach, I can apply the symmetry. So if you right click on this button, remove sub-D symmetry, and then select your sub-D, right click again, you will see this like whole object. And now if you change one element on one side, it will be not reflected to the other side. We decided to angle before move. Not really understand the question. If we speak about this moving, for example, and this angle, it's about arrows. So where arrows directed, you can only move this way. But of course, there are a possibility to do it on angle you want. First of all, for example, you can a little bit adjust this gimbal. If you click on this menu circle, you can align to object your gimbal, and it will be perpendicular to your object in this case. So it's one way. If you don't see, for example, this menu button, you can also right click on the gimbal, and you can see the same options right here. So basically, it's one way to do that. Another way, gimbal is just for sketching, let's say. It's not the element or command which you can really do the precise scale or precise moving. Of course, you can, in some cases, if I want to move it in this exact direction to 5 meters, I can just click on arrow, put 5 here, and it will be moved on 5 meters. Or if I want to extrude, I click on this hatched circle, put, for example, 20 meters, and it will be extrude for 20 meters. So basically, in some cases, you can do the precise moving or scale, just not to drag the element, but click on it. And you can scale it in, for example, this scale. So basically, same with the rotation. Just click instead of dragging the rotation axis. And for example, I need it for 15 degrees. And you can do that this way. But in some cases, you need to use other tools. For example, these tools for move the element, and these tools for rotate the element, and these two for scale. We can use some of them later. And for example, if you need a specific direction for moving, what you can do, you can go to the front view, let's say, and then you can use the move command, click on the initial point for moving, and then you can decide what direction you want to move. And to fix the direction, you can press tab button. Then it will be only stick with this direction. And then you can provide how many meters you want to use, for example, 100. So 100 is this distance. So and press enter, it will be moved to this point. So basically, it's like that. It's how you define the direction for moving or for something else. Okay, yeah, quite a tricky structure we have right now. And I think before we continue, we can make a break. It's everything about sub-D introduction. And we're gonna already create our own structure, which is not that abstract. And now it's 6:40. Let's make a big break for 15 minutes right now. And 6:55, we will go again with all this stuff. Okay, let's continue. I see the question about the prompting for different models. I think we for sure will return to ComfyUI during these two sessions, and maybe it will be like, let's say, more handy to show you there some stuff and answer these questions, and now switch back. So if I forget about that, will forget, just remind me when we switch to ComfyUI, but I think I will remember. Okay, I will delete all the stuff. So right now I gonna switch off sub-object and disable selection filter. So I don't need it right now. I select the whole sub-D we did and just delete it. We don't need it as well. So I have this layer image and double click on it to make it active. Then I will go to the front view. So my views are here basically. And it's perspective, top, front, and right by default. Of course, you can add more views, but it's enough for us. If you would like to add a new view, just right click on any of them and make a new viewport. So you will have another one. And then when you have the viewport, you can go to the set view and assign one of the projection like top, bottom, left, right, etc. Okay, but I think this should be enough for us. Right now, I on the front view. I will switch to that. And I need to put my initial image, which I have. I need to copy it for myself. The class 1 file, and it's right here. So basically, this image you have on Google Drive inside of the Rhino folder, I believe, in the files, then Rhino, and then you will have this image. Let's copy too long. Okay, yeah, and then you can just drag and drop it to your Rhino canvas. And you will see this small window. Actually, there are several options how to use images in Rhino, but we just need the first one, picture. Press OK, and just make a kind of rectangle right here, close to the center of the coordinates. It will be good enough for us, I believe. So then when we have this image, the size for now should be abstract. We will adjust it a little bit later. Yeah, for Google Drive. Thank you for sending. And then I will create a new layer, which I will call grids. And double click on it to make it active. So then I will use the polyline command and just make the simple grid for my main, let's say, sizes of this object. So first I will create a kind of horizontal grid anywhere and right click to finish the command. And maybe I put it on this bottom of the pavilion right here. Then I gonna copy this line. For copying it, I can press Alt on keyboard and press once on this arrow and provide the size of this pavilion, of the height of this pavilion. Let's say it will be 5 meters. That's probably enough for me. So it's just remember my last input when we did the abstract sub-D, I moved something on 5 meters. So I think the 5 meters for this pavilion, it's good enough. We can keep it like that and just press enter. And we will see this is the 5 meter span. So now I need to scale my image to have this exact height for the pavilion. So how I can do that? I need to select the image itself, and then I will use the scale command. So there are several options for that. It's scale 3D, scale 2D, scale 1D. So basically, 1D we don't need because it's only will scale the image in one direction. We need to scale the whole image. And because this is the 2D object, it will be work the same for 3D and 2D scale. There is no depth for this image. So basically, doesn't matter which of two using right here. So basically, they're working the same way. And then I click on any point on this curve. It will be my base point for scaling, like that. Then I need to provide scale factor. So for that, I press Shift to make it directly vertical, this line, and hold the Shift. Shift is like an ortho regime. So when you hold in the Shift, you not have these angles for the line. And I press the Shift and press right here to the top of my pavilion, top of the, let's say, bottom of the roof of my pavilion, top of the ground floor. And click again. And then I click third time in the top line to scale it to this. So this is the idea. In between these two lines, I have 5 meters. And now I have kind of 5 meters right here. So then I will select these two elements of my grids, and I need to make it shorter probably. For that, I will press F10. It's a functional button, not any keyboard has it. So if you don't, you can use also this icon, control points on. It's the same as F10 on the keyboard. So when you do that, you will see these points on the sides of your curves, and you can make it shorter, just move it through the gumball this way. And probably I select everything and put it closer to the origin point. So this is the origin point of my file. So somewhere here. And this my two first grid. Then I will copy again. And now I don't need to provide the specific sizes between grids, just do it in a more abstract way. I put another grid on top of the whole structure, somewhere here. And then I will create a vertical line, also using Shift for ortho regime and right click to finish the command. So it will be on the side. Another one, again, Alt to copy. And another one I will provide maybe right here. Here I actually don't really need it, but okay, I leave it here for now. Maybe it will be useful. And another one right here, and maybe one more horizontal line to a place where we have this kind of intersection. So this is my grids. And then I will create a new layer for the geometry. So basically I call it maybe geometry for now. It will be my 3D objects right here. Double click on it. It will be my active layer. So now all the objects you are creating, they are going to active layer, which you highlighted this way with this mark. And basically, if I, for example, switch off grids, I can see all of them in this layer. The same for the image. So basically, these two layers, I don't need to modify them in future. And to not do it accidentally, I will block them using these padlocks. So basically, I will close these two layers. And now it's not possible to select this object or somehow modify them until I will unlock the layer. So basically, this is really handful in the situation like that, when you have like background objects or objects which are already defined and you don't need to edit them. So it's better to log them, because otherwise you can just accidentally select them and move a little bit. So it will be not good for our situation. So then in the geometry layer, I will start to modeling basically. And for modeling with sub-D tools, and these tools which we're gonna use right now, um, there are basically about 3 different techniques how to do that. And I go to perspective view to show you some ideas for that. And you don't need to repeat this small part, which I will show you right now. So the first technique is basically, we already kind of do that. First, you can create the primitive object, primitive sub-D object, like a box, and then you some kind of modify it to create something else. And this is one of the really basic technique. And from the box, you can create actually a lot of different stuff. And this is the first approach how you can start modeling with the sub-D. Just make a primitive. If, for example, you have several objects on the plot, you can create several boxes and start with them, maybe connect them with the bridges or somehow modify them. So this is the one approach from which you can start modeling with sub-D. Another approach where you can create just one single polygon. So for that, you have this command. Before we used create sub-D plane. It's a same approach as for polygons. It's like already kind of an object from which you can start, but it's a little bit different. You can also start with the sphere, but this I not recommend, because, for example, if you start with this object or with this object, you can see the topology. It's kind of straightforward. All these um, lines are parallel. And when you, for example, double click, you can select the loop like that. And it's easy to modify this stuff. For sphere, it's a little bit different, because you have situations like that. And it's already not really convenient for modifines. So because if you, for example, double click, here you have an interruption point. It's one direction or another you can go. And this is not the best way for starting your geometry. And basically, when you're working with sub-D, try to keep it as simple as possible until you reach the point when you need more details. So you first need to create your initial shape in a quite simple way, where all the lines of the topology are kind of parallel. So parallel, I mean not exactly parallel. For example, if you move it this way or this way, these are not parallel already, but in the topology point of view, they kind of still parallel, and you can work with them in the pretty simple way to modify the sub-D, to add some details, and this is the good way how you can keep your topology when you have just 2 directions of your edges. So it doesn't matter they a little bit declined from these directions, but in general, you have these just 2 directions without the point where you can split the way by 2 or even 3 different possibilities. So basically, this what you need to keep in mind. It's better to have topology like that. It will be easy in a lot of different cases to work with sub-D. And so you can start with the simple elements like that. I don't recommend sphere or cones or something like that. So either plane or box, and then modify them. It's the first way how to work with sub-D. The second way, you can start just with the single sub-D phase, and you can make it this way, for example. And then from this phase, you will create a more complex geometry. We will use this method right now. That's why I'm not going into it in this abstract sample. I will show you on this object how we will do that. And the third method, also we will going to use them. This method, we can start with the curves like that. And then from curves, you can create the sub-D geometry, for example, using sub-D loft like that. So this also an option. But We'll also use this method on this geometry. So basically, these three approaches, and we will start with the single sub-D face. This will be our goal. The only thing, I probably unlock the image for now and move it back a little bit, because we will need this space for depth of the structure also. And for depth, I maybe will create another grid. Let me check. So I think 10 meters will be good enough for us. So I will lock the image layer and unlock the grid. And basically, I will press Alt, press on this arrow, and copy it on 10 meters. So like that. It will be our depth, but we will need it in future. So grid, I will lock again. If you copy the object which is on the layer, doesn't matter this layer is active. They will be in the same layer because you copy the object with its properties, let's say. So layer one of the property. Okay, I go to the front view. It's from this side, basically. So we probably need to move image on the other side. And the same for these. So it will be 20 now, because 10, 10. And look again. So front view, now everything is fine. And yeah, we will start with this single sub-D face. So I will put it somewhere right here. So 1, 2, 3, let's say. Actually, I try to do it again and to not snap to this image because it's on the back. I need to put the object without snapping. Maybe I just disable all these snap options right now. If you're not snapping to anything, and I need 4 corners, basically, and right click to finish it. And if you're not snapping and you go to the perspective view, it will be on this axis. So it's like that. And then on the front view, I see the direction, normal vector for this face. It's on the back. To put it on the right position, I need to flip in this face. I can just use the flip command, just type it on the command line and flip it on the other side. So now it's better. And go again to the front view. On the front view, I don't see the geometry because here is the wireframe mode. I probably switch to costed to have a little bit of transparency in between this face and the image. And in the costed regime, your face is a little bit transparent. So they're not exactly like on the shaded view without transparency. And I prefer right now is this regime. Also, maybe for geometry, I will change the color to like blue. Have it like here. And another thing, I will probably unlock the grids, select all the elements in this layer, right click on it, select objects. And for these exact elements, I don't want to have them in the hosted regime, which is assigned to the whole view. I want to see them as thicker line. And I have this regime, for example, thick curves. So probably for this exact object, assign this regime. To do that, I need to use command, which is called set object display mode. And then by default is use the view mode. I will click on it. And instead of the hosted, I will pick the thick curves to make it much thicker. So basically, and block it again. It's what I need right now. Then I will switch to the flat regime to sub-D. Press Tab key on the keyboard, like that. And I will go to the selection filter. use again subobject, uncheck disable, and I will not need surfaces, but I will probably need points and vertices basically and edges. So then what I'm gonna do, I will just use this command on the gumball to extrude the edge from this side. The only thing I probably need to use menu and align this to object. I already did it basically. So if you don't use this right now, either using this small circle right here, click on it and align to the object, or right click on the gumball and it will be the same menu. So I have kind of weird representation of the bottom of okay. Okay, it doesn't matter. Okay, I will select this edge and kind of extrude it, then move it a bit right here. And then again, do that. So I will need to more or less repeat this structure this way. So here I maybe need to rotate it a bit already. Like that. You shouldn't be really precise. You also can scale it this way, but we just approximately cover the structure. Also probably need to scale a bit. Actually, I don't need the whole surface. I only need the thickness right now. I'm wrong a bit, so make it less. So also just select one lattice. So here it's I have to put it this way. So and yeah, I think it's okay. And maybe here also we don't need all of them. Only this thin part. Okay, this I think good enough for me. And go next. Oops. So we need to spend a bit of time to make it, but not that much actually. It's quite easy by in the end. And for now, I'm not trying to be really accurate, because in real life you maybe can do it in a more precise way, but also can adjust it later. I will show you and we will do some stuff like that. So for now, it's actually good enough to be a little bit abstract. So, and we are reaching the point of the intersection. It's not like a real intersection because in some point, somewhere here, it's starting to go behind of this structure. And yeah, we need to also make it three-dimensionally. So if I go to the perspective view, I see the situation like that, and I need to put this element on the back, so somewhere there. So basically, the thing is, of course, we can just move it polygon by polygon, but and probably we will do it for some things if I use this checkbox to select the faces as well. And through the Shift command, I will select a few polygons, maybe these, and move them down, not down, but back, like that. It will be my starting point. But of course, I not having here the smooth transition between them. And even if I go to the smooth regime, it looks like that, which is not good enough. And we can do it partially, um, just manually, of course. But maybe sometimes better to use additional command. And there is one which is called soft transform. And we can just type it and pick it, soft transform, like that. And then this is the radius for affecting soft transformation. We don't need to make it too big to not affect these elements actually, because this part we should keep as it is. Maybe I will write like that. And now if I will move some elements, maybe now I need to switch Gumball to the normal regime, not aligned to object, but aligned to world. And now it's a little bit smoother for moving all the elements around it. And I can do it more accurate, more interesting way. So basically, to keep all the elements on the proper position, I probably go to the right view to make it also more accurate right here. And soft transform, it's actually working until we switch it off. So now it's working basically. And yeah, I believe this curvature is good enough. So also we can check from the top view how it looks like. So maybe I will push this a little bit back. But the rest part seems fine to me. So basically it will be like that. And then I need to go again to soft transform and switch it off. So smooth. Basically it looks like it's not really worked before, but okay. Um, Let me check again. Transform. Yeah, it's enable, yes. Yeah, I need to switch it off. Now is no. And there is basically a few regimes for that. If you want to know more about that, again, you can go to the help menu and you can just check what we have for smooth transform. And there are, yeah, this is about regimes. You can see the difference between them. So we use the smooth regime, but others also work in a different way. If you pick this option, you can pick one of them. So, but this the idea of it. Then I will go back to the selection filter, enable it again, and uncheck the surfaces and go back to this transformation, let's say. Yes, sub-objects I also need. And go to the front view. And the same approach, tap to see the flat regime for the sub-D. And here I again need to align it to object. And just this way. And maybe actually here I need to make it kind of wider. So something like that. Now let's say this and go this. Will be my bottom part. So we will probably adjust it a little bit later. And yeah, to have bottom part flat without this angle, let's say I can select this point and use this small square to scale 1D, these objects, and press on it, and the scale factor should be 0. In this case, it will be the average position in between these 2 points. It's actually the trick which any 3D software using. You can use the same in Blender, in Maya, in somewhere else. So basically, if you kind of scale 2 different points by 0 scale factor, it just find the average position between them and then align them on this position. So this is the thing. And probably I can also scale these 2 guys the same way. So scale 0. So basically, because direction is like that, it's scaling this way. If I go to the menu and align to the world and scale them this way to 0, this will be scaled this like that. So this is the whole idea about that. And maybe to make this thing more narrow, I will need to insert one edge right here and also scale these 2 points to 0. And this point I will move somewhere here. So let's check. Still not narrow enough. Yeah, maybe I need to insert another one edge right here. So then you can just a little bit adjust your result. So you can already go to the smooth sub-D regime and make in some point this surface wider if you want. So I would say it's good enough for me right now. So then to this edge, I would prefer to make a hard crease. So this button and right click on it to have a hard crease here. Oh, it's not working. Let's go again. Crease. Okay, then I need also select these vertices, not just edge. So, and also make a hard crease on them. Now it's working. And the same for this part. Also add hard crease, right click on this button. So basically it's this. And I would say I'm good with this shape. So let's keep it like that. So maybe here is a little bit not accurate, and you can check again on the right view. for example, and top view. But for exercise is good enough, I would say. So I will keep it like that. And then let's create another part of this framework, the bottom part. Again, go to the front view. And in this case, I will use another approach. I will, yeah, it's disabled, it's okay. I will just use curves to define the beam itself. And then from these curves, we will create the sub-D surface. Using shift right or not? Don't understand these questions. So shift you're using just for two cases. When you want to select a few objects, for example, you select one, and to select another one in addition to that, you can press the shift. It's one situation. Another situation, when you create the line, for example, when you use shift, you can make it in the ortho regime to not switch on ortho manually every time. You can see this button, switch on, switch off, when you press the shift. So let's make a curve. I will create the curve through the point. For that, you can either right click on this icon or use the small arrow below it. And use the second icon right here. There are several options to create curves in Rhino. So basically, you can create it through control points or through points on curve. And if you now work with Rhino, the difference is if you use through control points, you see this is your control point, and the curve not exactly there. It's somewhere else. And this is one option. But when you select the curve, you see again these control points. And through them, if you select, yeah, it's probably I have a selection filter. Yeah, let's disable it. So if you select this control point, you can modify the curve. So, and this is the first regime, how you can create the curve. So the second regime is quite different. You don't see the control points. You create curve through the exact points you place in. But when you select, you again have this control point somewhere outside. You not control them from the beginning, and it's just calculated automatically when you create the curve. So it depends what you want to achieve. Sometimes one regime is better than another, but right now I want to just repeat the existing curvature. And in this case, I probably better use this regime when I put the points, and curve will be exactly going through these points. So I will pick this, and then it's disabled. Good. This one is disabled as well. So then I will start to create my second element. It will be this one, and it started somewhere here, I believe. So maybe even here, and I will create it this way. And here is not really visible, but it's probably somewhere here. And then we will go, I don't know, this way. So this will be my curve. I can check the curvature. Here is not that accurate. I maybe a little bit adjust it. It's fine. And also we need to put these points back to have this shifting as we have for this beam. And there is also a command for curve soft modifying, and it's called soft edit curve. So I will use this command, soft edit curve. And then I can select the best point and then the kind of radius I should provide, for example, 20 it will be. And then when I modify my curve, it's affected the closed control points as well. So basically, what I'm gonna do is just move these elements somewhere back, even farther than for the first beam. So basically, I will provide this direction for moving and fix it using the tab command. And then I can move on the exact position, for example, somewhere right here. Then I will select the second point, the curve, and already tried to move without soft transformation. Something like that, probably. Maybe more, just a little bit on the extreme positions. And then I will adjust them. Okay. And go to the top view to make it more accurate. So maybe I again press F10 to always have this control point, or you can use this button, control points on. So from this view, it's good enough for me. From the right side, I maybe need to make it more interesting here. Okay, I would say it's fine. So it's fine. We now have interesting accurate curve. I press escape twice to switch off the dots. When I select the curve, it's anyway will showing. So basically, this is my second curve, but I need to have another one curve. So if we see this surface, we already have two borders of it. In this case, we have only one border. And to create another one, I go again to the front view, and I will need to offset this curve outside. So to offset it, I use the offset command. And then I need to provide a distance. So I can do it graphically. By default, it's 1 meter. But if I just press it right here, I can pick the one point and second point to the exact distance I want. So it's a graphical approach to provide the distance. So maybe 1 meter is not good enough because in some cases, it's maybe average position. So it's good. I will keep it 1 meter or about 1 meter. So it's 0.87 in my case. And the second option, I need to switch on. It's loose yes. By default, it's no. And I need to put it to yes right here and press enter. So basically, I don't see the result actually. What happened? Try again. Lose yes. Yeah, now it's fine. I just probably canceled it before start. So what about this command loose offset? When you have any curve in Rhino, let's say I will make the abstract one like that, maybe to make it more visible like that. So when you offset this curve, you can do it by default with lose no command. And if you do that, when you select this curve, you can see a lot of control polygons right here in comparison to initial curve. It's like 1, 2, 3, 4, 5, 6. And in the new curve, it's a lot of them. And basically, it's because algorithm tried to make distance equal in all curve longitude, let's say, in all places. It's try to keep this exact distance which you provide for offset. But when you have another approach, like you use offset but with the loose command, you will have exact amount of control points in the end on both curves. But the distance is somewhere in not that they're not that precise as you provided for the offset. And for us, it's good enough because we are kind of sketching right here. We don't need precise distances in all positions for this curve. And for us, it's much more important to have the certain amount of control points, not too much of them, because otherwise editing of this curve will be terrible. If we will try to edit this curve, instead of just, for example, a little bit adjusted in this case to make it wider, here we would need kind of do it for a lot of different points one by one, and or use soft transformation. So it will be much more difficult in this situation. So we basically stick with the less amount of control points. So this is the idea of the loose offset approach. And right now, what we have here is these two curves. To make it even more smoother, I will try to rebuild them to make positions of these points more equal spread it on this curve. So let's say I will have, instead of 18 control points, 12. And you will see the difference, but the smoothness of this curve will be much more accurate in this case. So I can see the result right here. And by the end, we need to adjust the second curve because in different situations, it's somewhere wider, somewhere it's vice versa. So basically, for example, here it should be wider in this situation. And here is an opposite. So it's close to each other. Maybe both of them. So maybe I use another color, like green, for example, be more visible. Again, I don't need to be very precise right here. Maybe something like that will be good enough to me. And then from these curves, I need to create sub D. So basically I go to the, again, sub D tools and create a loft between these two curves. So this is the create sub D loft. And it will create for me another surface, let's say. Basically, it's like that. Of course, I also need to adjust it a little bit to make creases here and different stuff, but you already know it, so I will not repeat it every time. So I just showed you approach, which we have right here. And what we missing for these elements is thickness for these surfaces. So I probably do this thing right now. So to do that, you can select, let's say, one of them first and use this command offset sub D to make it thicker. And then you need some options here. So first is the distance, 1 meter. Maybe it's good enough for me. Solid, I press yes, and both sides press yes as well. So basically, delete input probably yes as well. If I already find better, actually in real work, press no here, because in this case you will always can go back and change something, and then offset again. So if you don't like the result or something like that, but in my situation, I'm just demonstrate, so I don't need additional object behind it. So I probably better to delete input in this case. And let's see what we have. So maybe 1 meter is too much. I Control Z this command and run it again. So offset sub D. And the distance probably should be like 0.5. So this is better. We have a gap here, I would say. And it's created creases on the sides, as you can see. Maybe even 0.5 is too much, but doesn't matter. Let's keep it like that for now. And for the second element, do the same, offset sub D. It's already remember all these options. Just press OK. And we have the second beam right here. So to make it kind of more interesting, what we can do, I can go to the selection filter sub-object again and enable it and double click on one of these edge. So something like that. And then I create the new loop, insert sub-D edge loop using this command and put it right here. So check in the other regime. That seems fine to me. Then I can, again, double click on it. And you can, for example, move it a little bit on front to have this situation and make it also with the crease. So I will put the hard crease, right click on this button on it. So I will have this situation. Do the same on the other side. Also insert, put it somewhere here, double click and add the hard crease on it. So we will have a little bit more interesting shape this way. So you can do the same here for this element, also maybe adjust some points because they're kind of twisted a little bit here. And in general, it's of course require much more attention to the shape, to the curvature. And then when you create a real shape, you will spend more time for that. Also, if you can see on the image, we have kind of connection between these elements right here. We can try to do that also. So basically, I maybe move this a little bit right here. And maybe I will provide additional loop somewhere here. Maybe another one as well. Like that. And let's say in between this polygon and maybe this, I press them through the shift, I will create a bridge using the bridge command. Maybe they are too close here. I kind of twist it. Let's cancel it. Maybe I can use these and these. They are more far away from each other. Let's try again. Check. It looks like not really cool actually. Let me try maybe these two. This seems better. Also not quite good. Yeah, it's probably maybe I cancel a couple of commands right here to not have it on the bottom additional shape right here, and first make a bridge between this and this. Let's say Yeah, this is better. The only thing it's too thick. Maybe I will first create additional loop right here. And then it should be good enough to me. So bridge. Yeah, now it's perfect, I would say. I'll go to the render preview. Seems quite fine. And then we can create additional creases and loops on this thing, so it will be the goal. And of course, this looks quite not interesting, so we can adjust all the elements, but you already more or less understand how to do that. And this is the approach how to make a framework basically for this shape. Just in case, I will save this model right now. Mm. And on Google Drive, there is a model which is already finalized for all this sub-D work, for all these elements. I can try to find it right now. It should be this one. Can I copy it also here for myself? And I'm gonna open it instead of this. So basically, here is all the elements already modeled. You can see them. There are some surfaces in between the elements. Basically, these surfaces I only need for Grasshopper. Ah, no, it's only also glass surfaces. Okay, not only for Grasshopper. So if I switch them off, I have this framework. So this framework made totally the same way as I shown you right now. You can see this transition which we did. You can see these first two beams and other two or three or how many of them I not even counted them made the same way. So basically, I just spent more time here to make it more accurate with the better curvature and etc. etc. This file you can find on the Google Drive, and we continue working with it. So you just can open it instead of you have right now. Save your model if you followed me, and you can try later to do everything yourself in the same way as we did right now. But basically, this is the model which from which we will continue. So this is quite simple. Also, here is added the small pavilion. This pavilion made a pretty simple way. I can show you quickly on the side. So if I go to the standard tab, I can create the ellipse using this command. So ellipse, something like that. And I will switch to shaded mode. And then on the, let's say, front view, you can create a profile, which we have right here for element and using just a curve command. And we need a snap here. So for example, profile like that. It's for glass, and for this cap, you will need another profile. So it's something like, I don't know. So I will not go really accurate with it, but something like that. Okay, let's say it's this one. And then we will need an axis for rotation. So basically you need to use center or snap like that, then control and click to the same point to make a vertical line like that. Then you need to trim these to this line, and using that you can use the trim command, then select cutting object, and then select object to cut. No, sorry, it's again cutting object. Press enter, and then select the part you want to cut, like that. And you have this profile. And to make the whole shape, you need to use surface revolve, then select the curve to revolve. It's our ellipse. Press enter, select the axis, and basically, sorry, I skip one thing. Select curve to revolve, select curves to revolve. Okay, I'm a bit confusing. Let me check. Yeah, I'm wrong with the command. I see. Rail revolve I need because here is no rails. That's why I was confusing you. Just revolve by a circle anyway. So I need rail revolve, and here I select the profile curve for revolving. It's this thing. Then I select the rail, and then I select the axis. So this is my glass, let's say, and the same for this part. So I select the profile curve, I select the rail, and I select the axis. So basically it's like that. But of course here is more accurate. And so what I had here is this cap, which made with this profile, and also I have this glass, which made with another profile, but both by ellipse. So basically this is the simple approach for this pavilion. And then we just need to add a few details, but for that we will gonna use Grasshopper already. And to launch the Grasshopper, you can use this command, launch Grasshopper. So, and then if you see just empty window, press File New or Control N to create a new file like that with this template. If you assign this template already, I have two of them, so I just close one. So the template itself I've shown on the beginning of this session. If you skip the beginning, you will see it on the records, but basically you don't really need these elements. It's just for some tips to which color use in different cases. I will explain it later. And then what we're gonna do first, we will create a few trusses in between elements. So for example, I will start to create trusses for this surface. And first I need to provide this surface as an input parameter, let's say. And all my inputs in this quarter of the canvas will be. So basically, this is the sub-D surface. And to connect it to Grasshopper, I need to use one of these containers. So there are containers for primitive elements like numbers, text, etc. And there are containers for geometry. And this is the sub-D geometry. I need a container for sub-D. And this called like that. All the containers are black nodes in Grasshopper. So I can put this one with the sub-D. We can see the icon. If you don't see it, you go to display and draw icon. And instead of this text, you will see the icon itself. And to put this geometry to this container, you right click on it and set one sub-D. If it's already selected, you will have it immediately here. If it's not, it's provide for you an option to select it, and you will have it anyway here. So this is our sub-D. And to use this sub-D in the script, you can directly connect it to anything. It's also an option. But I prefer to use telepathy to organize the script in a better way. So telepathy is the plugin for Grasshopper, and it has just two nodes. It's a sender and a receiver. So in our case, I will send information to other part of the script, and that's why I will use sender. And put it right here, connect my sub-D to this sender, and I will rename it. So for import object, I always use this prefix, which is import, obviously, and then I name the parameter whatever I want. So in this case, I will call it sub-D. So all these prefixes I use, you can find in the template right here. So for example, import data, it's this prefix. So basically, this is my import geometry. And when I select it, it's somehow highlighted right here. You can see that. And basically, I probably hide these elements for now and only see it from Grasshopper. If it's not selected, it's also visible from the Grasshopper, unless I will hide it using this command by clicking middle mouse button, or Control Q also on your keyboard can hide and then hide the information from the node. So basically, this is the thing. And then I will start with this element to create my script. I double click on this node and it will create a receiver for me. And the definition itself, definition, it's a name for workflow in Grasshopper for your script, let's say. It will be in this quarter on the canvas. And I put this import subd right here. So to show you the names of the node, I will use another plugin. You don't need it. It's called Bfocals, and it will add some names of the node. You can use them to find this node by double click on the canvas and then type this name. So for example, remote receiver. It will find it for you. And if you don't know where is the node on the palette, you can just double click on the canvas and use the name of it to search for it and put it there. So basically, is what I'm gonna use. Then I need to create a mesh from this subd because subd is good for modeling, but it's for Grasshopper scripts. Usually you have different functions just to operate with mesh or North geometry, not working directly with subd. And basically subd is also mesh. You just need you just have a different representation of this mesh. So basically, I better to use the proper mesh from it. And for that, I will use the node which is called mesh from subd. It's this node. And I connect my subd right here. And the second input in this node, it's actually the quality of this mesh. By default, it's fine, but I better to use really draft quality like coarse, not extra coarse, but coarse. It will be fine for me. It will be less polygons right here, and I probably better stick with that. And the only thing I can, not sure what I have for the mesh, preview mesh edges. So display preview mesh edges, I better to switch on this command to see the mesh grid right here. So this density of the mesh probably is good enough for me. And I will stick with this number of polygons right here. So this one thing, and then I will use this mesh later in my script. So I will send it somewhere else. And this is already not the input parameter, is part of the workflow. So I will use the prefix W and then mesh. So I will use it later. Then from this subd, I also will need the borders. To take it, I will gonna use brep edges node. It's basically not for subd, it's for NURBS geometry for polysurfaces, but sometimes Grasshopper can convert data automatically, and it can take all these edges from my initial subd, and I can use them here. So it's like that, basically. And then if it's possible to join them in one places, because it's create all these small cars independently, I better to reduce this amount of cars to join them together, to use join curve node right here. And then on each curve, I will, yeah, and also important, here I use only output borders, let's say, not internal curves. If you can see, here is much more elements. We see some intermediate curves in between the surface, and here is only the border. So I only have the closed border of this surface. It's what I need at the end. And on this border, I would need a couple of, not couple of, but some points, let's say. And to put them, I can use divide curve command. So divide curve, taking a curve and like creating the point on it with the same distance between them. And here is the number of points. So for number of points, I'm gonna use the parameter, which is which will be called number of points. And let's say we will use somehow 16 points on the cursor, something like that. And I will, because this is the input parameter, I will gonna use another sender. So for parameters, I used prefix PRM, and then this is number of points. Like that, double click on it, and put it right here. So basically, of course, you can just directly create this slider right here and connect it. But the thing is, if you, for example, need to use this exact parameter multiple times in different part of the script, you can just use one slider instead of multiple. And then you can change the value of the slider right here. For example, I need more points or less points. And I can do it from one place. It's one thing. Another thing, all my parameters will be in the same place. If I gonna change the script itself, I don't need to find them somewhere, especially if you script quite big. So you know all your parameters is on this quarter. And that's why I use this telepathy to better organize my workflow. And it's just an approach how to keep it clean, let's say. So here is my divide curve node, and I already have 16 different points on this closed curve. It's good enough for me. And what I need next, it's kind of find for all of these points neighbors. And basically, I need for each point find the two neighbors. To do that, I first graph them. So graphed, I don't know, it's about your experience in Grasshopper, but in Grasshopper, there are data trees. It's like a structure for the data. And by default, for example, here you have just a list of points. So list is like a simple table with one column of elements, let's say. And the data tree, which we have right here, it's already complex table with multiple columns where each column represents at least inside this tree. So basically, tree itself is the like a root tree, root list, and inside of it you have a few others, or maybe even inside these few others you have others. So it's could be structure as with multiple branches, and you can represent the tree through this node. You don't need it right now. So for example, when you have just a list, it's a simple tree with one branch without any other possibilities. And when I use graph, I have much more complex tree. So I have one initial tree, let's say, and multiple branches from it. So basically, the thing is, when you just use the graph command, you put every point in the separate branch. And here they are in the same list. And it means if you will affect these points with one or another function, you will work with them kind of differently. And to maybe show it, don't really have a nice sample right now, but let's say, um, probably these both cases, all the samples will be worked almost the same way, but I will show you what I'm gonna do, and then what if it will be without this operation, so it will be maybe easier to understand. And what I'm gonna do is find for each point two neighbors, and that's why I need to separate them basically to all these points to separate branches, because otherwise they working as a whole list together. And here, after graph command, each point I put to just separate data structure, which is called branch, and it will be easy to manipulate with it afterwards. So then I will try to use closest point command, closest Yeah, closest points command, this one. And here is my input for the point. And here I will connect the list, which I have initially. And basically, here I need to provide how many points I need to find, how many neighbors I need to find. And this will be free. And by default, it's free already. So I don't need to change this parameter, basically. But if I want to do that in future, I maybe better provide a parameter. So it will be slider free, and I also use the sender, and it will be again rem, and I will call it number of neighbors. Okay, yeah, I think it's like that. Not 100% sure. I'm writing it right, but okay. So this will be my second parameter. And yeah, this is the thing, actually. And for each point, I have these three neighbors right here. And the first neighbor, it's point itself, because here is the list with all the points, including this one. And for Grasshopper right now, this list and this list are different. So doesn't matter, they have the same points. They kind of two data structures which are connected to this function separately. And basically here and here we have the same points. But the thing is, uh, it's searching three neighbors for each of these points in this list. And first neighbor will be the closest point, and this is the same point as for each we looking for a neighbor, and then two others. So it means I first, for example, if I'm looking for neighbors for this point, I first find this point itself in this list, and then this one, and then this one. They two are closer. So basically, this is the idea. But sometimes it could be a little bit different, because it's just measuring the distance, and maybe this point is closer to this than this one. So it could be also interesting situations right here. And basically, here we have a structure with simplify it a little bit to reduce the address. We have a structure with 3 points in each branch. So these three are neighbors to each other. And this kind of the idea of what we have right here. So basically, this is the thing. Then I'm have as an input distances between them. And those distances I want to sort from smaller to higher. And basically for that, and not even sort, I want to find probably the bigger distance for the last neighbor, let's say. And for that, I will use the node which is called list item, reverse the order, because right now in the first place located the smaller distance, and I need the last one, let's say. So I reverse the order of this list. And then I will flatten them to have a simple list again. So maybe it's a bit complex for those of you who never worked with Grasshopper, with all this graph and flatten. But I'm not sure I have a lot of time to explain it, because it's kind of complex topic as well for Grasshopper. But maybe I will stop a little bit on just in this case, and next not to return to this topic, explain this for you. So let's say I will have a few elements like these points. Let's say 5 of them, yeah? And they are in the box. And this box called somehow like 0. Or so this is the point and this is the 0. It's not easy to really draw it with the mouse. So this is the name of this box. And this in Grasshopper called list, this data structure. So where we have a box with a few elements, and this box has a name, basically not a name, but address. And the address started from 0. It could be another number like 1, 2, 10, 12, something else. So basically, this is called the list. And another one structure, it's tree, where we have kind of more complex box, which also has an address, let's say 0 as well. And inside this box, we have other boxes. And inside these boxes, it could be other boxes as well, or just elements, like points. And of course, each of these boxes also has addresses. This one 0, this one 1, this one 2, and again, this one 0, 1, and 2. And here we have no boxes inside. And this structure is pretty simple. It's just like that. If we try to draw a tree, so it's just one branch. Here is just more complex. We first draw this box with 0, then we draw this one, 0, then this one is 1, and this one is 2. And inside this box, we also have 3, so it's another one, 3 branches. It's like that. And here is our data, actually. So here located, let's say 1 point, here maybe 2 of them, here another one. So here's 2 points, here another one. And here we have in each branch, let's say 6 points. I will not draw all of them, but just like that. So this is the graphical representation of the tree. But what it means basically for us, it means these objects are isolated from each other. They are located on different boxes. And when we assign one or another function to this data tree, these functions are work in a different order. Let's say we have we just want to move this point somewhere. So we use the move function. And in this, it's pretty simple. It's taking the first point, moving it on the parameters we have in this function, then taking the second point, moving it again, and it's stopped. So that's it. It's pretty simple if we have just one vector for the move. So move function, it has, let's say, 2 inputs. This is our function. And this is our input for the geometry which we are moving. And another input in how we are moving, on which direction. So it's basically the vector. And if it's just one vector, it will be the same for this structure and for this as well. So, but the only difference in order, it's taken first, for example, this box, first this element, then go inside, etc., etc. But in the end, we will have all the points moving for one vector in the same way. In case we have a few vectors right here, which are different, it's a tricky part actually, because if they are in the list like that, so let's say it's 4 of them, and here we have 5 points. The first vector will work with the first point. The second vector will be work with the second point. The third with the third point, and the fourth with the fourth point. And for this point, we have nothing. And by default, we in this box we have nothing, I mean, and by default it's taken the last vector from the box. So there are several approaches in Grasshopper, but if you do nothing with it, it's just taking the last vector, and this point also will use this vector. Doesn't matter, there is nothing else for it. So this is one thing. But here is another situation. We have a lot of different structures, and here is just one point right here and a few vectors. And in this interaction, we have a lot of other points, but they are separated from it. So when we assign them to the function, we not consider any other boxes except the first one we take. So we first take this one and not taking into account others. So this just one point inside this box, and we have 4 vectors. It's always working in the same way. It's taking the box which has more elements. So 4 vectors are more than 1 point. And it's taking the first vector right here and the first point right here, and they interact in here. So this point moving to this vector. But then for the second vector, there is no point here. So it's taking the same one because it's the same approach as here. Is nothing for this vector. Okay, I'm taking what we have. So it's taking the last point from here, and it's again the same point moving to this vector. Again, for this, nothing. It's taking this point again, moving for this vector, and that's it for the last one. So basically, we worked with this first box, and then the whole function switched to another box. So it's now not taking into account this one or this one or this one. It's only work with this. And for vectors, we have no other boxes in the structure. It's considering now only boxes, not elements inside them. So if it's nothing, it's taking this exact box again. It's always like that. If we have more elements here, if we speak about boxes, it's just taking what we have. So nothing else for this box, we can take this with vectors. But then we go into the boxes. And now this, again, 4 vectors and 2 elements. First vectors go with the first point, second vector go with the second point. And for the third vector is nothing else. It's again, taking the last element we have here and working with it. And the same for this, taking the last element and working with it. So basically, we just work with 2D boxes. Then we switch to the third one, the same situation, then to this one and this one. And basically, it's if we speak about the graph function, what we did right here, it's the situation where we had just one box before with the several points. And then we created after the graph function, the box with the boxes. And in each box, we have just one point. And if we have the same situation with vectors, where it's just one box and a few vectors inside, and we need to move them with the move function. So this is the function. In this case, we take first, then this, then this, and this. And for these two, no, nothing else. It's just both taking this last vector. After the graph, we have basically the same elements here, but the result will be totally different because it will consider only one box first. And here is 3 vectors. It means the same element from this box will be moved 3 times. Then it switched to another box. And again, this element will move 3 times. So basically, if we had 6 points, in this situation, we just will have 6 points as a result. But here, 6 points in separate boxes. We will have 6 multiple 3, 18 points as a result. So it's totally different thing. I don't know, it's understandable or not, but this is how data structure is work in Grasshopper. And basically, this is the most complex topic for the whole Grasshopper. And when you understand it, you can work with Grasshopper freely. It doesn't matter you remember all these nodes or not. You can just Google them or find them. It's not a big deal. The big deal is understand how data structure is work inside it. And this is the quick explanation for the most complex topic for the whole software, let's say. And basically, when you go to the Grasshopper course or take it in the university, probably maybe 50% of this course will be about data structures. But we have no time for that. We just need to achieve the result, let's say. And basically, let's try to do that. Okay. Yeah, I will take the longest distances right here. And also, I go back to my simple list structure to make the flatten command right here. You can use flatten and graft just on the output or inputs of the nodes. And there are some nodes for these commands, but also you can just switch data this way. Here, I didn't use graft on the output because I also need this as a list. I don't need the graph right here. If I do it here, both my wires will be grafted, which I don't need. So basically, that's why I used not here. And then I will I'm gonna sort them, all these distances from smaller to bigger one. So distances I have right here, and this is my initial points. And I will again reverse this list. And I will need another one trick, which is so basically when I explained for you how elements interact and they take in if there is no elements on the other box for one element on the first box, they take in the last one always. This method called longest list, and by default it's just repeat the last element. But you can use another one options like interpolate, for example, or repeat first, or wrap, or flip. So basically, in this exact situation, I would need interpolate the elements to not always take in the last one, but take in like all of them if possible. So basically, I will take my points, which are sorted by distances right here. And then I will need another parameter, which is called number of connections for each points. And I will create it first. So basically, I probably assign it as a list. And I use this double slash to create the panel. And inside of the panel, I will provide this data, 5, 5, and 4. And right click on it. And instead of multi-line data, I will use line by line data, and this will be the list with 3 elements in the end. So right click and switch off multi-line data. Then I would need another sender, and it will be the parameter which I will call the number of connections. So connect it right here, double click again, and put it somewhere here. So it will be used this 554 and then again 554 for these 16 elements. Then for B, I would need a graphed output. And for A, I would need both list and graph. So that's why I, again, need to create a graph node like that. And again, I will find the closest points. So this is my number of connections. This is my points, and this is my points, to make all this situation more, let's say, random. Then I will create the lines between them. So this will be my first thing. And then here I have a lot of elements which I don't need. I probably call some of them, call index. And here I will provide set multiple integers and probably first 3 I will reduce 0, 1, 2. So it's like that. And instead of 5 points to connect, so if I just connect directly like that, I will have a lot of connections. It's maybe too much for me. So I will reduce them through this node to connect it this way only. So you can keep also more if you want, but I probably reduce first. And then I select all these nodes and hide them to have only the result right here. Also can hide this guy. So these my connections, basically. They're quite random. So I first use neighbors here, then a little bit sorted them in a different way, and again, find the neighbors through this node and connect them by the end. So we can also connect them after this node without all this part, because it's basically the same. We first a little bit reorganize them and connect them again. But this will be like really regular one. If I, for example, provide as a sample these elements right here, and we try to find all these connections. For example, I just put these initial points, and then I put, let's say, I have to reduce some of the points right here, but not all three, let's say, but for example, maybe even without reducing, let's say, I will connect this. So we will have really regular structure, as you can see, if we connect these initial points with what we have right here. And to make it more random, I a little bit sort them in a different way and then connect it like that. So then I will send this result and call it, let's say, edges of my final structure. And double click on it. And we will start the last part of the script. I will also put some points on these edges. I will use divide distance node in this case. And I will need a parameter for density of this thing. So basically, let's say by default, I will provide the distance like 2 meters, maybe even 1. And then I will create the parameter, which is called param density. Double click on it and connect it right here. Put the parameter somewhere here. I will use this color, right click on this group and use it as default. And from this part, I can already make a group. Control G, just select all of them and Control G to make a group. And here I will, just in case, make a flatten and remove all the duplicates points. Remove duplicating points, it's a part of the kangaroo nodes. So you can use this node right here. Then I would need my initial mesh, which I had here. Double click on it. And pull this point to this mesh, because these cars could be a little bit out of the initial surface. So I would need the pull points to this geometry. Pull points. So these points, this geometry I have. Just in case if they are putting on the same position, I again remove duplicates. And then we will gonna use the Dendro plugin. So this is the plugin which we have. And we will need these nodes to provide settings. Create settings for Dendro. And another one nodes, it's create points of the volume. It's this node. So basically we can connect settings already to here. And for settings, we will need, the main settings is voxel size. And basically I will provide another slider and size like something like that. And create a parameter, which is called param underscore voxel size. And put it right here. And these guys go to my parameter section. And another parameter which we need is voxel radius. And so probably I just copy these guys using the Alt button and drag them. And this will be a voxel radius. And the value for that, let's say 0.6. Double click, connect it right here, and connect our points right here. So we will have these bubbled elements. So basically, Dendro is the plugin which can create from point structure or from curve structure, kind of smooth and abstract geometry. And first, we need to create volumes from the points. So we had these points, and we already create this primitive volume, but it's not smooth enough. So first, we will convert it to the mesh. So for that, we can go to the Dendro and using volume to mesh. So volume, it's kind of uh, data which Dendro use itself. This data type not exist in Grasshopper or Rhino itself. So it's the specific type of the geometry. Like for example, we previously worked with sub-D, mesh, NORPs. I've shown a difference in between them. And there are some other types of geometry which are not exactly in Rhino, but some plugins can put it to the Rhino. For example, these volumes. And Dendro used this kind of type of geometry to create, for example, volume from the points. And this is the thing which is exist only in Dendro. And then it's kind of can manipulate it. You can smooth them somehow using the smooth volume. We will probably use it later, but now I just want to convert it to the mesh, which is like a normal geometry for Rhino. And I'll use this. And for the settings, I will use the same settings right here. So basically, it's my mesh geometry. And then I can hide all of this. I can quadrimesh this geometry. So this is the standard function for the Rhino, quadrimesh. But I also would need to use settings for that. So quadrimesh settings. And for settings, I would need to use a parameter which is called number of polygons in my case. And it will be, I believe, 1000. Not too much. And the parameter itself, I need, again, to use sender. And number of polygons. Okay, double click on it and connect it to the first input. It's my target count of polygons. And these guys I will put again to the parameter section. And then I will connect my mesh right here. So it will recreate it a little bit to this structure. And the only thing I need a little bit smooth it. For that, I will need Weaverbird, and there is Weaverbird Laplacian smoothing function right here. So level of subdivision, I will put 3 instead of 1. So this parameter, right click, set integer, or you can provide slider with number 3. And here I need smooth for the naked edges option. So it's by default like that. I don't need to change it. And the vinyl large shot thinking with the original mesh, it's also okay. Thin one is okay. So mesh right here, I will have the smooth mesh afterwards. And on top of it, I will also create a subdivision using Catmull-Clark subdivision here with the level just 1. And smooth. Yeah, this for corners will also keep us this. So basically, this geometry we have right here. And this is our final mesh result. So I will provide another sender right here and call it export and mesh. So I can hide this, double click on it, right here. So this is my another group in this script. And here is parameters. I make this color default and put them except of the import to the parameters group. And for the import, I have another color, make default. And this is my import group. And for the export, I have this. And I also make a preview for that, like custom preview, for example, not. And we'll use color picker. Color swatch better, probably. Maybe go to the rendered view, it will be better. So this will be like my result. If I'm fine with it, I can keep it as it is. And then I will create a layer. So here I have a few other layers already in this file. So basically I have surfaces for Grasshopper, just in case I will need them, but I'm not sure I use them right now. So I divided my sub-D to sub-D we created kind of together. I've shown them, and glass elements. So glass elements are just a loft between two edges of this sub-D. So it's quite simple to create. You just use edges and create loft between them, or you can even provide like a close patch, for example, for the NURBS and then convert it to sub-D. And basically this my glass, and these glass surfaces I use as inputs for this script, for example. And then curves is curves, which are default elements to create all this stuff. We also use this thing. Grids we also used, image we also used. So there are a few different layers. And I will create a new folder, which is called export. And for this folder, I will provide a sub, oh, not folder, layer. I will provide a sub layer using this button. And I will call it, for example, terraces. And double click on it to make it active. And this we can put to the group already for export and select this, right click and bake. And you can put it to the terraces layer and press OK. This is one way. Another way, you can just double click on this layer to make it active, select this node and press insert button on the keyboard, and it will bake it for you automatically. So now you have this geometry in Rhino. By default, everything you can create in Grasshopper, they exist in this geometry exists in Grasshopper, but not in Rhino. They like represented in Rhino as ghosted object, but you cannot select them. So in this case, when you bake the element, you already have it in Rhino. You can move it, you can modify it using standard Rhino tools. And afterwards, you can export it to Blender. For example, it's our goal. And that's why this layer called export. And inside it, I will have a few other layers. So first of them is trusses. And basically, I need such a trusses for all the other part of this structure. So I need to switch on this, for example, and instead of my surface right here, I can set one sub D selected before. It will think a bit, and I will switch off this, and it will provide for me these elements. It's not dense enough, I would say, so I can try to work with these parameters. For example, I can make it more dense. First, no, it's not good. let's keep it 1. But I will maybe change the voxel radius also. It's a little bit better. And I probably need more connections. Say, still thinking. No, it's not working. Let me check what happened here. Yeah, it's broken on this step. So here we have our mesh with a lot of connection. It's fine, but it's not smoothed. It's failed with this geometry. Somehow, let's try to skip this step then. Now it's better. The only thing here I have the level of subdivision just 1. Maybe I put it like 2 or even 3 to make it more smoother. But also you can play with other parameters to have a better structure and to work with this in the end. So basically, I probably go back to level of subdivision 1, connect this again, and maybe just change some other parameters like voxel radius bigger, for example. Let's see, maybe it will work. Yeah, it's working. And in this case, it's already too thick. But in general, doesn't matter. You understand the idea probably. I will not fine tune all this stuff. So you can play with the parameter to achieve the density you want, to achieve the thickness you want for these elements. And you will have the result, which is in the end quite nice. I would say here I already have a nice result. Here is not, it's too thick from my point of view, and you can change the radius, the size of the voxels, and maybe to achieve much better result in the end. So let's try maybe 0.5, like last attempt. But even with 0.6, it didn't work for smooth knot. I suppose it will not work right here as well. But let's see. Still thinking. It's okay. It's quite a tricky script for your computer. So no, it's not working. It's again with this not this problem, but yeah, you always can skip it. And oh yeah, it's basically even a mistake how I connected right here. So yeah, with this radius I have not a good structure, but basically. So after this, you can also try to increase amount of polygons or quadri mesh. Also could be an option. And also what I want to check, so here is looks fine to me. So maybe density of these points, we need them more dense, so like not 1, but I will provide number like that, and maybe 1 is the maximum for me, and the number will be like 0.4, let's say. Let's check this one. Yeah, with this densities seems better, but this not still not working. So the thing is why it's not working is somewhere here we have this kind of gaps and these small elements like that. It's also because it's not enough polygons right here, I suppose. So if we increase the amount of the polygons and make a maximum, let's say, like that, and the exact amount of polygons, let's say maybe 10,000, because this structure is much bigger than the previous one. It probably should work, but let's check. Okay, yes, it's working, and this was a problem. So this parameter, number of polygons, we need to increase it for bigger structure, and then we can put this mesh here, and we will have the result. So now I would say it's looks fine to me, and this is my network. This is the like first level of the network, because then we also create the netting in which is much more detailed inside of this network. And for that, I used Nuclei, this plugin. But probably we are already out of time today, and I will continue with this topic tomorrow. It's one more Grasshopper script which we need to cover. And basically, it's this one is not that complex. It's quite a short one. I will save it in our class, let's say, and I will call it, let's say, 01 trusses. I will put it on Google Disk after this lesson, or maybe right now. Let's just save it to show you where it will be. Okay, it's saved. I just probably have a slow disk, that's why it's saving too long, because the script itself is just a few kilobytes. And so what I have right here, I have the update of this 00 file. I will probably also save it like 00_1. And I will put both this Rhino file and this Grasshopper file we did to Google Disk. So where we have it, wait a second. So Google Drive, and I will go to the Rhino. And put this and this right here. So you will have it as soon as they load it. So it's already probably done. Yeah, and let's return to your question about prompts. So, for example, the question is, the prompts you are creating are quite elaborate and specific. Prompting strategy more or less unique to every model. Are there ways to find resources, strategies for prompting for the various models that are available? So yes and no. I mean, yes, there are resources for that. There are even like websites where you can generate prompts. And also you can use ChatGPT for that. Just provide a specific model you use and ask ChatGPT to create a prompt based on your concept, not just ChatGPT, any LLM, like Gemini you can use or something else. And Basically, they will provide for you an instruction and the exact prompt you need. But the thing is, I'm not really doing it often. So I'm not using, basically for most of the cases right now, I use Nano Banana Pro. So for me, it's the best model to do AI renders, architectural stuff, and other different things. So basically, before I used a lot of other models like Flux One, Flux Context, SDXL. Before SDXL, it was Stable Diffusion 1.5, Midjourney. So and yes, for them the strategy are different. But right now I'm using just one model, and I never used websites to generate prompts because the thing is, especially for Nano Banana, but before it was almost the same. If you use AI for renders, you already have inputs like images or screenshots from your 3D software or sketch, like a hand sketch, or like photo of the, I don't know, physical model to make a render from it. So you have already an input. And if you provide on top of this input detailed prompt, it will rather confuse the model than provide an additional information. Your prompt should be for AI render specifically as simple as possible. For example, if you on your input miss materials, for example, your screenshot without textures or something like that, you also need to specify materials in the prompt. Uh, if it means something else like environment, you need to specify environment, like this building located on the river and the forest around it. So, for example, something like that. But if you already have all this information, you just provide a simple prompt like make a realistic render from this image, something like that. And maybe you just describe light conditions and that's it. If, as I already mentioned, you miss something, you add this to this simple prompt, like materials for the facade are, and then you provide your materials. So basically, your prompt should be quite simple for AI renders. If you have a workflow like text to image, as we had in the beginning of this session, you just have an idea, and then you need to provide an instruction to how create an image from nothing, just from your text. So this prompt should be quite detailed. And I would say ChatGPT is a good way to create this detailed prompt. So you briefly can describe to ChatGPT your concept, and it will add, and then you can just ask, so I want to have a prompt for Nano Banana Pro, for example, or for SDXL, or for Flux 2, or for something else. And it will create for you kind of prompt. It will not work 100%. So I would say it depends on the model. Some models are really tricky with one or another prompt. And you probably will adjust it manually in some parts. And ChatGPT like to add details you don't want to have in the end, so you can delete them from the prompt. But for text-to-image process, if you need detailed prompt, you can use this approach. I would say it's a way. Sometimes I integrate LLM nodes inside of my workflow in ComfyUI. So it means in ComfyUI, I have like a initial node with the simple prompt like that, for example. And then another node with LLM model, like OpenAI model or something like that, it will take this text and change it somehow and make it more detailed or something like that. And it's already will be in the one workflow. It's also a way how you can do it in ComfyUI. So there are some nodes which are working with just the text, nodes to produce images, and you can specify how they need to change your prompt, and it could be a case as well. So this is the thing. Okay. Hi, everybody. We finished yesterday on this script, and we already made kind of structure in between our framework. And basically, I probably didn't pay attention on what the goal of this structure, but this small script actually doing a pretty simple stuff in the end. And our goal is, for example, if we have two beams and the net in between these beams, we need to somehow create this net randomly as we have right here. And for that, basically, we first created kind of polylines, just random polylines which are located differently. But if we just leave them like that, and for example, use sub D for them or something like that, they will be still so regular. That's why we use Dendro for that right here, because Dendro making this organic shape way better even than standard sub D. It's looks more random, more natural, I would say. And for Dendro, we need points. So we created a lot of points on these polylines from the beginning. And from these points, Dendro create kind of mesh shape. And then we just apply subdivision on this shape or some smooth modifiers. So this is the thing for whole this script. I probably didn't describe it this way yesterday. So, but it's not enough. We also need the second level of this network. And this second level will be much more dense and much more random, I would say. And just using the simple polylines before Dendro is not enough here. We need more complex structure, more random curves intersect each other, and also they should be much I would say the density of these curves should be much bigger than we have right here. So for that, we're gonna use Nuclei. It's another plugin for Grasshopper. And we will start with the new script for that. Just create file, a new document right here. We will see the same template. And by default, I continue working with this file we finished yesterday. And actually, we already have all the geometry we need right here. And this file you can find on Google Drive. So just in case, I will show you again where it is. So basically, I'm loading right now some other files, but we don't need them immediately on the second part of this session. We probably will need them, but I will tell you when they finish downloading and when you will start uploading them. So basically in files Rhino folder, you should have this file 00_1. This is the file from which I'm working right now, a Rhino file. This is our yesterday script for Grasshopper, but we don't need it anymore because we already finished it. So now we will create a new script from scratch. And basically, it's a bit of a similar as this one, but the approach is different to make network more complex. And so that's it for now, I suppose. Let me check another thing. So yeah, it's finished saving. I think I can also start to upload this file just to have it right here. Let me do that. Oh, sorry. Top. Okay, but we don't need this file as well right now. It will be necessary to have later. Yeah, so I hope you have everything because nothing new for now. All these files we had yesterday, and basically you just need this Rhino 00_1 3DM model and empty Grasshopper script, which is based on template, and a few plugins, which we also already mentioned yesterday. And for start of the script, we just need one import surface, which we have right here. So the same approach as we did yesterday. We need a container for this sub-D surface, and so it's right here. And we need a sender to send this information to the script, and I will call it import and underscore sub-D, something like that. So another parameter which we're gonna use later, but I will probably create it right now. It's just a simple slider. Let's say number will be 16, and the parameter name will be number of points. So it's PRM underscore number of points. This script will have just a couple of parameters, so we don't need something else. I think we will stop with just this. And for the sub-D surface, I have it right here, glass sub-D, and I will need this surface. So right click here, set one as sub-D, and it will be in my script. I can hide this layer again, and it will be more visible. And also I will add this guy. You don't need to do that. It's just to show you the names of the nodes. Okay, and I will start with this surface. Just put it right here. It will be my starting point. Then the same approach, I need to convert this sub-D to mesh because most of the functions in Grasshopper are not working with sub-D, just a few of them. And for mesh, we have much more flexibility, let's say, to work it later with it. And I will use this node, mesh from sub-D. And the quality, I would need coarse here. So right click on this input and provide this option right here. Also, the same as we did yesterday, we would need the framework from the initial surface. And we only need the outline, not this middle is a curse. We don't need them, only the borders of this surface. So borders are right here. It's naked edges. So naked, it means it's from one side not connected to the surface. For example, if we speak about this edge, it's connected from both sides to one or another mesh face. And for example, these borders are only from one side connected to the mesh face. So from the other side is naked. So that's why it's called it like that. And others are internal, interior edges. And these guys are non-manifold. It means, for example, it's connected to free edges or more in a free faces or more in a tricky ways. For example, if we will have this for this edge like a perpendicular face to it, it will be called non-manifold edge. But it's pretty unusual, so it's not a regular mesh structure when you have such an edges. But interior and naked is quite regular. So basically, we need right now our naked edges, and we will connect them together to one polyline. For that, we will go to the curve tab, so and find the join curves node. Basically, Grasshopper, if you never work with it, pretty simple if we speak about structure of this palette. So it's related to one or another type of the geometry. For example, here, all the nodes about curves. Here, all the nodes about surfaces, like NORP surfaces or B-reps. Here is meshes. And other tabs, for example, here's operations about intersections, how geometry intersect each other, different Boolean operations. And here is transformation, like moving, rotating, mirroring, etc. And this guy, it's about graphical and annotation stuff, like display something, assign materials, show dimensions, hatches, stuff like that. And a few first steps, this one about different inputs, like for example, sliders or containers for geometry, and these math operations like plus, minus, division, some formulas, etc. And here's its most complex tab. It's about data trees and data structures like lists, and create different structures like sequences, etc., etc. So these are not easy to explain quickly, but sometimes we using some notes from it to organize our data a little bit different way as it's provided by one and other functions, but it's the most important stuff to understand in Grasshopper, as I already mentioned yesterday. And here we have all the notes about points, vectors, and different primitive stuff. So it's like increasing complexity here: points, curves, surfaces, meshes, and then just a couple of editing notes and annotations and display. The rest are plugins, so you need to install them except Kangaroo. It's this plugin are already implemented in Grasshopper by default. It's physics engine, and it's working with different things like simulate something, collide objects, etc. So it's quite interesting. And also we have this kind of plugin. This is also by default here. It's to interact with Rhino scene to, for example, take layers from it and modify them, or take graphical settings and modify them. So this is also default plugin in Rhino and Grasshopper, and the rest you need to install. So you on my working computer, this is my say home computer. I have not so much plugins here, but on my office computer, I have maybe hundreds of them. It's a huge ribbon right here. So you use a lot of different plugins in Grasshopper when you're working seriously with it. So basically, this is the quick overview about this palette. And I think we can read. Why don't we make sub-D to polysurface and we make sub-D to mesh instead? So because it depends what you're gonna do next. So for example, Nuclei plugin, it's working better with meshes. So we just need mesh geometry right here, and it will be easy for us. And sometimes you need to convert to NURBS geometry. It's also fine. And it really depends what you're gonna do next. For example, Weaverbird plugin, also we gonna use it. It's only working with mesh. It's the specific operations right here to apply modificators to mesh geometry. It's not possible to apply, for example, subdivision knot to NURBS or solid geometry. So it depends what you're gonna do next. And in our case, mesh is better. And in the common case, if it doesn't matter for you, for example, the next operation working same way with the mesh or with the sub-D or with NURBS geometry, you either not convert your initial geometry at all to not have additional operation, or you can convert it to mesh because mesh is just the fastest geometry. It's for this. To describe mesh, you don't need like powerful computer or something like that. And this is the fastest geometry you have in Rhino. So sub-D, a little bit slower, and NURBS, it's the most complicated geometry. It's really precise, but the cost for it, you need to spend more computing um, resources, let's say. And so in overall, if you don't care about precision or your function work the same way with mesh and any other geometry, better to use mesh in this case. So this is the thing. I hope this is the answer. I'm not sure I fully understand the question. Mm, yeah, and yeah, right now we have this mesh and we have the border of these meshes. So next, what we need here, we will send this mesh to other part of the script. So I will provide a sender here and call it W, which is prefix for workflow for me, and then mesh. So it means this information part of the workflow, I will not use it as an export for final result, or it's not part of the import of parameters. So it's somewhere inside of my workflow. And then I will need to create bounding box. So BB, it's a short key to find it, bounding box, and connect my mesh right here. So bounding box, it's a bounding box object, outline of your initial geometry, whatever you put here. And it's like a minimum box which can contain this geometry inside it. And it's working the pretty simple way. I suppose it's visible and understandable how it's working. And this is also common thing for any 3D software. A lot of different programs use bounding boxes to, for example, find a volumetric center of the geometry, or just to have like a space for this geometry or something else. So it's basically a really common thing. Then we would need to find the center of this object. And I usually use the node from the plugin, this one. It's from Heteraptera from here. If you don't have this plugin, because I probably didn't provide it for you, it's also possible to find on Food for Rhino, but you can use instead standard node, which is called area. So the effect will be the same. You can connect this or here. The only difference, this node just provide the center point right here. And also sometimes it's really necessary to use not the spatial center, but planar center or basement center. So basement on the bottom of this bounding box, for example, and it's right here. But in my case, I need just a simple spatial center. That's why area is also fine. And the difference is providing point and diagonal size of the bounding box. And here is provide point as well from here, and area of the object. So basically, why I don't use usually this node, for this sample, it doesn't matter because we just have one box, and area is pretty easy to calculate from it. But for more complex scene, when you have, for example, or more complex situation, when you have as an input to here, not just the one box, but let's say thousands of objects, sometimes you need to find centers of all of them. It will calculate areas also for all of them, and it's not that fast. So in these cases, doesn't matter. You can use area, but I recommend for future, for your work, install this plugin, Heteraptera. It has a lot of cool nodes, by the way, but in this case, I just use this first one, center. And in case you don't have it, just use area. And for this script, it's not much difference between them. So I will delete area for now, and I will use center right here. And yeah, by the way, in area, you should use this output as a center. So here we will use this one. You will need to use this one. Yeah, and this center, we will need to a little bit scale this bounding box because we need more space around this object to simulate, to have the space for simulation with nuclei. So for scale, I will use this standard node scale. And we will provide the geometry for scaling. We need to provide the center for scaling. That's why we use this node. And the factor is how much we will scale it. So let's say 4.1. 0.1, I just used to have a more precise slider. If I, for example, just put 4 here, my step will be like that without this digit after comma. So it depends which how many numbers you use when you create sliders. will be the same right here. Of course, you can change it afterwards, but this additional clicks. So you need double click on it, then change it there. So easy to just provide exactly how many numbers after comma you would like to have. So then I will select all these, middle mouse button and hide them, or use Control Q to like a short key to do that. So this is my scaled object. It's actually like that because I have rendered mode. It's kind of rendering the virtual surface under the object. That's why it's sometimes cutting objects from the bottom. I probably switch to just simple shaded mode. It will be more accurate in this case. So, and then we will deconstruct this box. Deconstruct box. And here we will have sizes like X, Y, Z. It's not exact sizes. It's actually domains. And domains, it's a coordinate of the beginning and of the end of this object. So it's from here to here, the size starting and the ending, let's say. And we have these sizes for all dimensions, like that. And we need these sizes for nuclei, basically, to construct our voxels for simulation. So basically, nuclei work in a tricky way. You need a three-dimensional network first, which is constructed from voxels. And inside this network, your simulation will be started. So basically, I need to construct voxels using this node and provide just these domains to do that. And then I will send this information to other part of the script. So I will call it W voxels. Something like that. This is the first thing. The second, we need to work a little bit with these joint borders of my initial surface. And I first need to create some points on it. So I will divide curve, this one. Basically, for placing points on curve, you have a lot of options. Not a lot, but three of them. Let's say if you go to the curve and then division, you have as a main things, it's divide curve, divide distance, and divide length. They're working a little bit different ways. So basically, divide curve just provide a number of curves, how many points you would like to place on this exact curve, and it's automatically make equal distances between them to place all these points. And it's working vice versa. So you have distance between points and you don't know the numbers in advance, and it's providing the points for you. And length, it's basically, so if you have a curve like that, so the distance, it's a long curve, and the length, it's like a straight line in between two points. So this is the difference. For example, for polyline, it will be no difference almost, or just a simple line. For spline like that, it will be a little bit different. Okay, and we already have the parameter, this one. I will copy it, number of points. Just double click on it and put it to n to have these points right here. So these points I will need in future as well. So I will send them to another part of the script, call them W points. Okay, and then I will need a graph node. And I would need to find the closest point. So this we already did last time, this operation, so closest points. So here is my graph, and here is my list from which I will find these points, and number of neighbors which I would like to find will be 5. So I can provide it, for example, like that, //5. So it will be the constant number. I will not use slider here, just like that. Or you can, instead of this, right click, set integer, and provide 5 here. By default, here is 3. So I need 5. And then I will delete the initial point, because in between these 5 neighbors, I have the point itself. So to delete it, I will go to call index. And here I will provide my list, and the point itself always on the first place, because the distance between uh, this point and the self-instance of this point is 0, so it will be on the first place always. And here is the list with the 5 elements for each point, if we can see that like that. So basically this is the list with 5 points. And this first point is the point for which we looking for neighbors. It's will always be on the first place right here. For example, if I check this list, you can see that this guy and this guy are the same. And then this guy is the same as this. So it's always in each list the initial point on the first place. And first place always has this index 0. So I need to call the object with this index. So to do that, I need to provide 0 right here. So I also can do that with the panel, for example, like that, to make it visible. Or again, right click, set integer, and provide 0 instead of connecting panel. It's up to you. And now we have only 4 elements in each list. And then I will connect my initial point with all these 4 with the lines. So I will make lines like that to create kind of network. So it will be like that. For each point, it found 4 closest points, except the point itself. And then we have these connections between each points and these 4. And these will be our edges. We will use them later as well. So I can hide all of these and group all these objects. Oops. I need to use this color by default. So this is first part of my script. And then I would need voxels and edges first. And basically, these edges, which I have right here, I'm gonna use as kind of attractors for my final structure. So it will be places where the density of the network will be like a maximum. And in between them, it will be like in the middle point, let's say it will be the minimum density in between all these edges. And to make these attractors for nuclei, there is a specific node for that, actually. It's right here, curve attractor for voxels. So I'm gonna use it this way. And so I need to provide my voxels, my initial network, which is in the bounding box. And I need to provide my curves as attractors. And then I will have kind of new voxels, which is updated with this information. And voxels are the same, basically, if we speak about their geometry, but they right now have kind of additional parameter, which is related to these attractors. Okay, and also I will need, again, voxels and mesh. So I'll copy this and this. And I will use this mesh as an attractor as well, because bounding box around the mesh also has a space outside of this surface. And I basically don't need to have network outside of this exact mesh. So basically, I'm going to use this mesh also as an attractor. So it will be a second one, and they will working together. And of course, this will be like more powerful, and this one like a common attractor for everything. But basically, to provide this information, I need another node, mesh attractor for voxels. And that's why we used mesh actually, because as you can see, there is no options here to use NURBS geometry or solid geometry or something like that. So it was a reason why we converted it to mesh. So basically, I will connect voxels, connect mesh right here. And then I would also need to provide a parameter for maximum range for attractor. And this kind of number. So I will provide something like that, for example. It will be my maximum. So it's kind of field around of this attractor. So we need some more space, because otherwise it will be just a 2D surface with all this network. We need a little bit more space around it to have simulation there as well. Okay, and yeah, for this, actually, we also would need to assign kind of behavior on top of these voxels. And to do that, we're gonna use, I think, this node, define voxel values. So right here. Okay, and we would need a multiplier slider, and I probably create a slider like from 1 to 10. You can use this syntax to create a slider with the specific borders. And from the beginning, I will provide multiplier like that. And when you connect it, you will see this additional input. This is basically standard node as well. It's located right here, value list. And this node has kind of function inside it. When you connect the multiplier, it's automatically connected also this value list. And by default here is a minimum density. I would say it's what we need. So it's basically, it will be vice versa. I mean, if we will use this network, here will be actually minimum density for us, which is also interesting. We can afterwards try both options and see what will be better for us as a result. So right now it will be minimum density. And then we need to kind of join this information together. For that, again, go to nuclei and voxel selection union, what we need to do right here. So this and this connect to each other. So the method is average. It's okay for us. So we can check maximum or minimum information from one of them. So average, I would say, would be okay. Yeah, and we need also another one, attractor. So again, copy voxels, and in this case, points. And we will use point attractor for voxels right here. Connect it. And for maximum, I will provide, oh, sorry, again, the slider, and the value will be, let's say, 5. We will afterwards try to adjust it. So basically, we have different power right here. So here is maximum 1 is by default. Here is 6, about 6, and here is 5. So when we start simulation, we can regulate all these sliders to check what will be better and more interesting for us. We also need to join spaces. In this case, we will join these and these. So not all 3 of them right now. And if we're gonna use these points instead of these lines, we will reconnect them. So it's our, let's say, second variant right now. And I will keep it right here because this will be my main variant. If it work well, I will not gonna use this. If it's not working well as I expected, I will change this to points, for example. So then, what else I need here? Basically, I need node which is called voxel positions. It's this one, extract voxel positions from here, and we will see the situation what we have after that. Also, we can try to check what we have with the points, not this guy, but this. So it's quite interesting as well. It's filled a little bit smaller. Okay. Yeah, and then what we gonna do? Basically, for simulation, we would need to use this node. It's a nuclei solver. It's our final goal to connect everything here. So we need just a button to reset it. It could be a Boolean toggle, for example, or button. There is a node which is called button as well. We would need our voxels. We would need our particles and settings. So all this information we need to provide. And basically, we already have kind of voxels, but we still need to adjust them a little bit. And it's still, this field is probably too much for simulation. I need to make it closer to the surface. And for that, I will, again, use my mesh geometry. Right here. I will deconstruct this mesh. It's not. Then I will find the coordinates of each vertices on this mesh. So after the construction, I have these vertices right here. When I use this button and I select one or another node, I only see the information from this exact node, not from the whole script. So basically, all the nodes which are light gray provided information to Rhino viewport if it's possible, because some nodes just without geometry inside, like number nodes or text nodes or something like that. So they not provides information to the Rhino viewport, but if it's possible, they do. And this guy allow me to just check the information inside exact node to not hide all the others and showing only this one. So sometimes it's easy. And even, for example, if these nodes are hidden, doesn't matter. If I select them, I will see the information if this option is working for me. So basically, it's quite a nice modern Grasshopper. I always use it. So then I need to deconstruct these vertices to XYZ coordinates. So for that, there is a not deconstruct point. Or just deconstruct. Yeah, it's called just deconstruct without point. Like that. And I gonna find minimum and maximum of Z coordinates. For that, there is a node which is called bounds. It's providing for me like a domain from minimum to maximum of Z coordinates of these points. And I will deconstruct this domain as well to have this minimum and maximum as separate numbers. This is the start of the domain, and this is the end. Also, I'm gonna a little bit randomize position of these numbers in the list this way. So this is not jitter. It's making the thing, for example, if you have a list with kind of objects like first object, second object, third object, etc. And after jitter, they just randomly some kind of mix in between each other. And there is a strength of this jitter in this input. You can provide from 0 to 1, where 0 is nothing changes, and 1 is completely change all the position. And if you have like something in the middle, it's only mix neighbor numbers, or this area start to be bigger and bigger when this input is close to 1. So this is the idea. And then I will use kind of approach with a little bit tricky, but let's try to do it first, and then I will try to explain. So I will use gradient right here. This will be start value and end value for this gradient, and this will be the position on this scale, let's say. And then I also change the preset to this one to have colors more like different. And I will use split RGB node. So this one. So here I have colors by the end. So gradient is working pretty simple way. You have start number for the gradient and end number. And this start number is color on the beginning of this scale. So it's green in this case. And end number, it's the color from the end of this scale. So it's red in this case. And then I have random numbers here. For example, if 0 is equal to green and 10 is equal to red. If I have here 5, it will be yellow. If I have here, let's say 2, it will be somewhere here. So basically, it's provide for me list of numbers, and as an output, I have list of colors which are related to these numbers. So, and then I split them to RGB, so red, green, blue channel, and this is the alpha channel. So basically, it's like that. And I will sort my initial points right here to the green, to using green channel. And then here I have almost 700 numbers. I will just take 20 of them. So for that, I will use sublist. And here it is. And here I will provide 20 as number, and 21 yet, because 0 also included. So 21 first numbers are here. It's random 21 points on my surface. There is a lot of different ways to take these random points. but it's one of them. And so I will use pull point node to connect these points to this geometry and find the distances between all these cloud of points to this 21. So here I have distances. And then I will again find the bounds between these distances, so minimum and maximum between this cloud and these points. And I kind of rearrange all of them. For that, I will use remap numbers. And this is my numbers, which I'm gonna remap. And this is my source limits for these numbers. So it's basically my minimum and maximum, which I had, and targeted from 0 to 1. For example, it means if I had numbers, in this case, I had numbers like almost from 0 to 10. So it's basically, here I have a lot of different numbers, 21 different numbers, but all of them in the limits from 0 to 10. For example, I have 0.5 somewhere, I have 9.5 somewhere, I have 6.8 somewhere in between these numbers. And all of them should match to the scale 0 to 1. It means this guy will start to be 0.95. This guy, 0.68. It's a simple situation right here. It's not that simple because I actually here have not a 0 as a beginning and not exactly a 10 as my maximum. So it's not exactly 0.95. It's maybe 0.97, 7, something like that. And it's interpolation. It's what remap numbers doing, basically. But in the end, I will have only numbers in between 0 and 1 because this is my target right here. And what else I would need is to little bit adjust them with the graph mapper to make this distribution of numbers more interesting. So, and for graph mapper, I'm gonna use Bezier graphic like that. And I will change it this way, for example. So what it means basically, it means if my number from here was 0.5 on an X scale, it's somewhere here. It's going this way, then going to this curve, and going here, which is 0.8. So my 0.5 starting to be 0.8. And I have right now no elements with the 0 value, because if it's 0, it's going to here, it's 0.3 start to be, and no with 1, because 1 started to be something like 0.6 or close to it. So basically my numbers have no such extreme positions like 0 or 1 anymore, and they started to be close to each other after this rearrange with graph mapper. So basically this is the idea. Why put it bounds in there? This I don't understand. You mean why this we're using, or what exactly? Okay. Yeah, we'll wait. Maybe you will describe your question in a more precise way, because I don't really get it right now. So then what we're gonna do with these numbers, it's use them to adjust our initial voxels, which we have right here. And to do that, we again define voxel values. We already use this parameter right here, and I will just copy it probably this way. And voxels we have right now, it's these voxels. So these are voxels. And I will disconnect the type, and I will disconnect the slider. So the type is again, could be something, we will check it later. And for multiplier, we will use these numbers. So for type, I'm gonna actually use right now distance from my objects, which I provide right here from my mesh. And this information will be adjusted with this mesh. So basically, we little bit make it not a huge cloud like that, but provided, maybe if I visualize it with this, it's actually not really visible, but maybe I'll switch with them. No, the cloud is the same. The thing is, it's not just points there. Each voxel has the information inside. Point is just the center of the voxel, and each voxel has additional parameters inside them, and they have kind of strength and possibilities where simulation could be or not. And these operations provide for us an opportunity to have more powerful voxels close to our surface, let's say. So this will be one thing. And another, we also need to copy these two. And we will use another parameter right here. The inputs, other inputs will be the same, but parameter will be, again, maximum density. And then I will join these voxels together. This way. And these already voxels I need, so I can connect them right here to Nuclei solver. All these guys I can hide. And then we need to think about particles and settings. So first of all, about particles. Basically, it's quite easy. We have these positions, and we can use them as kind of positions for our particles as well. But I gonna reduce them a little bit because it's quite a lot of them, and especially for starting positions, let's say. And to reduce the number of points here, I gonna use random reduce. This one, just connect it this way. And we need to provide kind of number what we want to reduce. So I will measure how many elements I will have here, list length, and this is the node for that. So I have 4,300 elements almost. And let's say I want to reduce them almost twice, something like that. So I multiply these two number like that. And I will connect it to reduce. So here I have just 1,900 elements. And these will be my initial particle positions. To provide these positions, I will need to have a node for that, which is this one in the particles group. So the first node, construct particles. And I only need to provide my positions right here. So vector and tag, in this case, I don't need. They will be kind of random, and I can connect these particles to my nuclei node. So it's fine. It's red. It's just not working yet, but it will be fine in the end. So I see number of particles right here. And the last thing what we need to do is provide settings to this node. And for settings, there is this guy voxel settings. So this is my node. And basically, it's just part of the settings actually. Also, we have settings for particles. It's right here. And we have settings for depth of the particles. It's right here. And also for division. So I believe this one. So then we probably also need these population settings and trail settings. We also need is this one, I believe. So go one by one. Basically, all these algorithms like nuclei, what they're doing, they have particles like, let's say, points, but we can represent them in any way. So points is like a basic agent, and they are moving somehow. And we have a simulation to show how they are moving. And sometimes they are divided by 2. And this guy can divide by 2, etc. And for that, we have these division settings when they divide in. But also sometimes they just die. It's a random situation, and it depends on the population and different parameters. And for that, we have these particle depth settings. So to define when they die and how, not how basically, but in which case, let's say, because of the too much of others, or they are too close to others, for example. So basically, this is the idea of this behavior. And yeah, basically this simulation working with these kind of orders, and we need to provide all these settings there. So first of all, we need to define our voxel settings. So there is a little bit of parameters here. They all defined by numbers except the last one. And I will provide just settings like that for diffuse. Let's say for range for now will be 1. For decay, we will have something small. And for wrap, you need to provide a true or false parameter. In this case, I will go with the true. So you can check each parameter if you just hover your mouse over this input, and you will see a little bit of description of each. So basically, also each node has a help, and the same description you can find here. And probably nuclei has kind of documentation. I didn't go into it with the better described parameters and inputs for each node. So in my case, I just experiment with different numbers, and also they provided kind of templates. When you download the plugin, you can see the folder with the samples, and from which you can find the set of parameters for different nodes. So let's say I right now just follow one another sample, which is working better for me. And I'm not going into all these inputs right here. So then particle settings. So here is basically a little bit more understandable, like speed, sensor distance, etc. So it's distance for other particles, angle, how it see other particles. It has a vector to move in, and also angle around this vector, how it see other particles rotation angle, because it's can change the vector of moving, etc. So basically, these parameters are a little bit more understandable, and tag is just a name, let's say, which you can use afterwards to check the position of exact particles and represent it on one or another graphical list, but we don't need these tags in this case. So basically, I will only provide other parameters. I need the speed, for example, something like that. Sensor distance, let's say, will be 5 meters. Then angle will be 45 degrees. Then rotation angle also 45 degrees. And deposit is will be 3, something like that. So then we have the parameters for division and depth. So I will start with division probably. And first we need to divide. They decide they will be divide or not. In our case, yes. So division range is how many new elements, let's say, we will have. Minimum parameter and maximum parameter for division. It's how many neighbors should be for this object to decide to divide. And division frequently, let's say 5 seconds. I believe it's seconds here. So the same for the die. Also, I will copy this node. It will be true again. And parameters will be kind of more or less the same. So die range will be 2. Minimum and maximum we can provide 0. If nobody close to it, it will die. And die frequently, let's say 12 seconds. We not them too often to die. Population, like minimum population and maximum population, it's how many particles you have simultaneously. Let's say minimum will be 5 and maximum 30. And trail, it's a kind of trail behind the particle, which it's left leaving after it when it's moving. So you can provide the length of this trail with the trail size. So let's say 50. We need a long lines right here, and frequency is 5. So these all are settings. We need to connect these parameters to the settings using Shift, holding Shift button to connect all of them right here. Oops. Okay. And basically, it's almost all we need. Also, to represent outputs, we need a couple of nodes afterwards. First of all, it's trail positions. Let me check where it is. Yeah, extract particle trails, this node. And we just connect particles to it to show this guy. And yeah, then from these, we're gonna create a kind of curves, because here we will have points by the end. And to create these trails in a more interesting way, we will create kind of curves from it. So for that, we need a interpolate curve. I will flatten the result. And also, this probably will be kind of tricky tree. We cannot connect it like that because otherwise they probably will be in the separate branches of the tree. So here, just believe me, and I will prune the tree a little bit. Use this standard node. And here I provide a slider X7. It will be my minimum. And after I can create my curves. So basically, this is the idea. Let's check. To launch all this stuff, we will need a time trigger. Is this not? And we need to provide interval, let's say 10 milliseconds, connected this way. And so I need to reset this parameter and try to launch this. So let me check. Yeah, now it's working. I need to hide all this additional stuff, I believe. What else I have here? So I can see how this simulation working right here. It's connected to my surface, which is nice. Attractors are working, basically. So if I reset it and launch it again, you can see the starting position outside of the surface, but afterwards, it's going to work only with this surface, which is nice. And to make from these curves kind of mesh, we this not enough. We will use Dendro in the end. So basically, what we gonna do right here. Let me check one stuff. So yeah, we have a lot of cars. This is nice. We can just directly connect them to Dendro. But for that, I believe we need to also provide some points with. So first of all, these curves are kind of irregular, let's say. Let's make it, let's make all of them more smooth. And for that, we can just rebuild them using the rebuild curve node. And here by default, we have 10 points. I think it's good enough for us. So it are initial curves and this after rebuilding. They're similar, but here they're more flex, let's say. And then on each of these curve, I will create points like that. So basically better to disconnect these guys actually right now. Maybe right now I connect them, but in future I will show you we will disconnect them because first you need to run simulation and then all these operations because otherwise it will be like a real-time apply and all this function for changing elements and it will be too slow. So this operation right here, we will disconnect later. But for now, to show the freezing result, I will do it this way. And we need a lot of points, let's say 125 on each curve to make this network dense enough. Then we need to pull this point to our initial mesh. So maybe we flatten them first. And the mesh we have, for example, right here, I will copy it. So if you don't remember, for example, where your sender located, you can also just take a receiver, right click on it, keys, oops, keys, and find your mesh like that. Or you can find replace key names. If you know the name, you can just search it. So basically, now they're exactly on the mesh. And if we have some copies of the points, better to delete them. I use Kangaroo for that. So check. It's deleted 5 points, let's say, which is not bad. And now we can use the same operations which we did yesterday with Dendro. So I will go to this plugin. And first I need to create volumes from these points. So I will connect my points this way. Radius, let's say, will be something like that. And I would also need settings for this guy. And for settings, mainly what I need is the voxel size. I need it smaller than 1 meter, much smaller. So then I will smooth this volume. We didn't do it yesterday, but this is a kind of operation which you can use to not smooth the mesh afterwards. So basically you can smooth the initial volume. And then we need to convert this volume to mesh. This we did yesterday. So basically this is our volume and this is our settings to do that. And we see already this mesh right here. Then I will take from this mesh only edges to have this network. So I will hide all these elements. So I have this network right now. And then I'm again going to use Dendro. And there is a node here to create the volume from edges, from curves, basically. So I will use this curve, radius also kind of small. And I would need to have a new settings. I will copy these guys. But make it probably even thinner. Oops. It's vice versa, it's actually thicker. And then I can create again a mesh from these elements. So this we already know. Can copy these. Settings right now is these settings, and these are mesh. And we can do custom preview. And also maybe better to use this organized to create a parameter like expert mesh. This is my second group. This is my input parameter, which I only want to change. It's my initial phase, and here is my export. We'll save the script for you, and where it was actually. Recording, yes, will be available, of course. I believe tomorrow or after tomorrow you will have this. So let's say I will call it 02 net, something like that. So basically, yeah, as I already mentioned, we better to disconnect these guys right here and maybe just show this. Try to reset it and play it again. You know what? Maybe stop. Maybe I connect it right here and disconnect it here to show this guy. And for example, I will stop somewhere in this moment to have better network. And then I can try to connect and wait a little bit because all these meshing operations in Dendro are quite expensive if we speak about computing. So let's check what we have, something like that, not bad. Yeah, this is, let's say, our result. So you can experiment with that a lot, of course, and try to run it again and again. So basically, what you also can do here, it's something like that, maybe, and like that. The group. So this is just a container for cars. It's doing nothing. But what you can do here, it's internalize data to have this information right here. And for example, when you launch the file, I just save it on my computer right now. I will share it later. So when you launch this file, it will not affect the result because if you just disconnect, you have nothing here and you will not see this result anymore. If you still want to keep it and launch another approach, let's say, and check it again, you can do that and then reconnect it instead of this to check the result, and you can always have the previous one. So to keep the lines right here, you can always create a new container, then right click and internalize data. So now you have this cursor that you have right here inside of this node. So basically this is the simple option how you can keep the information. There are some more tricky ways in Grasshopper, but we know not go into it right now. So basically I will probably save it again in this position, all these nodes. So, and the idea is you next need to connect another surface, and all of them one by one to have the final geometry for the whole structure, and the same for trusses. So trusses, we did it yesterday, and you first all the surfaces you want make with trusses, and then all the surfaces with this network. So basically, this is the idea. So let me check all the files I have and put them together on the Google Drive. I have in Rhino already yesterday files with trusses. This is the final Rhino model, which already has all the trusses and all the nets and the whole geometry of this structure, let's say. So this is quite a big file, but you can download it. And the script I did right now, I will put it here as well. So now it's also here. This is the script, basically. And this script based on this Rhino file, which we did yesterday. So basically this Rhino file we used for both this and this scripts. This is our initial geometry framework, let's say, which is without some details. This is already with some details, and we did the scripts on these files, and this is the final result. Let's say with all the scripts already applied and baked. So basically, this is the final Rhino model from which we will start our Blender part. But before that, I would say we can make a break right now. So before we go to the break, start downloading some files. So basically, you can download Rhino if you want, but you don't really need it. What you need is the Blender folder. So here is a folder with the exported geometry from Rhino already. I will show you how to export quickly, but do not do it for all the geometry during the session because it's time consuming. I prepare the folder for you. Just load this whole folder. And also we have a Blender template. This small file you also need to download. So basically this Blender folder, please download the whole folder. It's important for next part, let's say. The rest you can download later. So quick question, how did you change the Grasshopper cables layout to... for this, I use plugin. So basically, in my Grasshopper, there is a couple of plugins. Oh, where is my? So it's, for example, Snapping Gecko, but Snapping Gecko is just for snapping nodes to have these elements. And for wires, I actually is this plugin wires renderer, but I'm not sure this is the name of this plugin actually. This option which this plugin will provide for you, it's not a default option in Grasshopper, but how plugin named, I actually forget. Let me check. Maybe I have it in the components folder. Yeah, it's wires renderer. So this is the plugin. You can find it on Food4N, I believe. So basically most of the plugins you can find there. So just wires renderer. And then if you have this plugin, you go to display and these are options to how to represent your wires. So in my case, it's an electric wire, for example. Okay. Yeah, just download the Blender folder and let's say we go for 15 minutes break and we will return in 5:45. So Okay, let's continue. I think, yeah, I hope I didn't miss any questions from you. If I did, please repeat it just in the chat and I will try to answer. So basically, for Rhino, it's almost everything what I would like to cover. The only thing is left, it's how to export geometry to Blender. And basically, whenever you want to export anything to software for rendering, you need to prepare the mesh geometry for that. And for some part of our model, we already have mesh geometry. So for trusses and for this net, we made the mesh from the beginning. But for other parts, we either work with sub-D or even with the NURB surfaces, but mostly with sub-D, I suppose. And better to convert it to mesh to just control it from the beginning, what we have right here. And basically for that, I already shown you the method. When we compared the mesh NURBS and sub-D sphere, how to do that directly in Rhino. And there are command which is called mesh to convert your geometry directly to the mesh, but sometimes it's not the best way because the net mesh net they're kind of random. So basically, sometimes better to use just this method in Grasshopper. So upload your sub-D right here and make mesh from sub-D, controlling the density through this parameter. And here is coarse, but you can switch to fine or extra fine, depends what detalization you want to have for rendering. And you will see exactly the mesh you will have. And if your geometry is sub-D geometry, I would say this is the best method to work with. And you can just apply this Grasshopper node and then bake your geometry inside Rhino and then export. So basically for export, if I open the file which I prepared as a final one, so this maybe I also better to save just in case. Will be 2. So I had this Rhino file, which is on the Google Drive right now. This is the final geometry I have in the end. And basically everything already baked here. The only thing, the layer which is about this dense net, it's hidden because it's quite heavy. But right now I probably switch it on just to show. So this is the geometry I have now. Viewport working a little bit slowly, but still okay. So this is my final result in the end. And this is what I going to export to Blender. And to do that, usually people just export the whole model. So this is not the best approach, I would say, because if something wrong with your model, you will not really separate the problem. And better to export by materials or by type of geometry you have. For example, here I already have layers for framework, glass, this dense net, trusses, and columns. So columns, it's inside of this pavilion. We didn't really model them, but it's just a simple sub-D network, so it's nothing tricky there. And all this geometry I prepared in advance. And for the geometry which is not the mesh from the beginning, I prepared the export layers. It's framework, glass, and columns. So this geometry done with sub-D. I first converted it through this Grasshopper approach, which I just have shown you, and then bake it to these layers. And these guys already meshed, so I didn't copy them here. They are in the initial geometry layers. So basically, if you have such a structure, then you need to select this object one by one. For example, if I start with the framework mesh, I will right-click on this layer, select object from this layer. Oh, sorry. Yeah, it's actually correct. Yeah, it's hidden. That's why it's not working. So if I hide the geometry, let's say, and show the export, so I right click here and select the object, and I will see this framework I have. And then in Rhino, there is a command which is file export selected. It's right here. And for Blender, you either use object format or FBX. So there is a small difference between these formats. I prefer object basically, but for example, FBX keep the layer structure. And if you already have a specific layer structure which you want to have in Blender as well, you can use FBX. So this basically also an option for you. But I prefer object, by the way, and especially if you don't have any materials on your geometry, just export geometry and materials we will assign in Blender. This is the best way. Otherwise, materials will saved on a separate file in case you use object format and you would need to load them also in Blender. So basically, I usually don't have any materials in Rhino, so I just export geometry as it is. By default, of course, any object anyway has a material. It's coming from the layer or just from the assigned material you did for representation in Rhino, and it will also export to your folder, but you don't need to use it for real in Blender. So basically, you do it one by one, then you select another layer and export it as well. So that's why I have a few files on Google Drive, not just one for export the whole model. And then if I have a problem with one or another object during the import into Blender, I will exactly know what exact layer contain this object, and it will be easier for me to find the issue. The next thing which is important, these layers are divided by the object for which I will assign the different materials. So for example, here is the glass. And for all the objects here, I will assign the same glass materials in Blender. And it will be easier for me to have them separately for importing, because when I import them, they will be in the separate layer in Blender, and it will be easy to just select them and assign the material. So otherwise, you need to use another approach. If you export the whole model, you either need to some kind of assign material in advance to have this separation and then select by material in Blender, or just select everything manually, so which is not a good way at all. So basically, this separation also has an advantage if we speak about selecting object afterwards in Blender. It will be just easier for us. And yeah, this is the thing. I have a few layers right here just to export it. So basically, Blender I'm gonna use just to create environment, landscape around this structure, and also for rendering. And this is the main idea. Also, you can use Blender for modeling. It's a nice tool for modeling the structure itself, but it depends what tools you know is better. And also, sometimes you need elements not just for renders, but also for drawings. And in this case, Rhino, of course, more precise. And you can control here all the sizes, but I already told you about that. So what the difference between engineering software and software and for creating just 3D models for renders, for animations, and for different stuff. So basically, this one thing. And another one, we already actually can use this exact model for rendering if we gonna use AI. So with AI, this is enough information for us. We don't need exact landscape or something else. What we need is to make screenshots. So I prepared in this file some cameras, and also on Google Drive, I already saved these screenshots. They are located in the ComfyUI folder and then in the input folder, and you can see all of them. And basically, you can just switch between different cameras and check what you have and how to save the screenshot from Rhino in the nice resolution. Basically, first of all, you need to create a camera, and this is quite easy. You need to have this named views tab right here. If you don't have it, you go to these buttons and show panels and just check box, highlight this named um, views option with the checkbox, and you will have it right here. And then you just find the view you like. So for example, I don't know, something like that. And afterwards, you can either adjust some camera parameters, like for example, in the properties, you have a lens length. You can make it wider, like 30 millimeters instead of 50, or even 20. So it's up to you. If you make a really wide angle, like 20, you will see the result like that. It's like a wide perspective on the object. Also, you can set, for example, 2-point perspective camera. So it's a set view and then 2-point perspective. So in this case, you have no parameter for, no, actually you have one, yeah. You have this parameter. Yeah, but the thing is, in the 2-point perspective, you don't have inclination for vertical lines. So it's a nice architectural perspective, and sometimes it's a good way to represent your model as well. And if you like one another view, you just, for example, keep the camera as you like, and then you create a new view with this button and provide a number, for example, 0.8, something like that. And you will have this view. Then you can switch between them easily. And if you want to save the screenshot, you go here, then you go to the capture and to file. So this small arrow, and capture to file. Then you define the resolution for your screenshot and save it somewhere. When you press OK, Rhino will suggest you to pick a path on your computer to save the screenshot. And basically, yeah, by default, I suppose here is a viewport. You need to change it to custom and change the sizes of your screenshot. And sizes are important because, for example, if you use Nano Banana for rendering, for example, here I provided one of the screenshots, and here is my prompt, and this is the result. Basically, it's quite nice, and it's follow the structure exactly as it is. And this is the case when you provide exact aspect ratio as you have in Nano Banana. And this is important. There is a table. Actually, I can show you this official website. I can copy this link for you in the chat. Yeah, if you see just a recording, just pay attention to this name, and you can Google it, AI Google Dev. And this is the bottom of this page. So basically, here is the information about how to integrate Google AI models inside your own website or service or something like that. And this is not important for us during this workshop. Which is important for us is these two tables, Gemini 2.5 Flash Image and Gemini 3 Pro. So basically, this is about Nano Banana, this is about Nano Banana Pro. This official naming for these two models. And here is aspect ratios, which are supported by these two models. And basically, they are not exactly as this relationship. For example, 1 by 1, of course, this is exactly 1 by 1. But if you go 16 by 9, for example, this is not exactly 16 by 9. And you can check, maybe I'm wrong, but last time I checked, it wasn't. And basically, you need to provide a resolution for your input image for Nana Banana, which is exactly this one or related to this. For example, you can multiply it twice or triple times. So basically, it will aspect ratio should be as this, not like this exactly. So when, for example, you export an image from Rhino, you can use exactly one of these three resolutions, or you can multiply, for example, on 2.5 this resolution. So any multiplying factor is fine. It's only a matter that this and this number you will multiply both on the same factor, let's say. And afterwards, if you have such an image, you can provide it right here. Then you can pick the aspect ratio with the related to this resolution. And when you render it, you will have the exact positioning of the elements. You see how this line move into this. It's not actually exact because I suppose this I saved for Nana Banana 2.5. And here I use Gemini 3, not 2.5. So there is a small difference between them. And that's why I have this difference right here. But basically, when you save exactly with the resolution which is provided in these tables, they are different, as I already said. Uh, you will have exactly render as your input. And of course, prompt is important. It's this thing from this image, make a realistic professional studio photo of futuristic structure. And then you little bit describe a structure and materiality. Here, for example, I need a specific contrast. I need a specific materials here. I can describe it. But what is important, it's only this part. So this one from this image, make a realistic professional studio photo. Or maybe not photo, maybe a render, maybe something else. It's up to you. Or maybe diagram or like a stylish image with the specific style. So it's could be something else as well. And then you describe an object, specifically describe the materials because object is already here. You don't need to describe it again. Model will see it from your input. You only need to describe materials and light features. And basically, when you launch the render, you can achieve the result like that. So it's one of the options. You can also try to create an environment for a render. It's also possible. And for example, I did it somehow right here. Let me check. Mm. Yeah, here I have another prompt. I will copy it because here is, again, Gemini 2.5. This is the old model. And I'm interested in what we gonna have with the newest model. And for example, I will take mm, the screenshot from Rhino. Let me check where it is also. Let's say this one. Let's say this one. I need to switch aspect ratio to this, maybe 1K, and everything else is fine. Let's see what we have. Yeah, not bad. So maybe too much of crystals and different stuff around it. So it's not fully clean render, but we can try to adjust our prompt as well. So it's what we have right here. Mm, yeah, here's words like frozen, sharp crystallines, ice formations. So we basically see all of this, but maybe it's too much. We need to make this prompt more simple. And basically it's kind of working. So Um, yeah, the question is, do I use the ComfyUI desktop version or the cloud? With the cloud, you need to pay the subscription. Um, in this case, I use desktop version, but also I have a subscription for the cloud. Basically, when you use API nodes, like Nano Banana Pro node, it doesn't matter which version you are using because you will pay any case. And this is not the model which is below ComfyUI or which is like an open source model. It's the Google related model, and they are only provided this model as through API or through their own services. So when you use it through API, you need to pay for this model. Doesn't matter which interface you use, ComfyUI or something else, or like one of the version of ComfyUI. So basically, for API nodes, when you have this small thing with the credits on top of this node, it means you are paying for every generation, and this is the price. So it's $13, 13 cents, and or 14, almost 14. So basically, for one generation, you need to pay a little bit. And in this case, I just opened the ComfyUI desktop for that. And it's anyway not from your computer because this information going to Google server and then the result from Google going back. So it's up to you which version to use. Cloud version, it makes sense to use when you work with the open source models, but your computer is not good enough to launch them. So basically, all these models are for free. And if you have good computer, you can just work with them, on a free basis and pay nothing for them. It's like Flux One Context, Flux Two, um, many other models. So it's really a lot of free models, old models like STXL, Stable Diffusion 1.5. Sometimes they're good as well if you need not really realistic but more abstract result. Sometimes they're interesting. Gwen image, a lot of different models which are for free. And so you can use them if you have a nice computer, and you can use them in cloud, ComfyUI, if you just want to pay a fixed subscription and don't care about anything else. So I really like this model. Nano Banana Pro is paid, but it's quite good when you speak about architecture. If we will have a time at the end of this session, I will show you some my working samples, which project I did with these models, and I would say this quite cool. So then, basically, this what we can achieve right here. We can achieve more. Basically, we can adjust this prompt and try to fix some problems here. Right now, it's too graphical, not realistic, I would say, and it's about the prompt. We can try to fix it a little bit and make a better result in the end. But I don't want to really spend time to work with the prompt right now. It's easy to do. You just get rid of some words and add others. Nothing specific here. And no really tricks here. You can just experiment with different approaches. Mm, then we try to switch to Blender and try to make a realistic render, I would say. Then, Yeah, these images are on the Google Drive. You can find them in ComfyUI folder and then in the input folder. So it looks like no more questions. Then I want to show you about the character, um, which we had before. I've shown this guy to you yesterday when described the project itself. And this kind of character in the scene, which we can use as 2D object, or previously I just redraw it manually with the grease pencil, but also an option to make a 3D model from it. And basically in ComfyUI, there are some templates for creating 3D models. If you go to the templates right here, and go to the 3D model section, you will find a lot of different models. Some of them are for free and working from your computer, and some of them are API models. So basically, different developers. So the leaders here is Hainan. This is Chinese company who created the model for 3D models. Also Tripo and Meshi. I would say I don't see Meshi right here. Yeah, this Meshi. And basically, all of them are quite good. You can try different models to create 3D model, to create a 3D objects from your images or just from your text. And there are several workflows here. So I tried this one right now. It's working through API. You can see it right here. API, it means you will need to pay because it's not working from your computer, and it means developer of this model not provide this model for free. So basically, some of these models are for free. For example, this one. I know it's also API, but um, actually, yeah, this these are for free. This one as well. This old version of the Hainan. This very old version of the Hainan. Yeah, and the newest version, which is 3.1, right here, it's not available for free. You can also go to the Hainan website, and there is a possibility to generate a few objects for free. If you not do it professionally, but you just need one model or two models per day, so it's possible to do it there without payment. But interface on the Chinese language, this is maybe not easy to understand sometimes, and it's quite tricky how everything organized there. But anyway, it's still possible to do. So, but I will show you in ComfyUI to not go to this complex website. And so what you need to provide is your image. This is the node. I just added the template, nothing else. This is the standard template from this library. And basically this template I use right now. And what I did, so PBR, it means you will create a model with the materials. So not just the 3D model, but also textures on it. Then you can assign the face count, how many faces will be. So basically, more faces you have, more detailed your model will be, but more heavy, of course, and it's bad for the different scenes. So it's up to you. This is the standard value right here. I would say up to, it's also about complexity of your model. It could be much more complex object, or even not just one object, but a small scene. So in this case, you probably will need more faces. But in my case, it works well. So I would say I keep it like that. And by default, there, the model 3.0, I switch it to 3.1. It probably a little bit better, but I'm not quite sure about that. And generate type, you have low poly and geometry in normal. So low poly is the specific mode if you want to prepare your model for computer games or for just a low poly scene to not make it heavy. For example, interactive scene for Unreal Engine or something like that. And geometry, it's precise geometry, and normal, I suppose it's somewhere in the middle of these two positions. So I keep the normal. For me, it's worked okay. And that's it basically. With the parameter, seed is the standard parameter for any model. So it's just about random generation. If seed is different, you will have different result. So if seed is the same, when you run it again, you will have the same result. So, and this is how you control the seeds. Randomize, it means it will switch to another number when you run it again mm, by itself. So it's just automatically switched it to another number, random number. And this is the result I have right here. So not bad at all. Just from one image, it understands the background. It's, I mean, the backside of this object. And it's quite a good model. So we probably will use it. And to download it, you can just right click on this node. And here you have a save option and 3 different formats. Basically, this format with the materials inside. Object, I believe, will be without materials, and STL I didn't try. So you can also check this. So there are different options right here to save this model. So basically, this is how it's working. If you run it again, you will have a little bit different results. So, but I will not gonna do it. I'm fine with this. Okay, on the case of unable to start ComfyUI desktop, what do you do? Hard to say. It depends on the situation. Basically, there are some cases. First, I recommend to subscribe on official Discord of ComfyUI. So they have a Discord channel. I can show you quickly. Oh, that's not good actually. All the stuff what they want from me. So it sounds too complex. Probably here and here, yeah. Mm, okay, new location. Okay, now everything is fine. And they have this Discord channel. Can somehow copy the link. Mm, paste it right here. And here they have an announcements about everything. And sometimes when it's a new update of the ComfyUI, they also provide information uh, for what you need for this update. For example, a couple of weeks ago, they made an update which required to update your NVIDIA graphic card driver. And without it, it didn't work. And basically, when you launch ComfyUI, you have seen the message as you just described, like enable to start or something like that. And it was exactly about this driver. When you installed this driver, it was fine. But it really depends on the case. So sometimes it's something else. Sometimes it's just, I don't know, maybe conflict of your Python libraries or something like that. So basically, usually ComfyUI just can solve it internally. And when you launch it, there is a button for troubleshooting. And you can use this button. And if something wrong, it's kind of solve it automatically, install dependencies it needs. Sometimes it's about these updates. For example, NVIDIA driver was a case a few weeks ago. No, maybe I don't know what else it could be. It's no one recipe here, so it's depends. And they update the ComfyUI very often because every second week there are new AI models or different stuff, which is necessary to implement inside of this software. That's why they also should update it quite often. And some models require new Python libraries, new dependencies, new drivers, etc., new CUDA drivers, etc., etc. So basically, that's why sometimes it's problematic to launch, and yeah, it depends on the case. So it's no one recipe here, but you can find information here. If not, there is also here is chat, help part, etc. You can just ask the question. So basically, it's a huge community behind it, and you can find a solution sometimes. So, mm, okay, so I think all the questions are done. Let's switch to the Blender and let's start to do something there. I suppose it will be quite interesting. Yeah, Rhino, I believe I don't need anymore. I will close it. And for Blender, I just launch the empty file like that. And here, basically, I use my own template. So this template also on Google Drive in the Blender folder. And you can just drag and drop it right here. And to keep this template for the next time, if you will like it, you can go to the File, Defaults, and Save Startup File after you, of course, open it. So what this template has inside, it has structure for the collections. So there is collections is kind of layers. It's not exactly the layers as you have in Rhino, but we can make this analogy. So basically, there are four collections here: hidden lights, cameras, and collection. And lights and cameras for lights and cameras is quite simple. Hidden collection is for the objects which we want to um, kind of used to spread across of the landscape, like trees, stones, rocks, I mean, something like that. So we don't need to see the initial objects for population, but we still gonna use them. So basically they are hidden, but we use them in the script to have this population on the surface or somewhere else. So this is the specific layer for that. And this layer for my geometry. So I can copy it and create a few of them. For example, if I have landscape, it could be one collection for the one building or another, it could be another collection. So this is the simple layer structure I have right here. And this is the part of the template. Then I have here a few materials as well. But for materials, I will describe later, like basic materials like concrete, steel, glass. This stuff I already have here. And all of them are done without like actual image mapping, all of them procedural. And it's better to use such materials if you can, because it's easy for your graphic card to handle such scene without huge textures. And procedural materials are quite nice, I would say, in Blender. And if you can use them, it's better to use such materials. So I have a few of them right here for the basic stuff. And from some of them, we will start our work to assign materials to our structure. And there is no geometry here, so this is the empty file. Basically, what we gonna do first, it's exporting our Rhino geometry right here. So basically, I have this geometry already in this in one folder. Let me check. So right here, I have it. And these my objects I would need to have. So first of all, I need to select this collection for the geometry in the layer to have the new object here. And I have two options, just drag and drop. It's one option. And another option is go to File, Import, and I need to specify the format. In this case, It's object format. So basically it's right here, wavefront object. And then I need to go to the folder I have here. And then I need to select. So basically, I don't see the type here, but okay. I need to select only the geometry files. MTL files are with the materials, and they're with the basic Rhino materials, which I don't need basically. So I only pick the files with the geometry. All the other parameters, I believe, are fine for me right now. So for axis minus Z, up axis Y. I think it matches from my export settings, but let's check. So I just pick all of them and import. And we need to wait a little bit because we have a heavy geometry right there. Yeah, I think I shared the net object as well. Let me check. Should be in the Blender folder, object. Yeah, net is right here. It's just heavier and maybe it's loading not that fast. And this is the template, by the way. But if you don't have it yet, it's not necessary to import all at once. So if, for example, this exact file is still loading, import everything else, and you can later add some other objects. It's not a big deal. So basically, we have this geometry. To zoom it in, because right now camera rotated somewhere outside of it, you need to use the dot button on your keyboard, and it will be working as zoom selection. So if you select the object, for example, this one, then dot button, it will zoom on it, your camera. So basically, what I have right here, it's my geometry. And I'm probably gonna start with materials. So first of all, I will switch to this mode rendering to just show you the scene I have in this template. So a little bit working. So yeah, all the objects right now are like transparent because it's a default material they have. But I already have a light right here. And maybe I will switch back. I need to create a surface to have kind of proper shadows and reflection from the objects. So to see materials in a better way, to add new object to the Blender scene, to just create it from this view, you need to press Shift A. So Shift A, it's adding something to the Blender viewport, and it's working in any window, but in different way. Because, for example, when you Shift A on the node-based interfaces like geometry nodes or shading interface, you will add a new node this way, not the geometry object. So in different windows, Blender works differently with hotkeys. So the same hotkeys can be applied to different commands and work similarly, but provide different options for you. So here are objects which you can add to Blender viewport, and basically we need a simple mesh plane. This one, I will pick it, and all the objects which you add to Blender, they are put into the 3D cursor position. So 3D cursor, it's this circle basically, and by default it's located from the internal origin point where is X and Y axis intersected. So basically you can move it somewhere else, but we don't need it. We just okay with this plane right here. and I need to scale it a bit. To scale, use S button on your keyboard. You can see the scaling, or this command right here. So if I press escape, this also scale. And in the description, you can see the hotkey, which is S, shortcut, shift space bar, S. So basically, there are a few shortcuts for this button, but S, it's most common to use. And when you're working with Blender, it's a kind of software which you always use shortkeys. And it's kind of, for example, in Rhino, I'm not using them so often. But Blender, without shortkeys, it's not possible to work. There are a lot of commands right here, and to find them in different menus is not really a way to work here. So you need to use all these shortkeys. So Shift A, it's for adding object, and S right now we are using for scaling. So I will select and scale, and then I provide, let's say, 100 to scale factor and press enter. So this is my new surface right here. I will move it a little bit to the right to have the center of the surface in the middle of this object. To move the object, you need to use either this button or G shortkey. Also, you can see it in the description when you hover your mouse over this button. And when you use G, you start moving it right here. And to move it exactly on X direction, press X on your keyboard. And you fix this direction right here. So then you leave it. And this will be my surface right here. And also, I would like to move it on top to intersect with my structure to not have this gap. And for that, I will go to this orthogonal view. You can use these things, or you can also use numpad. You can see this shortcut for the numpad, and every view, every single view on this related to one of the numbers on the numpad. Like, for example, if you press 4, it's kind of rotate your perspective. 7, 6, rotate on the other way. 8, rotate this way. 2, and 1, 5, 3, 9, and 7 related to one or another view. So basically, it's like that. I will go with 1 to go to the front view right here. Then I press G to move my surface. Basically, yeah, this is the plane right now. And then I press Z to move it to this direction exactly, and a little bit intersect my structure right here. So it should be okay. Check on the perspective view. For rotating perspective view, you just hold your middle mouse button and rotate through it. So I would say it's good enough. We'll keep it like that. Maybe a little bit go below, but it should be fine, basically, and leave it like that. So if I switch again to this representation with the materials, it should be a little bit better right now. I already have shadows for my object right here, but materials are not nice at all. We need to check them and change a little bit. So for that, I will go to the shading tab. So there is a few layouts for your viewport, and basically all of them are possible to recreate right here because there are just a few windows in Blender. Not just a few, it's actually a lot comparison to Rhino, for example. And there are a lot of different menus right here. And we are right now in 3D viewport, but there are some other windows. For example, this is the outliner. This is the properties palette, and some other views you have in Blender. And the difference between these tab, it's some of the views are placed there instead of views we have right here. So it's just predefined set of views on each tab for you, but you can adjust the main layout as well. You can add one view or replace one view to another. So basically, it's up to you. But I just like how it is by default, more or less. By default, it's a little bit different because here is additional window for animation progress. I don't need it right here. I have an animation tab specifically for that. But I prefer to minimize the main layout with these three windows. And to work with the materials, I always go just to shading, not open the additional window right there for shading. And here is more windows I have. So I also zoom to this object. It's like that. To zoom again, it's a dot button on your keyboard, on your numpad. So you can use this. And basically, I also switch to this mode to see material representation. So this shading mode right here. And we can start with the materials. So maybe I just first of all select everything and assign something like white material to all this object. Not really working. Let me check. Yeah, it's not working this way. So okay, let me do it one by one, maybe. Yeah, this is better. So at least on the framework, I will assign white material, but let me check again. It's not working for all. Okay, it's working just with one object. I already forget this stuff. For example, white here. And it's enough for me right now. So I will start with basically the wireframe. I need to select it either in the viewport or right here. You can select the object through outliner. So you can select one object to another. So, and you can see the material right here, which is assigned to it. Blender has this interface for materials, which is not based like Grasshopper. And you can work with this way. Also on the properties palette, there is a material tab, which is more like normal interface to assign material parameters, but I prefer this one. So basically, when you select the object, you can see the material which is assigned on it. So in this case is white. Here is the number, how many other objects use this exact material. And sometimes object has different slots. So it's a more complex approach when for one object you assign different materials simultaneously. For one part, for example, one material, on another part, another material. And in this case, you have a few slots right here. So then you have also some buttons here to delete material, to pin it, to copy it, and to shield it. So basically, this is important to assign fake user to the material in case material not assigned to anything, and you want to close the software but keep this material. So when you close the Blender, it's automatically purged during this process, and all the materials which are not used will be deleted. So if you don't want to delete them from your file, you either need to assign material to the one or another object or to assign the fake user on it. So in this case, it will be protected from removing from your file. And this is the small panel, what we gonna use sometimes. Then we have this important menu. This by default in the object position. It means when you select one or another object, you will see the material for it. And it's quite simple. There are also world material. So basically, usually just one. So it's not a lot of them. And in my case, it's a world output. To this world output is connected sky texture. So it's this sky texture we've seen here right now. And there are some parameters for this sky texture. You can actually try to work with them. For example, let me show you some stuff. You can see these shadows, yeah. And if you increase the elevation of the sun, Oh no, elevation actually, yeah, should work. So shadow should be shorter, and sun will be more intense, of course, because when it's located higher, it's more bright, like afternoon time or something like that. And if you put this elevation below, shadow will be long until it will be night. So basically, it's working this way, and you can adjust this position as you want. Then it's, of course, sun rotation. You can rotate the shadow in different stuff. So it will be like that, for example. It's in the result. It's more or less rendering in real time, and you can see what you have. Then you have a sun size. If you increase the sun size, your shadow will be not that strong. And basically, bigger sun you have, it's like mm, cloudy weather, let's say. And when you increase the size, it's more like not a strong light like a summer afternoon, but more like a cloudy sun, and you have this situation like here. So basically, it's also up to you what you want to have with these elements. So basically, maybe to make it a little bit faster, I will hide a net for right now. Because for me, it's rendering not that fast enough. And to hide one of the layer, you need to press Shift and then click on this eye right here. So Shift you need to click because to hold, because it's nested structure right here in these layers. And if you press it without Shift, it's only hide the top layer, but you need to hide the whole structure. In this case, you hold the Shift and also press on this eye. So it's something like that. Okay, what next? And you can actually try to work with this parameter and check what any of them responsible. And for example, if you work with air, you can see the effect. It's more or less like that. If you work with aerosols, so it's also kind of interesting effect could be here. So a zone also. So you can check all these parameters and how they're working. Also, in the last version of the Blender, they implemented multi-scattering algorithm. It's for more realistic light. And we can probably try it during the render. Let's see. But right now I keep the single scattering. So for me, it works better as a presentation, I think. And we will keep it like that for now. So let's switch back to the object and select our framework. And we will try to make this material for it. So basically, I will probably start with the steel. I have the steel material right here. Should have at least. Let me check. Light brown glass, metal. Yeah, metal material. I'll assign this one. And maybe the sun is too bright. Let me make it less intense. Okay. Celebration right here. Yeah, I think it's fine. And go to object again. So this is my steel material. In any material, when you just make a like default material for the object, you always have this material output. It's basically the node which is doing more or less nothing. It's just taking all the information and assign the result to the object. Without this node, the result will not be visible on the object itself. So basically, you need it as the final representation of your work with the materials. And then in most cases, you will have this principled BSDF node, which is like a standard node to create shader with all the features like texture, reflections, and different stuff, bump, etc., etc. So basically, it's simple combination of these two. It's already enough to have a material. But here is a little bit more complex with this steel. We have like a random noise texture to have it not mm, same in all the places. And this is for reflection, basically to make it more interesting. And in some places, it's a reflection with like closer to mirror reflection, and the roughness of this reflection is bigger. So basically, it's how this material is done, and it's not really tricky, but I will not go into it. I better to show you some other stuff. We're gonna mix this metal material with something else to create a more interesting result, and we anyway will use all these techniques which we are using, which I used to create this metal. So first of all, I will copy this material and call it like maybe a framework, something like that. And then I'm gonna mix this shader with the self-illumination shader, let's say, to provide this light from the object. And to mix it, I gonna add the specific node, which is called Mix Shader. Shift A to add this node, and then you need to go to the shader, and then Mix Shader. So, and you can assign it to the wire like that. It will be connected automatically. So for the first input, I have one shader, and for the second, I will need another one. If I move the wire from here, it will be suggestions for me. But basically, you can also use the search from any shaders. And what I need right here, it's emission shader. So it's for self-illumination, let's say. And I put it right here. So right now, these two shaders, emission and principal BSDF, they are mixing together with the proportion 0.5. And because this shader is kind of more powerful, it's looks like it replaced the metal. And now we have this situation. But I don't need this exact thing. I need to mix them not with the proportions, but by mask. And here I will provide the mask, which define the areas for this emission shader and for the metal in the end. So basically, maybe I will group all these nodes, use Control J command. Oh no, not Control J. They change it. Maybe Control G. No, actually, not like that. Control G. It's grouped like that, but it's also probably fine for me. Maybe no. Better to see them. I will ungroup them. So before it was Control J to just. It's not selected. Let's see. I'm a bit confusing. But okay, it doesn't matter. So I wanted to create a group like that, but I didn't really work a lot with the new version of the Blender. They changed some stuff here. So, okay. Basically, it's just to representation our nodes. It's not important. Then what I need to do is a kind of mask for mixing our objects. And to do that, I first of all create brick texture. So brick texture, it's a procedural texture as well. So if I press Shift A and go to the textures, there is a few procedural textures which we can use here. And the first one is brick. So this one we will assign to the object to define some places for the lights, like self-illumination, and other for just metal. And basically, we need to adjust a few parameters right here. First of all, if I just connect it directly to the output, for that, you press Ctrl Shift and the left mouse button to this. You will see how this is not connected to the result output, and it's assigned like that right now. So basically, it's more or less fine, but sometimes you need to have a direction along the surfaces. And for that, better to use to unwrap this surface and use this unwrapping map for placing the textures. So to that, I need to select this object again, press Tab on the keyboard. So, or you can go to edit mode from here. So Tab is like a short key to switch between object mode and edit mode, but you also can just go here and press edit mode. Then I will press A to select all the faces for my object right here. So they're selected. The only thing is, yeah, I see one problem here. So let's press Tab again to go out from this object. And I will select the whole framework right here, the all object here. And I will try to press, let me check, Control J. No. Hmm. Let me check one stuff. Hmm. Yeah, seems like they changed one thing, but let me check it. It should be Control J, but somehow no mesh data to join. Okay. It seems already joined. It's fine. Okay, I just probably confused with the material. It's probably also assigned to the glass. No, the glass is default material, but it's like that. Let me check. Hmm. Yeah, I have something wrong with this framework, looks like. This surface, which I don't need right here. But no, it's fine. It should be like that. Okay, let me keep it like that. It's okay. Yeah, basically it's just somehow represented wrong, but it's more or less fine. So what I want to have in the end, I would like to unwrap this surface, and to do that, I press U or you can go to UV, so it will be the same. And here is some options to unwrap the object. And I believe unwrap angle based will be the best in this case. So let me check. And here I have, let me, instead of image editor, here put UV editor to see the result. So this is our unwrapping surfaces right here. And then if you have this result, we will go back to the object mode, tap again. We can assign to the brick textures, like mapping textures. For that, select this node and press, maybe I didn't switch on this add-on. Let me check. I go to edit first and go to preferences. Again, yeah, edit preferences. And here is add-on part. There are some models of the Blender which are not switched on by default. And what we need here, it's Wrangler nodes. Yeah, it's switched off. So we need to switch it on. This guy, not Wrangler. It provides some additional features for working with nodes, either geometry nodes or nodes for shading or other nodes which we have in Blender. So I will close this. And then if I select this texture and press Ctrl T, I will have these new nodes right here. And here, instead of generated, I will put UV coordinates to the mapping. And I will see that now this brick texture go along my structure, not perpendicular to it. So this already better. And what I want to have else, maybe I can also try with the rotation. This even better, I would say. So let's keep it like that. And I will need to change a few parameters for the texture itself. First of all, I need, instead of these gray colors, white, because I will use it for the mask. And for mask, for me, important to have black and white zones. So it's possible to have a gray zones also where the shaders will be mixed. But in my case, I prefer basically to have a borders, at least for now, uh, between them, like more precise. And of course, for real brick, you need different colors because the real brick colors are not the same. And this is more realistic, but in my case, I don't use this brick texture for exact brick material. So basically, this fine. I also will change the scale. Say it will be 75 to make it much more smaller. And then I will reduce the size of these seams in between bricks. So make it much smaller, like this one. Let's say it will be really thin elements. Then I don't need to have an offset in between bricks. I need like a regular grids like that. And I need a brick size much bigger. So let's say I need like a stripes, not like a bricks elements. So let's say here will be 50 and here will be like 0.1, something like that. So now I have these stripes right here. I don't know it's visible through the video because should be visible when I zoom in. So now I have such stripes. So basically, this is already not bad, but to make it kind of more interesting, I will also provide a few other parameters right here. And on top of this brick texture, I will assign another procedural texture, which is noise. And it will be this one. So now it's not really interesting. It's just make it much smoother, but we will do it better, I believe. So first of all, I will change the scale to make it much bigger, also 25, and we will increase details as well. It's also not visible right now, but we will see the result later. So these parameters, I will pick something like that. So there is no big difference right now, but we need to adjust the noise texture as well. And to do that, because noise provide also like gradient colors inside, like gray colors, we will adjust it to black and white again. And to do that, I will use color range. So either color ramp, maybe, yeah, color ramp node. And this node allow me to make from these different gradients like only black and white objects. So let me check where it will be. So let's say something like that we will do. Maybe okay, let's see what we will have with this. So now it's like more, okay, keep it like that, for example. And then if I use this as a factor directly, so if I go with this and then put it right here, so right now I actually seems like have for for metal this thin white stripes. Oh no, thin black stripes for white material and the rest for the metal. So it should be vice versa by the way. And yeah, we can just invert this texture, but also I first probably do it with another approach. I will use mix color first. So maybe just search, I don't remember where it is. Mix color right here. And using the same factor like that, I will mix it with the checker texture. It's also texture checker. And for checker, I just use black and white. So go with B like that. So now it's already a little bit better. We have more metal here, but it's a little bit patchy. So I will need to have all this stuff in a more interesting way. So also to have not produce intermediate stuff, I will use another color map right here and maybe reduce the black like that. So keep it like this for now. I suppose when we finish it will be more clear why we are doing all this, but now it's probably not 100% clear. So then I would need another mix right here, another mix shader. So I will, for my emission material, mix it with something else. So to not provide the whole light for all this structure right here. And to do that, I just mix it with the metal again. So this is my metal right here. And for the factor, I will use ambient occlusion texture. So Shift A, maybe search ambient occlusion. Ambient occlusion is the texture which is, if I just connect it directly, it's provided the black color on the edges of the object and kind of white color in the middle part of the object. So where we have a narrow parts, it will be more like a black, and on the white parts of the structure, it will be more white element. And this I will use as a factor, but not directly as well. So I will again switch this mix shader on. It's already much better with this element, so we have much more metal here. But to be more interesting, right here, I also provide another color map, Control C, Control V, and put it right here. And then I will move it somewhere to this position to have more light on the borders. Basically, I just want to show you on another place with the light. So it's more or less still calculating. So it's not bad actually, but I don't see stripes as I wanted to see them. Maybe let me get rid of if I just connect this directly here. Yeah. Let me check one stuff. So I want to have more black right here. Maybe this will be more interesting. Yeah, these light zones are fine. In the end, the only thing they are not really working the way I want it. So basically, this is my factor. Maybe I just need to invert these colors. Let me do it this way. Yeah, this will be better. And probably I need to make stripes a little bit wider. So here I have this size. Let's make it like 1.2 maybe. No, it's too white. Hmm. Yeah, it's too white. 0.05, something like that. Yeah, this could be okay, I think. Yeah, this is better. So what we have here, it's and this is just a reflection, I believe. Yeah, maybe we don't need this checker right here. It's already too much. So I will connect without checker directly this element right here. And then, yeah, now we have these stripes. The only thing is I still need this guy to invert them. Mm, yeah, and checker I will delete. See, still calculating. Yeah, just in case I will save this file because it's seems like freezing sometime and who knows, maybe it will be go away from us. Okay, I will put it somewhere here. Okay, while it's saving because it's kind of heavy file, maybe we can make a small break for 10 minutes and we will return at 7:20 for the last session. We just need to adjust a couple of more materials. They are much more simple than this one, and it will be faster, I suppose. And then the landscape before the rendering. And landscape also, I will just show you some quick stuff to how to do it kind of fast. So let's make a break for just 10 minutes, and I will type that we will return at 90, let's say 25. Okay, so see you soon. Okay, let's continue. I think will be a last part of our workshop. I also added the new folder inside of the files Blender file. It's quite a small folder with the few textures which we gonna use. And basically these textures come in from website, which is not working anymore. I didn't expect that. I just wanted to provide a website for you. But I realize in my bookmarks when I tried to open this website, it's actually this one. So it's kind of not working right now. Maybe in future it will be. Just in case, I will provide a link for you because it's a really useful page with some 3D models for Blender as well and for other stuff. There are actually a lot of different websites where you can download materials for Blender and plugins for Blender and 3D models. So basically, it's not just this one. This one is quite a small from the private after, I suppose. But it was with some nice assets which I used. So basically, the most popular probably Polyheaven, just to show you this website. And you can find here a lot of different stuff in the assets. So it's textures and models, also some plugins. So basically plugin, it's related to this website to have a direct access to these materials from your Blender. But basically it's not only site, also for downloading something for Blender. There are a lot of different stuff. But you can start with this, especially if you just need a few materials and different things. Also, another resource which is quite nice, it's an official Blender website. So Blender, I just like that, blender.org. And here is, I suppose I've already forget where it was, but under Studio, free open source. Okay, it's just about Blender, but they had maybe in the store. No, store is just merch. No, I forget where it was. Download, it's download software. It's itself. Oh yeah, demo files right here. So basically, they have like demo files with really nice scenes. And you can find there a lot of assets, materials inside of these scenes as well. And you can just check how these scenes are created. So they are quite good, I would say, with a lot of different stuff inside. And you can see some scripts here for simulations, some samples for Grease Pencil. So Grease Pencil is a tool for Blender for 2D animation and drawings. And it's quite nice. So Eevee, it's a render engine inside of the Blender, which is I personally not use, but some people like it as well. I use cycles. It's more realistic, let's say, and a lot of stuff here. So basically, you can find some materials right here as well. I can copy this link for you also. Yeah, Walter Patrick already did it. So thank you. So yeah, basically. It's a few resources just in case you're gonna work with Blender in future. So let's go back. The small description about that. Actually, I tweak a lot of different numbers here, like scale and different parameters for the textures. It's not a point right here. It's actually all these parameters you need to adjust when you just see the result. And there is no predefined numbers which you know in advance. Okay, in scale, I need to put 132. It's basically depends on situation, and you can just check it and see what's happening. If you like the result, it's fine. If you not like it, you can go again and try some other parameter, something like that. And I'm not fully satisfied with the result right now. I had much better material in my predefined scene. I will share it with you afterwards, and you can check exact material I had there. But the point is to show you how to mix materials, basically. So this is the main reason for creating the things. It's basically I have the metal part, I have this self-emission part, and I have the mask for mix them together. And this is the whole idea. And what is inside of this idea, it doesn't matter. Instead of metal, it could be something else. Instead of self-emission, it could be something else. And this is the important thing, is how you can mix the different materials using the procedural textures as a map for mixing. So this is the thing I would like to share with you. And basically, everything else here, it's just about adjustment. You can tweak all these numbers and define the result you want. So basically, this is the thing. And here we have a texture, let's say. We have another texture to mix with it. And we have a color map to adjust gradient colors to just black and white or close to black and white. So it means, for example, if we have right here initial gradient of the colors from very black to white, like that, for example, and we move these borders right here, all was in the tones in this position should started to be black, and all was here started to be white. So it's the whole idea of the color map, and sometimes this really useful thing to assign to one or another textures on top. So basically, this is the first material. We want to have, let's make a second one for this network. So basically, I can start with just this default material output and the principal BSDF shader. And basically, let me check. Yeah, basically, it will be a really, really simple material. So for roughness. So roughness is the parameter of the material which is related to reflections. So if we go to 0, it's like a mirror. And if you go to 1, it's no reflections at all. So it's how rough your reflections on the one or another material. And instead of numbers, you can provide here a black and white map, where is, again, white is, I believe, it's like 1, and black is like 0. But you can check it afterwards. I can actually, maybe I'm mistaken, and it's vice versa. So we will check it after. And to do that, we can just can create another texture. And in this case, we will just use the real map. So it's like an image as a texture. And to do that, we need to add the node, which is texture node. And it's called image texture, this one. And to this node, you can provide the exact image from your computer. And in this case, let me check, did I provide it also for you? Probably not. Let me also put this folder right here. So it's just 5 images here, and they are quite light, so it's easy to download. And while it's downloading, I show you them. It's just different variations. We actually need only one of them, any of them, whatever you like. And these textures I generated with Midjourney. In Midjourney, there is a parameter which called tile. So if you ever work with Midjourney, I'm not sure I have subscription right here, but let me check. Should have. No, it's not what I need. me check quickly. No, I probably will not find my account right here because it's related to the office and I need another Google account for that. So basically, in Midjourney, when you have a prompt and after this prompt, you put something like dash dash style, something like that. So you will have a texture by the result. And I will not show you. So let's say this is your prompt, and then this is your parameter. And this will be a seamless texture, and you can download it and use it afterwards in your software. So it's a primitive way to do that, but in this case, it should work just fine for us. So basically, what I'm gonna do is open this texture right here, one of them. So I will probably pick this one. And I don't need color space RGB. I actually need black and white texture. So I will pick non-color right here. So this will be my idea because I'm gonna use this texture for roughness and also for some other stuff which is require black and white color only. And then I will also adjust it with the color ramp. So I can connect it like that and then Shift A and search color ramp, this one. So, and for the color map, I use this more like a gray material. Again, thinking, yeah, it's better. Something like that, maybe. And this one as well, not exactly white, but something like maybe this one. So this will be roughness. Let's call this material trusses or something like that. Check. Okay, I don't really understand why it's that transparent. So I'm gonna increase the metallic. Yeah, probably because of that. Let's make it like that. So now it's better. And yeah, you can see these reflections, they are not um, like regular in all places. So here is more reflected, on the other side is less. So it's because we have this texture, which is not like fully normal. But the thing is, when I connect it, it's actually looks not that good. So let's also apply Control T mapping to that. And also we need to go to the top, A to select everything, U to make unwrapping, and then we use unwrap angle based standard regime right here. You can see how this texture right now assigned to this unwrapped grid, and it's much bigger than that, but it's already visible a little bit better. And then I press tab again to exit from this regime. Still thinking. Yeah, and maybe I will adjust the scale a bit to make it much smaller, like 20. Yeah, now it's good. And readjust the shader itself. So we see these reflections right here, which is much more complex now. And the thing is, maybe I need to make it a little bit closer by color to have not such a big contrast between these two colors. So let's keep it like that. Let's say it's good enough for me. And also what I'm gonna do to assign the same texture, which we have right here, to the bump. And for bump, I have this normal input. And if I go here, I need not bump normal. Let me just search it. Maybe they also change it. Yeah, actually this texture is good enough. And because I have just black and white texture, I need to put it to height, not to normal. So height is a specific type of texture, which we don't have right here. And I just put this one to the bump. And bump is kind of relief on top of your object. And the strength, we probably will make it a little bit different. So distance, I will put 0, 0, 1, something like that. And the strength, a little bit less, like 0, 0, 83, something like that. So now it's better. And to make it even more interesting, I also add a displacement. So displacement, it's additional input on this material output. And for that, there is a node as well. So Shift A, search, displacement. So this one. And we again connect this texture to the height. And then I will connect this displacement to displacement. It's not really working right now, I believe, because we need to go to the material settings. Then, so basically, let me check where it is. Yeah, settings, surface, here is bump only. We need displacement and bump for this material. So right now it's working, should be. And you can see the result. It's like that. So it's in the material settings. Then you can go to the settings subtab, and here surface, and here you need to pick displacement and bump. And then you can check the scale and different stuff. For example, if you make a scale like 1, you have really extreme displacement like that. So if you make it what we had before, like 0, 1, it will be like normal one. So, and let's say this is our material. I was fine with it. Maybe so we can make it more dark a little bit. As well as I probably make this material darker. Okay, it's quite good. And basically the last thing I want to have is material for my net grid. So for that, I need to show it. Maybe I save it first. Okay, it's saved, and then I need to switch it on. And select it. So basically, what I have right here is material output and just a shader. So I will copy this because it's white right now. I need a new material. And still, I would like to keep white material in this scene. And I will call it maybe net, just like that. And in this case, I don't need this guy, so I will delete it. And I will put the new object from the volume, new kind of wire from the volume. And what I have here by default, emission shader. Don't see actually volume shader, so let me just type it volume. So there are some volume shaders in Blender. This one is most simple one. I will probably pick this for now. So what is the volume? Volume, it's consider your 3D geometry as a space for particles. And inside of this volume, which is more or less transparent, it's put a lot of particles, which is, you can imagine like a dust in the room where is the light beam. Um, if you observe this light beam in such a room, you can see the dust particles inside it. And this light beam, it's our geometry in this case. And dust inside is our particles. And we can assign the density for these particles. We can assign the color, but color is not for particles themselves. It's for kind of it's kind of filter. It's working like filter inside this volume. When light go to this volume, this filter assigned to this light, and we will see the result, by the way. So it's kind of mixed with actual light color and the color of this filter. So it's working more or less like that. So let's say we can create a very dense space, like 20 maybe, and the color could be maybe something like, I don't know, yellow. But you can see when I put yellow here, it's not the yellow result. It's more like blue because this color working as a filter. And we can try vice versa. Maybe it will be more interesting. Something like that. So this, I believe it's quite interesting result. So we have main trusses with this displacement, and this network we have this volumetric approach, and they kind of mix with each other. So it's quite a nice effect, I would say. And I believe we can keep it like that. We don't really need to add something else for materials. So it's fine enough. For the main surfaces, I will keep the glass material, which here. So let's work a little bit with the landscape. Right now with the materials, I can keep all the stuff like that. So I will go back to layout. And just in case, I again save this file because we already set up all the materials. We only need to work a little bit with the landscape. Okay, for the landscape, we have this plane. Right now, let's check some settings of it. If I press N button, it's N, just just this button, it will show for me this menu, which is hidden by default. And actually, this N button also working for some node interfaces to show the settings of the selected node or object or something like that. But here it's showing the settings of this plane. And what I'm interested for, it's actually the item settings. And here is the scale. If you remember from the beginning, we scaled this plane with the factor 100, and it's still here. And it means if we assign to this plane some modificators or I don't know, we will try to work with brushes on it. It will work with the initial scale of this object and consider this object like not with this size exactly, but with the initial size, because this scale, it's just another modificator on top of it. And we need to apply it somehow. So to apply it, we press Control A right now when it's selected and apply the scale. So Control A, it's a short key to apply some settings, let's say. So I will apply the scale, and now it's 111, so it's what I need. And I don't need this transform window anymore. I press N again to hide it. So now we're good. Then I press Tab to go inside of the edit mode, or you can again switch in between these windows to switch in from object to edit. And I press right click and subdivide this surface. And then I will have these parameters. So number of cuts, I will go to maximum, which is 10. And it's fine for me. So I then apply the result to click somewhere else outside of this surface. Then press A again to select all this thing, right click, and again subdivide because it wasn't enough. And again, I go to 10. So now I have this subdivision on my surface. So why subdivision is important? For example, when we applied to these trusses our displacement map, it's displacement map working with your faces or with your vertices of the initial surface. And for example, if we try to apply something like that or modificator which is working with the vertices to the initial plane without subdivision, it will not work because only vertices for working were on the corners. And doesn't matter how complex your displacement map, maximum what it can do, it's moving these four corners. And for some modificators, including displacement, we need to have a density for the object to work with a lot of different elements and different stuff. And also, for example, if I just want to make some relief or landscape here manually, for example, just select a few points and move them, I need these points to do that because if I just have corners, it's not enough. So for example, here is switching between points, edges, and faces for selection. So if I select points right here, I will select points object right here. If I select edges right here, I will select edges. It's actually not really, seems like I still selecting everything. Yeah, maybe just a graphical thing. Yeah, when it's actually selected in the right way. So to switch between this command, you can use 1, 2, 3 on your keyboard. So if you press 2, it's edges, 3 it's faces, and 1 is vertices. So I'm gonna work with vertices basically, and I select maybe one of them right here. And if I just try to move it, to press G to move this command, I will see this result. Maybe you don't see this. It depends on your regime of moving. So basically, I press Escape to kind of cancel this command. In my case, this proportional editing is switched on. So I have a few regimes for proportional editing. We did something like that in Rhino when we edited curves. But in Rhino, we have just about 3 different regimes. we still used smooth, and in this case, we also will gonna use smooth. But here you see the difference with the softwares. Softwares for kind of modeling with the more like artist or sculpting approach, like Blender. They have a lot of options for such things, and engineering software is not. But on other case, for example, engineering software has a lot of snapping tools and something like that, and here you will not find this. So there is a snap in here, but they're quite primitive, and they work in a really tricky way. So basically, I need to switch on this. So for that, just use this button. If it's not switched on, then pick the smooth regime, then pick one of the point, and then we will go with the G. And using the scroll, you can change the radius of affecting this regime. And using Z, you can fix the axis for moving. So I will create a couple of hills, let's say, in different places. So maybe I will get a little bit bigger here. Also G, Z, place it that. So G, that. So it's a fast method how you can quickly create a simple landscape. So let's say I will start with this right now and press Tab to finalize the result. Okay, this is first approach. Maybe I still hide the net to make it faster. Again, I press Shift and click on the eye to hide the whole layer. And then what we're gonna do next is go to sculpting mode. And for that, you can switch to the tab, or you can switch window to the sculpt mode. So I will switch to the tab specifically right here. And in the sculpting mode, you have a lot of different tools to do that and a lot of different brushes. So basically, it's you just need to pick one of these brush or there right here in this case. And for example, what I gonna use this case, maybe, I don't know, something like that. Let me check. It's not really. So probably for this brush is not enough density I have in this surface, but okay, let me check another one. So this better. To change the radius, in this case, you need to use F button on the keyboard, or this is the size, and also the size is right here, and all the other parameters. Of course, with the sculpting mode, is better to work when you have a graphical planchette on connected to your computer. With the mouse, it's not easy, and yeah. But basically, how I did these elements, for example, it's something like that. Can create them this way using sculpting. And you can try different brushes. Of course, if you make the grid of your initial surface more dense, you will see better effect. We still have not really accurate mesh, let's say, with a lot of details. So that's why our brush is working in a really rough way in this situation, but still can check how it's working. So maybe just add some small details like that. And you see this representation is not smooth for our mesh. To solve it somehow, you can go back to object mode, let's say, right click and shade smooth. This will be represented much more smoother in the end. So I will go back to sculpt mode and let's say I'm good with this result. I can keep these things like that. You can play with different brushes by yourself. And my recommendation, if you go with this tool, go again with this tab and maybe add some more subdivision. Right click, subdivide again, because more details you have, more vertices you have, it's better for working with the sculpting tools, and it will be much, much more interesting by then. This is not dense enough, basically. And yeah, I go back to the sculpt and go back to the layout. So basically, it's one thing. And another thing, for more details and the more complexity, we will also add a displacement for this landscape. But also before this, we probably create for us a kind of map where displacement should be and where not. For example, on these structures, I don't want to have this displacement. So basically, I probably do is the next way. So let me check vertex group. So I will go to the weight paint mode and I will create a new vertex group. Click on it and I will call it maybe a landscape. So vertex group you can create right here in object data properties and plus button, and you can see it. So then in your weight paint mode, you also have kind of a brush with a weight 100. Also, if you have planchette to draw instead of the mouse, you can regulate size pressure and strength pressure. So it's quite a responsive tool. You can really accurate work with hardware you have, let's say, but I have only mouse right here. So I would say I will maybe make the size bigger and I place my displacement right here. So maybe because with mouse is not easy to make the really different pressure everywhere, but you can work with weight as well and do it like that. So let's say where is the red? Right here, it will be the maximum displacement, and the blue is the nothing. So basically, it will be like that, and the green is the intermediate positions. So I'm good enough with this landscape map, and I go back to shading. And here I switch to object mode again. So it's still selected. It's white material right now. I will copy it and will call it landscape, probably. So like that. And then what I going to do right here is basically, oops, it's again thinking about something. Okay, it's fine. It's basically, I want to use mix shader node again. So search mix shader. So there is mix shader and mix color. This is the we used both already. And when you just mix the colors, it's, for example, before this node, you need to use mix color node. And shader, it's this guy is the shader. And for example, if you want to use already mix of these two, or emission is the shader as well. So you need to use this node. This is important difference, let's say. And for example, I put some kind of maybe red to see it better right now, and copy it. And for next shader, I will gonna use something like yellow. So they just mixed right now. And for factor, I need to use color attribute. Mm, so color attribute is not what I need, basically. We can also brush with the color attribute. So maybe I'm mistaken, and in the shader is not possible to use weight map, but let me check. Color attribute also fine. We can use this, but we need to brush it again. Mm, yeah, I believe weight map we can only use in the geometry nodes, not in the materials. So in this case, what I need to do is go to not the weight paint, but vertex paint. So I already a little bit forget this stuff. So vertex or texture paint even. No, I believe vertex paint. So let me check. Attributes, color attributes. Yeah. So in the color attributes, we have this guy attribute. It's by default here. It's like a layer we can brush there, and is the same as we did for vertex group. But vertex group, unfortunately, maybe I'm wrong, but looks like we can't use it in the material editor, let's say. We can only use it for geometry nodes because it's more related to geometry. And the similar stuff, which is called color attribute, where we can also use our brush. So I probably need a black color instead of white right here. And so here we can use the white. And probably I can switch to this mode. Yeah, and I need to brush the same way as I did before. So maybe use the gray color right here. So something like that. It will be, because it's, borders are kind of strong between colors. It's not good, but again, with the mouse, it's not easy to use. Also, you can try to change the strength a little bit and make it not that obvious, all these borders, but I'm fine. Just for demonstration, it's okay, I believe. And I can also rename it to landscape. Naming is not really important, but by name you can pick the color attribute from this node. So we can check. So landscape, it's right here. And it's basically working. So then I switch back to object mode. And this is my factor. If I go here again, I can see right now how these materials are applied. So where is the black? It was the red. Where is the white? It was the yellow. And somewhere in between as well, we have right here. So we can easily brush and assign two different textures instead of colors. We already did it with the displacement, and we see the result. But what I'm gonna do right here, it's also use displacement map, search displacement. Right here, use the same color attribute as a mask, but sorry, I need to actually check one thing. So yeah, for mask, I would need the first to mix colors before displacement. So Shift A, search, mix colors. My result will go to the height map, and for mixing these colors, I will use this mask. So it will be a factor. And let's say A will be just a white, and B will be my displacement texture. So I want to create a normal texture, like image texture, I mean. And then to put it to B, I will gonna use Control-Shift-T combination from the keyboard. So it's not working. Let me check again. Oh, I don't need Control-T, Control-Shift-T. Oh, why it's not working? It's image texture because it's already connected. Let me create a new one. I already a little bit forget some stuff with the Blender. Okay, yeah, I'm a little bit confused again now. Ah, you know what? It's yeah, I understand what I'm doing. So I don't need this image texture right here. I need use the principal node. That's why it's not working. So I need to select this and Control-Shift-T. And in this case, it will open the folder for me, and I can provide the whole approach for my texture. Let me show you how it works. So I just need to provide a folder. So this is the folder with a few textures simultaneously. I've shown you in the beginning after the break. And here is a few textures related to the same material. It's kind of displacement, diffusion, normal map, etc., etc. And when you use Ctrl-Shift-T on principal BSDF shader, it will open a folder for you. And if textures are named properly for Blender with these suffixes like div, disp, mask, it will understand how to use all these textures for this shader. So, and I can just use this button, and it will assign automatically all these textures to the node. So basically, this is the diffusion texture, and this place sRGB color space. This is roughness, is non-color, it's also correct. For all of them, the same mapping used. So basically, it's quite a cool tool. Ctrl-Shift-T, just select all the textures. Also, it's already provided the displacement for me to the height, but I don't need it here. I need it right there because I have displacement here. So basically, I can reconnect it to this way. So this will I show later. And this I will reconnect to the shader, let's say. This I will delete. And maybe this just for fun, we can make red. It's quite nice how it looks like. So we still have some bump and different stuff, but displacement still not working because the same thing, we need to go to the material settings, we need to go to the displacement, and instead of bump only, use displacement and bump. And let's check the scale. Let's say 10. Yeah, now it's for sure working. It's kind of extreme. At 100, it will be really extreme. So let's put it back to 0.1. And we have these additional details on our landscape. So everything is quite cool, I would say, right now. Okay, let's keep it like that. Maybe try to blue, check how it will looks like. Maybe red is more interesting. Okay, also we'll do it metallic, because let's say it's out of our planet, and this could be a landscape like that. Less roughness. So, and I think I'm fine with this material for the landscape. So let's go back to the layout. Check what we have. So it should be okay. So the only thing we need right now is put the camera and press enter. So I will switch to camera collection and then Shift A and add the camera right here. So as all the other objects, camera placed to this position, and we can actually adjust the view we like, and then I forget the hotkeys for that, but probably Control Shift 0. Check. No. 0. No. Okay. Yeah, there is a shortcut. You can Google it when you have a view, you can just press some buttons and camera will go to this exact view, but I don't remember that. So I will go in the other way around. I press 0 to go to the camera. So right now, this is my camera view. And then I need to go to the Shift tilde to switch to the mode, like a walking mode through my camera. And basically, so let me check. The camera frame is quite small right now. Let me also move it this way. 0. Yeah. So Shift tilde again. We'll go back a little bit to see the whole object inside the frame. Something like that will be good enough, I would say. So this will be my view of the camera. If I go outside of the camera and press 0 again, I will go back to it. So this is, you can always check the view. And maybe I will quickly save the scene right here. Okay, and I switch back to the collection, and I forgot to import my character. So I saved it in GLB format. I use this option for import. And then I have it in the folder right here, import it. So it's again, go to this place. So I probably just move it using G and Z. It's too small. I need to scale it, maybe 4 times, let's say, maybe twice more. So it's good. Then press put it here. So let me this smallest. Fine. Yeah, maybe closer to camera. Okay, it seems better. Something like that. I don't need to be that precise. Let's say this is our scene, and to render it, I need to go to the rendering tab. Basically, you don't care if something hidden on your scene because basically there are different options for hiding elements for scene and for render. And for render, we didn't hide anything right now. So we only use this eye icon, which is not related to render. It's only related to the viewport. And when we render something, it will be okay. Our net will be fine, and we should see it. So for render, I will use cycles with the GPU compute, not CPU. And for printing, I will use this resolution, maybe 100%. I don't need 6,000 pixels by the white side. So I would say this is good enough for me. And all the other parameters already fine here. I will keep all this like that. And to launch the render, you need to press F12, basically right here. And we just wait. With this shape, it's probably needs to have more details right here. It's not that interesting right now, but fine for explanation, I would say. So it use half of my memory on the computer is it's totally fine, I would say. graphic card memory, I mean. Yeah, you see, here you can see the progress. So it's number of samples. It depends on your settings right here. So it's max samples 100. And yeah, if you increase this, your render will be much slower. I would say for light scene with the direct sun, 100 is enough. So it's almost done. It's only need to finalize the result and denoise it. So I would say everything is quite good except these elements. This we need to make more detailed and more interesting. But the rest of the scene, all the materials, character, are quite fine, I would say. So I share this file for you. It will be in the Blender folder. And if you can make it more detailed and then share the results somewhere in Instagram, it will be quite cool. So I think I will stop right here because it's nothing. It's basically a lot of things what I can show, but related to this exact workshop, it's already more or less fine, I would say, and we can just add these details, but using the same techniques I already have shown you. I think it's not worth it to spend more time to just adjust the elements and finalize the result. It's not a goal. And for educational purpose, I think I have shown everything. And if you will have a time on a week, just make more details, maybe another view, another camera, maybe add your own objects or something else. So, and just share it in Instagram. It will be cool. So basically, that's it. If you have any questions, yeah, one more thing, how to save this image when you render it, you go to Image, Save As, and you can save the result. There is also the composing tool in Blender, but we will need another day to cover it. So, actually, it's a lot of stuff in Blender, and it's quite a nice tool with the complex modules, and you can do a lot right here. Animation, composing, materials, modeling. So basically, it's a lot of interesting stuff right here. Geometry nodes also, it's kind of Grasshopper inside Blender where you can work with geometry, and it's quite nice as well. So basically, we didn't touch all of these, but at least we already know some stuff about the Blender, so it's quite cool.
Well, thank you so much, Alec.
Mhm.
It was awesome 2 days.
Yeah, it's a question. Could you send a link to the resource you used to generate the 3D character model? I realized you use ComfyUI, but how can I find the specific resource to generate it? There is a template inside ComfyUI, so I can show it easily. It's in menu, browse templates, and I used in the 3D model this exact template. So if you just click on it, you will see this thing and delete second image and provide your image right here and launch. So the only you can use my parameters, which I've shown during this session. You will have a records. Tomorrow you can change a little bit these parameters and you will see the results. So it's quite easy. Um,
Yeah.
so
Thank you
looks,
so much.
yeah, thank you. I would.
Thank you everyone who joined and for this awesome webinar with a lot of information. And yeah, if you make anything, um, please share it, tag Alec and us so we can see it and also share it. And yeah, I guess just enjoy the rest of your day.
Yeah, thank you. See you next time.
See you next time. Thank you, Alec.